experience with energy behind the meter because we pay our bills, whether it's at home or in our offices. But we're going to talk a little bit about how energy gets to you and understand how the energy that you're using in your facility affects the grid as a whole. So we'll talk about some general strategies for demand side management and then review the general relationship between demand side management and distributed energy resources. So distributed energy resources is just a fancy term for renewables. So a couple of important terms, we got a number of different acronyms that you're going to see, and I'm speaking, throwing out a couple of this one. I hope to understand what they mean from the beginning. So DSM, so demand side management, is any management strategy on the customer side of the meter. So it's a broad definition, but it's just a saying that any place where we are managing the customer demand as opposed to the energy supply is demand side management. IDSM, Integrated Demand Side Management, is a comprehensive suite of programs that include both efficiency and demand reduction. We'll get into detail on what that means further into the presentation. EE, energy efficiency programs that are tailored to save energy, which are measured in kWh or kilowatt hours. DR, demand response programs that specifically manage electric demand that are usually measured in kW or in kilowatt. And then distributed energy resources are a combination of generation, storage, and load management. Now, just to go over a couple of the basics, energy is power over time. So when you are paying your bill at home, specifically for residential, you're usually going to pay your bill that is based on kilowatt hours. So kilowatt hours consumed energy use is called consumption, and for small billing, most of the time that billing is going to be in kilowatt hours. So power is the rate of doing work, and specifically for larger buildings, commercial buildings, industrial, power is also known as demand. And those demand charges reflect the infrastructure that is required to supply the amount of power that the building is going to need at any point in time. So a commercial bill is typically going to have both the kilowatt hour billing, which is your consumption, and the kilowatt billing for peak demand charges, or maybe some have facility charges. Okay, on the utility side of the meter, the supply is designed to meet the general requirements of an area. So the planners will use historical data for an area to look at the necessary supply capacity. So if there's a new development, the planners were going to look at how other developments that are similar in nature, so BPO to BPO, malls to malls, parks to parks, have developed over time, and they'll use that historical data to calculate the necessary supply capacity. And then they'll plan out the transmission lines, the substation feeders, the substation transformers, the individual circuits that are required to supply that particular load or area. But it is very, very large scale. So too much capacity means that you risk having supply failures because there isn't enough capacity to supply the demand. So we wind up with the Goldilocks capacity, the properly sized capacity that provides reliable power but also keeps the rates low because it doesn't have an excess of equipment required to provide the supply for that area. So most of the time, we don't think about the supply side of the electric grid. When we walk in our rooms, in our homes, in our offices, you turn on the light, you run an appliance, and when you are using air conditioning cycles, or depending on what part of the country you are, you are not really thinking of about all the infrastructure that is required to ensure that we can use electric energy when we need it. But it's there, and it's fairly expensive to build and maintain the network. It's important to understand how the demands aggregate that the customers of electricity put in onto the electric grid affects the way that the supply is being planned. So all the way that the way that the supply use distribution lines can cost more than ₱1,000,000 per kilometer, or a distribution substation of more than 50 million pesos to build. So it's usually not just a matter of saying we will just need more electricity. That's a very expensive proposition. It's expensive in transmission lines, it's expensive for generators, and it's expensive for substations. So it's important to match the supply to the demand in a particular area. And this is why demand side management is so important, and why it's such an important aspect of overall energy conservation. So increases in demand create a ripple effect back through the entire system. Here in Cebu, the major sectors are agriculture, fishery, we have industries, and we have tourism. So quite recently, our exports like furniture, steel scrap, semiconductors are trending alongside with the tourism and retail industry. So we've been seeing commercial food, especially on commercial food and beverages. So we're seeing an influx of commercial spaces and vacant lots, pop-up buildings, and are applying for additional demand on aggregate to the distribution utilities. So two key drivers of this growth in Cebu were previously by government spending on its build projects and the low lending rates. So with this, there are very, very large demand by businesses. We're starting to see that at the local circuit level, it ripples back up into additional capacity at substations, or possibly more generation in the short term. And all of this has the potential to increase the cost of electricity. So come to think of it, supply and demand. When there is low demand, the supply part will just follow, and it will bring down prices. But when there is increasing demand, the supply part will really catch up to the demand, and the prices as well will coincide with that trend. So in general, any type of industry or any change in the electric grid has to be considered all the way back to the generation. And when we're just using electricity as a consumer, we're not always thinking of how that ripples back and how it impacts the grid as a whole. So the previous administration has been on the BBB projects. In our new administration, the focus is on agriculture. So will the grid be more affected with this driver? We don't know. That's why we need to look at demand management. So the base load is very easy to predict. Once we understand what the base load for a building or a region is very predictable. So is very understandable and easy to plan for. Then there are daily load shapes that are different for different types of buildings or areas. So for example, a commercial office building typically has a very low demand in unoccupied hours, especially in the evening and towards dawn. So that's easy to project, and its peaks are usually fairly consistent, as well as industrial buildings through demand, though demand can change with production. So some industrial sites have almost perfectly flat load shapes where they have a very, very consistent demand 24/7. So other buildings might have seasonal variations depending on what type of production. So for example, there's one printing company that I work with, and their demand is lower in the summer, but it increases as you get into the bare months until February. So when they're printing a lot of leaflets or banners, catalogs for the holiday seasons to come. So there's a lot of different factors that can affect the shape of electric demand. Peak demand can be unpredictable, and coincident peak demand can also be expensive. So peak demand and coincident peak demands are, for example, several air conditioning units that might start up at the same time, or for example, industrial building, it might be a large air conditioning unit or an additional stage of chillers that is starting at the same time. So they're peaking on the same time. So as the large piece of production equipment, and if those pieces of equipment are all starting at the same time, it can create a very, very large coincident peak demand. And that creates a degree of strain on the grid itself because the grid has to be able to supply that demand. So it doesn't supply the demand. If it doesn't supply the demand, you will get brownouts or even blackouts as the demand exceeds the supply. So it can also be voltage drops, or worst case, the circuit breaker trips. So this doesn't happen very often in Cebu, and that's because of the planning that goes into the electric distribution system or even the transmission system. So, but part about planning is understanding how to manage that demand. So then system peaks are very expensive for everybody. So we all share the costs because of the additional infrastructure required to supply those system peaks. So let's take a look at this example. So I just simplified this one for purpose of presentation. So as you can see that during unoccupied hours, there is a base load here. Then let's say that the base load includes some sites like area lighting or even the parking spaces, the park towers, and some cooling equipment that needs to run just to maintain the building at stable temperature. So then there's also a morning peak, so which I'll talk about in a moment. So you can see that after that morning peak, it drops down and then comes back up to some variability, then leads up to an afternoon peak. So I've seen this load shape in a number of commercial office buildings here in Cebu. So we could use this as a general example for all commercial spaces. So there's a number of different ways that we can address these peaks. So the morning peak, for example, is caused usually because of the way that the building management is programmed. So all of the units are coming on at the same time, and that's creating the coincident peak that I mentioned earlier. And now that coincident peak is not as high as the afternoon peak because it's just bringing the building down to temperature whereas the afternoon peak is trying to keep the building comfortable throughout the day. So this is almost a predictable setup for those buildings with no management systems, or those who are really operating at manually with their cooling system. So now here's how that affects the system demand. So this is one of the uh, I got a summer season peak and a rainy period peak. So the lower line, that's the lower line, the orange. So the rainy season load are usually not too far from the summer season peak. So it has a little bit of a morning peak here and also the afternoon peak here. So somewhere at 2 p.m., 2 to 4 p.m., that is the time where our system peaks in the afternoon. And in the morning, it's around 9 to 11 a.m. So as we look at managing this from doing demand side management, we look at how we can reduce the kWh, or the kilowatt hour. So remember from the beginning, kilowatt hour is consumption. So kilowatt is demand. So the simplest thing to start with is an energy efficient program. So the energy efficient project will help reduce the base load. We also can reduce operating loads. So the daily load shape may remain similar to the load shape before the project, and it's been scaled down. It should be scaled down. So however, peak demand is still unpredictable. So some of the basic energy efficiency projects that can be done to reduce kilowatt hours are the lightning retrofits. So that's really a big one. So we are very popular in Cebu province and around the country, just taking old obsolete na mga light fixtures and replace them with new, more efficient ones. So for example, removing your T12 fixtures and replacing them with new LED fixtures can save a considerable amount of kilowatt hours. So another example from local LGUs, the replacement of sodium streetlights to LED streetlights. So then we have building management upgrades in scheduling equipment. So remember the morning peak that I presented earlier, that's something that can be addressed through scheduling by the building management system. And then it is also possible to add a variable frequency drives for motor loads to reduce energy consumption that way. So in our example project, we're going to look at what happens after they do a lightning retrofit, where the office areas were retrofitted to reduce demand by 50 kilowatts during the occupied hours, and a parking garage or a parking building when they reduce demand by 10 kilowatt hours. And also the reprogramming the building management system to ramp in during the morning instead of having that sharp peak. So in blue, you can see the original load where we have that sharp peak here in the morning, and then after the building management system was reprogrammed to ramp in the set points rather than simply switching them all together, the ramp helps smooth out the morning curve here. So this one, I got this from a mall in Liluan. So I just simplified this the right side of your screen. So that ramp again helps smooth out the morning curve, and it directly saves energy. So the end area between the blue line here and the orange represents the kilowatt hour savings. So think of this, this is an area where there is something that we could, that we have saved already. This has come from that simple programming. So it does not take much to program schedules to ramp in those set point changes a bit of a time. So in this example, the mall really starts to become occupied at 7:30. So because of the employees, the normal the 10 a.m. to 9 p.m., which is the mall opening hours. So rather than cooling down the whole building to occupy temperatures when nobody is even at work, they can slowly ramp up until we get into the occupied set points by the time that people are coming in. So with this, we could save a considerable amount of energy. So, and this is relatively easy thing to do. We're not talking about having to install a lot of new equipment. Just a matter of programming set points, and even in a building that has, for example, rooftop package units, individual zone thermostats, you can set up a schedule so that rather than switching from say 29 degrees unoccupied set point overnight to a 23 degree occupied set point, you could ramp it in and schedule different thermostats to start switching at different times within the morning, and thereby reduce that large peak in the morning and save energy. So now the lightning retrofits show up in different places. The first is the parking garage, and you can see that during the base load hours where the building is unoccupied, the parking garage still has to be on for safety reasons. And here it just didn't have a larger scale, but there's a 10 kilowatt reduction to the base load. So, and in the evening as well. So there's also a reduction of the office lighting retrofit, so that we have a from the 10 kilowatt reduction from the parking garage or the parking building, and the 40 kilowatt from the office retrofits or mga commercial spaces retrofits, give us an ample reduction during these occupied hours. So the area, again, the area between the two lines are really your savings. So you, for those now wala pa, for those that doesn't have any retrofit projects, you could somehow make an average profile of all your daily profile. Then once you do some retrofit energy efficient projects, you could somehow see the savings that you have. So for those that have already, maybe it is something that you already enjoy. So let's talk about a quick moment about the blended rates. So blended rates for large buildings reflect both the consumption and demand charges. So consumption is built in peso per kilowatt hour use. Demand is billed as the highest kilowatt recorded in a 15-minute interval in the billing cycle. So for example, if the building is using typically 900 kilowatts, there's one interval where all of the air conditioners kick on at the same time, and and probably production equipment starts off as well at the same time, then that one interval during the entire month sets the peak demand value. And if it sets 1 megawatt, you will be billed for 1 megawatt of power. This happens quite a bit, which is why we need to look at demand management, because there's a benefit for both the consumers and the utility. So I would like to remind again that the system peak is very expensive for all of us. So that's something that we have to think of. So as electrical practitioners, maybe managing a certain property, you have to do your part as well for improving the operations of your system. Because again, the system peak is very expensive for all of us. So in some of my cost saving examples, I'm going to use blended rates. So they're useful for quick estimate, but they're not always accurate because you don't separate out the demand charges and the consumption charges. So reducing overall demand has direct bill savings. So for first of all, in kilowatt hours, let's look at the base load savings. So we got a 10 kilowatt reduction from the parking garage after the retrofit. So for 13 pesos per kilowatt hour for 10 hours, so we might be for that day we might be saving a 1,300 peso for that day. So we got a 400 kilowatt hour saving from reprogramming the morning startup. That comes up to 5,200 pesos, and then a 50 kilowatt savings in the afternoon for the lighting retrofits. That's a 5,800 50 pesos for that period. So an estimate of around 12,000 pesos for the day. So you multiply it by 30, you will get a substantial savings by just doing the energy efficient problem. So the daily load shape remains similar before the project. You just scale down the profile. But again, peak demands can still be unpredictable depending on the operations at that moment. So that is where we'll start to look at active demand. So since the demand can be very unpredictable. So because the demand charges, we have to look at active demand because the demand charges by the grid is very fluctuating. So in the Philippines, the demand charges are relatively stable. So normally just a narrow bandwidth from 200 pesos to 230 pesos. So it just right now it just shoot up to 240 pesos. So, but in other areas of the world, especially those who have 4 seasons, so it can be very fluctuating for the demand charges. So we don't have any massive price swings for demand charges. So, but yeah, we don't know exactly what the future holds. But especially we are really dependent on fossil fuels. But on a typical day, the energy market prices increases towards the peaking periods. So I highlighted here the peaking periods. So usually after 12 noon up to 5 p.m. So just the shifts of the peaks will move around these periods. So with the M and this gray line are the market prices. So you can see that as we go through the peaking periods, as we enter the peaking periods and leaving the peaking periods, it's relatively low, but in the peaking periods, it's really, really high. So this is why I've said that the system demand can be very, very expensive for all of us. So with energy efficient projects implemented in our building, for example, there has been demand savings. So here, just if you could see clearly, the demand has been offset by a certain kilowatt, and there's the savings here, the space between the blue and the orange line. It has reduced the morning peak entirely and the afternoon peak by about 50 kilowatts. So we could say that the energy efficient measures are the place to start. So it's what you want to do first. Get the building as efficient as possible before going to more complex or more sophisticated technologies. And as you can observe, if we can reduce further even the peak demand by doing active demand management, we can save even more on peak demand charges and energy costs. And we could some indirectly contribute as well to the overall cost of improvement of the overall cost of energy and electricity in our region. So in the example, if we were to reduce that peak demand after our initial EE effort, energy efficient effort from 1.15 megawatt to 1.05 megawatts, we save an additional of 24,000 pesos for the month at recent demand rates. So all year round, it's gonna be 288 pesos. So as you observe, the 100 kilowatt demand that is being managed is not a huge amount. It's not a huge demand, but the savings are there. So the trick is to flatten out those peaks while having little or if any impact on the establishment, especially on the occupants' comfort. So what does it look like? So the orange line here is showing the load shape that did not change after our EE retrofit, energy efficiency project retrofit. And then we're showing an active demand management, the red line. So this is where some additional technology is being used to manage that demand and flatten it out. So what it does bring is that afternoon peak down, this one, while we're still using the same amount of kilowatt hours or the same amount of energy. The area under the red curve and the area under the orange curve are equal. So we just making some shifts of the demand, making a no difference in the occupants' comfort inside the building. So how do we do that? So what's the technology that's involved to make these kinds of changes? So this on the left hand side is the typical network infrastructure of the building management system. It's managing operations of the critical building equipment. And on the right hand side, this is an actual setup by one of our prestigious hotel in Cebu. It's a screenshot available controls of the actual air conditioning units. So we're just talking about the air conditioning units. So with the BMS installed, one can apply a swarm logic to hold off starting certain units while other units are still running. So that the peak demand is measured at the utility meter, can be controlled and reduced substantially. So one can have visibility to the detailed operation of every equipment and regularly diagnose problems. So if we go back here in the left-hand side of your screen, the building management system is not only for air conditioning units. It can also be for our mechanical and plumbing equipment. So energy management, demand side management, because all of this equipment, the pumps, will really contribute to the demand. So if we could control that operation, we could substantially limit our demand to the grid. So far, everything that I've discussed has minimal, if any, impact on occupant comfort. Because as you go back, the area, the energy is just equal. So in terms of the occupants inside the building, there is no substantial, they are not experiencing a substantial one. It's not noticeable on their side. So it has minimal impact on the occupant comfort. So I was just showing where the use of demand management technology can help reduce the peak demand charges while maintaining the same level of cooling in the building. So however, once that technology has been installed, it can also be used to provide demand response. So this is one key important aspect in managing our grid. So and demand response is very important for all grid, for the overall grid. So remember earlier we were talking about how the grid itself is a reflection of all the demand from all of the customers that are using electricity at any given time. So that demand gets reflected back onto the grid. Demand response is a way that demand management tools can be used to help stabilize the grid. So demand response is something that is only used when needed. It's not a constant change in demand such as you get from an energy efficient project. So it isn't a demand management tool per se, although it can use the same technology. So it's a resource that can be called on by the utility at points where there is peak demand that is potentially affecting grid stability or creating substantially increased costs for energy at a particular point in time. So one of the ways to manage occupant comfort while still doing demand response is to pre-cool the buildings. So this is a scenario. So this scenario, actually we have experienced it before in Cebu, where certain a group of establishments are requested to disconnect from the grid because of a limited capacity by the grid. So it can be a lot of reasons, can be mainly by the generation. It can be mainly that the transmission line is cut, or there's something that's beyond our control. So generally the supply side is out or limited. So this graphs gets a little crowded, but we've got three lines here. So the orange line here, which is after your EE project. The red line here is your demand management. It's a straight demand management with no impact on customer comfort or occupant comfort because the energy you're using is still the same. Then we have the blue line. The blue line is the demand response, and that shows we're running where this part we could operate the pre-cooling of the building because so that by the time that the period of adjusting our demand comes, at least it could coast further towards this period. So the blue lines are showing the peak periods. These are the peak periods, while the black lines are showing the managed response by the utility. In this case, a signal from them to directly reduce our demand, the building's demand for this period. So demand response has important value on the grid because forming demand response allows for grid scale peak shaving that reduces the need for new power plant construction. So that helps keep the electric grid slow and allows for technology that can be also used for distributed energy resources. So with this demand response, this is how the system profile will look like. So in this scenario, the utility, the grid operator, is shaving up to 520 megawatts. So it may not look like a lot, the 26, 28 megawatts based on the normal profile, but that's 26 or 28 megawatt or even 30 megawatts generating stations that do not need to be built or delayed in order to supply the afternoon demand. So it's a significant cost savings and a significant benefit to the customers, to all the consumers, as well as the utility. And this is typically what funds programs, because being able to avoid construction of new plants is less expensive than going out and building two new 20 megawatt or 10 megawatt generating plants or substations. So again, the demand response there are a lot of drivers for the demand response. It can be because of a certain problem by the supply. Some generations are out because of terrorist attack or some toppled down towers. It can also be by the utility themselves that are delayed in that that decide to delay the expansion of their franchise. So it can also be that way. Uh, they don't have enough money yet or any approvals sought by the ERC. They could use these tools, this concept to really limit the demand of that utility. So putting all this together, EE or energy efficient and DR, demand response, known as integrated IDSM, integrated demand side management. And that helps to lay the groundwork for distributed energy resources. Because once we have these technologies in place, we can start to look at what a building can do with on-site renewables. So this shows the typical production of a solar generation. So you can see that on an ideally sunny day, generation is very good and wide, and it's a wider graph. But for partly cloudy, it is narrower, intermittent, but with a slightly higher peak. So solar generation peaks at noon, solar noon, which varies from certain areas, especially in certain time zones. And there's usually a lag between the peak solar generation and the electric system demand peak. So the peak generation might happen at noon, but the peak demand happens from 2 to 4 p.m. So this is where IDSM projects can bridge the gap between renewable generation and peak demand. So demand management technologies, as what we've been discussing, allows for the load flexibility and the different management strategies that are necessary to work with distributed energy resources. So once they've been implemented, you can see that they're already cost effective. They're already cost effective to implement. So EE projects reduce the base load, and therefore any storage capacity that might be required in the building, making overall distributed energy resources projects such as solar plus storage batteries more cost effective. And then demand response projects can make use of excess stored energy that may exist in batteries to help support the loads on the grid overall. So, and together, all of this can prevent the duck-shaped curve. So this is typical for high load factor loads, especially industrial. This is something utilities are very concerned about. So especially if that customer has no storage. that this from a particular building, and if you could imagine that after the midday, this one, the midday, after the midday periods when the solar generation is tapering off, the potential of a late afternoon peak is still imminent, and this one is this side. So if the utilities perspective is if more and more customers are with this profile, there is still a peak to be managed. And this peak this demand may lead as well to capex, capital expenditures like building power plants, lines, substations. So by implementing these demand side management technologies, such as doing energy efficiency efforts, installing building management systems, implementing peak demand management technologies, can do peak shaving. So all of those come together so that now we can flatten this portion, the late afternoon peak, and avoid to build new capacities, power plants, lines, and substations. And even as we're building more solar generation, not until we have all of this demand side management in place, more solar generations doesn't necessarily help the overall grid because we're not getting rid of the late afternoon peak. So we could say that storage is also important. So energy management strategies are different in front of the meter and behind the meter. In front of the meter is mostly about providing supply. Behind the meter is more about managing demand. Putting that together, we see what I showed in the last slides with the potential for a duck-shaped curve. The need to provide good management. We talk about how individual building loads add up to the grid level effects in aggregate. We talk about EE and DR and how demand side management helps prepare buildings for renewable distributed energy resources. So I will be leaving this last slogan coming from our DOE. So when they launched the tar sheet, it's time for us to rethink our consumption habits. So thank you and good morning.
Thank you very much, Sir Louis.
Yes,
Okay,
sir.
thank you very much, Sir Louis, for that interesting topic. Now, there is a question here, sir. Uh,
Yes, sir.
Sir Lucio, Sir Lucio, Sir Lucio, do you have a question for Sir Louis?
No, sir.
Lucio Sanchez?
From Q&A here, it's from Sir Leo Labana.
Yes, sir. Go ahead, sir.
Yes.
Uh, the question of Engineer Jose Leo Labana is the 50M substation is for what size of a substation?
Okay. So the 50, the actually it really depends, but on average, it will be radial, and it will just be a simple one entry line side substation with one transformer, with one circuit breaker, with a system protection. Minimum system protection would be differential overcurrent, that one. So it will just be a one transformer radial setup substation. And the
Uh,
size probably it can be as high as 20 MBA.
so thank you, Sir Louis. I hope
20
that answers the
MBA.
question
Okay.
of Engineer Sir Leo Labana. So that's all from the Q&A, Sir Bob. I don't know if from the chat box if there are any questions.
Okay. Yeah, thank you very much, Sir Lucio. There's no more question in our chat box, so we will call in the giving of certificate to our speaker for today, Engineer Louis Angelo Colliera. By the way, Engineer Louis Colliera, he was one of the person who will restore the power of Cebu City during the typhoon. Thank you very much, Sir Louis. I really can't forget what you have done for us.
You're welcome, sir. It's a good.
So may I call in
You too.
Mr. Uh, yes, sir. Okay, with that, may I call in Engineer Lucio Sanchez to read the certificate to be given to Engineer Louis Angelo.
To the staff, kindly post the certificate on screen. To IIE Cebu staff, please. So while waiting, Sir Louis, I think this came in
Yes,
late.
sir.
This came in late. While waiting, Sir Bob, there is a question here that comes late. It's from Sparjon Arnejo. Is off-peak time of use benefit program available on VECO? Is lower generation charge on off-peak applicable also?
As of now, we don't have yet a TOU program. It's been we're waiting for the reset.
Okay,
We
thank
don't
you,
have yet
Sir
any
Louis.
TOU program for Petco.
To IAU staff, can you please share the certificate on the screen, please? Thank you.
Okay.
So IIE Cebu chapter presents this plaque of appreciation to Engineer Louis Angelo C. Colera, PEE, as technical resource speaker on the topic fundamentals of demand side energy management in the 21st Eastern and Central Visayas Regional Conference held on 27th to 30th day of July 2022 via hybrid at the Sky Hall A and B SMC side South Road Properties, Cebu City. Given this 27th day of July 2022, signed by Engineer Ronmar Gonzalez, PE, VP Technical Affairs, Erwin J. Salvador, PE, Technical Consultant and Advisor, Engineer Magdaleno Imbaclay, PE, President, IIE Cebu Chapter, and Engineer Brian E. Pasilan, PE, Regional Governor, Eastern and Central Visayas Region. So thank you very much, Engineer Louis, for sharing your knowledge and expertise to us.
Thank you also, IE, and all the program administrators.
Thank you, Sir Louis. Okay. And the time element is very important. Thank you very much, Sir Louis. You hit the target of 1 hour, 11 o'clock in the morning. So our next speaker for today, it would be he is a graduate with honors, a degree in materials engineering from Nanyang Technological University in Singapore, the year of 2008. He has more 9 years of experience in the marine sector, dealing with various systems such as Kongberg, alarm monitoring system, tank tagging, valve control, and other ship automation system. He also spent 2 years in ST Engineering as a business development manager, marketing their defense solution in the market of USA, Middle East, and Latin America. He is the sales manager of DIF Asia Pacific Singapore HQ in headquarters, taking care of the maritime sector in Singapore, Myanmar, and some customers in Malaysia. He joined DIF in 2015 and has been actively involved in DIF products and system. Ladies and gentlemen, would you please welcome our speaker for this morning, Mr. Matthew Loyong Wee, DIEF.
Thank you very much, Roberto, and it is my honor to be speaking with all of you this morning. So how do I do this? Do I share screen or?
Share screen, sir.
Okay. Share screen. Okay, please let me know if you can see my screen.
We would appreciate very much. Okay, Mr. Liu Yong, we would appreciate very much if you can finish your time by 12 noon.
Yes, okay.
Thank you, Mr. Liu
I'll
Yong.
probably finish before that, yeah. Okay, so let's begin. So this morning I will speak a bit about on marine hybrid solutions. Okay, so this picture you can see here in the slide is where our factory is in Denmark, and DIF, DEIF, is actually an acronym that stands for Danish Electrical Instrument Factory. Okay, I will be your host for today. My name is Matthew Low, and I specialize in marine and hybrid-based solutions. So hybrid is not a new concept for land. In fact, currently we are also working on quite a few hybrid projects in places like Ghana and Myanmar. All right. So this will be my agenda for today. I will speak a little bit about who we are at DIF and what role we play in the marine and offshore industry. And then we will ask the question, what is hybrid? How do we operate hybrid in the different modes of operation? What hardware do we use? And some case studies. And finally, we'll have some question and answer at the end. But of course, if you have any questions during the course of this presentation, just feel free to voice out. Okay, so here at DIF, our main business sectors are split into three: land, marine, and wind. So wind is not so much here in the equator region, but it's more prevalent in Europe, US, and China. So the fight against climate change has spurred humankind to transit into net zero emission systems. So here at DIF, we are no exception. So in our factory in Denmark, we are actually moving towards carbon neutrality by 2030, so that all our goods produced have a net zero carbon in mind. We feel that we have to set an example because we also specialize in control solutions for renewables.
Excuse me, Mr. Matthew.
Yes.
I think you haven't put your presentation on presentation because all we can see now is only the front page.
Oh, really?
Yes, it doesn't transfer to the slides, to the other slides.
Okay. Let me try again. Maybe you should put a screen. Yes. How about now?
Yes, but it's not on presentation mode. We can see the number of slides on the side.
Just presentation mode.
Presentation
Yeah,
mode.
the big one with the no.
How about now?
Yes, but this we can see the presenters mode where we can see the next slide. You just click the display settings. Display settings. You can see the display settings there.
Display settings, this one.
Yes. Click that one and swap. Yes, that one. Swap presenter view and slide view. Yes. Now, we can see now the presentation. You can now proceed, sir.
Okay. So I believe this slide will show. Okay, so you haven't been being able to visualize whatever I was saying, but that's okay. At least we are now still at the beginning. So land, marine, and wind. Right. So we are a company that specializes in control solutions for renewable energy. And we will advise customers on how to integrate renewable energy into their, be it existing power plants or greenfield projects. Okay, some of our values. Our values are underpinned by 3 different pillars: respect culture, mutual respect, ambition to do it better than yesterday, always improve, and also perspective, be open to possibilities and all that. So DIVE, we are committed to the UN Global Compact since 2014, and we joined in 2016. And we also actively support UN Sustainable Development Goals 2030. So our factory becoming carbon neutral is part of this direction. Okay, some figures about us. We started in 1933, and the picture you see there is our plant in this countryside place called Skive in Denmark, which is a 21,000, which sits on 21,000 square meters of land. We are present in 35 countries, and being a forward-looking company, we dedicate 20% of our workforce to R&D. We have our own in-house tech test lab. So this is also one of the reasons why during the Fukushima nuclear power plant meltdown in 2011, Caterpillar went in with 173 gensets, and it was DIVE who was supplying the control system, because we are the only supplier who actually tested our equipment to be able to withstand radiation to a certain level. And we also practice one point of contact through the system solution department. All right. Okay, so this global map will give you an idea of where we are and how we operate. The blue countries are where we are represented by our distributors. The green countries are where we have direct subsidiary offices under Denmark. Okay, so the training will follow a similar map over here. And because we are also a marine company, so marine vessels, they will travel all over the world. And we aim to provide a standardized training for the ship crew wherever they may be. But of course, standardized meaning to say the setup is standardized, but the software and the program is unique for each vessel. Okay, here in Singapore, we started in 2013. We are located at this place called Bukit Batok Crescent. So we function as the regional headquarters, reporting directly to Denmark. And from Singapore, we manage a total of 4 regional offices, 2 in Indonesia, 1 in Vietnam, 1 in Myanmar. And we have roughly around 25 to 30 employees in this area. And our scope of coverage stretches from Taiwan in the north all the way down to New Zealand in the south. Okay, so What we do for marine and offshore encompasses the power management system, which is our bread and butter. And if we were to go anti-clockwise, we also have HMI touchscreens, which are ATEX Zone 2 type approved. And more recently, we are into medium voltage now. And our switchboard equipment for point number 4 includes all the low voltage protection. So basically what we say is always everything you see on the switchboard, we supply, and everything you don't see, we also supply. And of course, engineering support to design the system and to test and commission the system, services, and product training. So this is the point that I was referring to earlier on training. We aim to provide a global standardized set of standards for training and marine bridge instrumentation. So this one we usually OEM to makers such as Rolls-Royce and Kongsberg. Okay, so based on those components, with sufficient engineering knowledge, we will be able to put them together to form a solution. Okay, and this solution will consist of things like DC bus. If you refer to the column on the right, there will be a DC bus application, variable speed, and more popularly now will be battery hybrid solutions. So in a hybrid solution, you cannot run away from inverters. So that's why we work very closely with Danfoss, and to the point that we are also able to supply Danfoss inverters. But of course, customer is free to purchase from Danfoss directly, and we are also able to interface with them. That being said, our interfacing is not limited to Danfoss as well. So we work with other inverters such as ABB and Schneider and all that. Okay, so let us begin by asking, what is hybrid? So by virtue of the word hybrid, so it means that energy is derived from 2 or more sources, right? So this energy source can be a regenerative winch and a crane, or more popularly, it can be solar or wind and diesel generators and batteries. So what we do here is we have a system that integrates all these sources into one power plant. Okay. So why are these solutions attractive? So there is a bit of a carrot and stick argument over here, right? When marine vessels, they sail into the different ports of each country, then that particular country will have their own legislation that the vessel must adhere to. Legislation such as the emissions of certain particulates, sulfur dioxide, nitrous oxide, and all that. So if the vessel doesn't adhere to that, then fines will be in order. So this will be the stick, right? But on the carrot side of things, for the ship owners, you are a well-designed hybrid solution actually allows you to better utilize your energy sources on board the vessel, and also if on land, if you have a project on land. So when we say better utilization of your sources, what we mean is you can run your diesel generator at optimal efficiency. You reduce your, for instance, you reduce your vibration on board. So when you reduce vibration on board, you actually are saving in terms of your maintenance, because your other equipment break down lesser, right? And when you are able to utilize your genset at a higher efficiency, cost savings, fuel cost savings will come into play as well. So all these are all win-win for both the bottom line of the company and also for the environment. Okay. So now hybrid propulsion is not a new thing. Hybrid propulsion has been around for, I believe, coming to 20 years already. So in the past, we talk about AC hybrid propulsion. So AC will stand for alternating current, right? AC bus. So in a traditional AC hybrid propulsion, you still have your main engine being the prime mover for your propeller. But what differentiates hybrid from normal vessels is the shaft generator. If you look here in the middle of the screen, and let me see if I can enable the pointer. Okay, if you look here in the middle of the screen, this will be the shaft generator here. And subsequently, we need to talk about the modes of operation. PTO stands for power takeout. So what it means is that power is being taken out from the shaft generator to power the bus bar and to supply load to the vessel. Okay, so if we drill deeper, means that the main engine is driving two loads. One load is the propeller, another load is the shaft generator. So what will happen here is that the vessel is able to shut down either one or both diesel generators, depending on how much the load is and how much the capacity of the shaft generator is. Okay, so you save fuel in the form of your generator being shut down. PTI, power take in. Power take in means your shaft generator now becomes a motor. So this will provide a boost to your propeller. So how this works out to be cost savings is that your main engine, instead of running at maybe 5,000 horsepower or whatever horsepower, you can run lesser because the electrical load is being boosted. Electricity is being converted into mechanical energy by this motor here. And traditionally, diesel gensets are always more efficient than main engines on board a generator. So hence, there is an incentive for the vessel to run in PTI mode if there isn't any heavy requirements on the horsepower. PTH, power take home. Power take home is very similar to PTI, but it means that the power take home is the most fuel consuming mode because you are trying to build a redundant system into it. Your shaft generator is behaving like a motor, your main engine is running, and your diesel generators are running. So this will provide the most amount of, for instance, if this is anchor handling tug, the bollard pull, the max bollard pull parameter will be activated during this time, power take home. Okay, so this is traditional mechanical AC hybrid propulsion in the past. So modern days, so this is more like a 5 years kind of system setup. 5 years ago, we have such system setups already. This is still an AC bus, but now we have batteries coupled to this. So what the batteries will bring is this thing what we call instantaneous spinning power reserve. So spinning power reserve is a sort of a blackout prevention method whereby our system will reserve a certain amount of power in the event of any diesel generator trip. All right. So when we have a battery coupled to the bus, we don't need to do this because the battery itself is the power reserve. And peak shaving is a term we use for land-based applications whereby we cap the power to a certain level. Any demand beyond the level, then we will draw from an alternate source. So in marine, now we are using this same term, peak shaving, but it's more to respond to slow responding gensets. So the generators may be either very huge or very old or poorly maintained. So they tend to respond slower. Then when they cannot ramp up as fast, you are in danger of having a blackout situation on board, right? So during this time, like for instance, the genset can take maybe 5 seconds to 10 seconds to ramp up. So during this time, the batteries are fully capable of handling this excess load. Like for instance, if you want to start up a crane or you want to start up a winch, this is a time when you require this additional sudden power boost. Okay. Okay. Okay, so just to check in, is everybody okay? Can you all see my screen and both hear me at the same time?
It's okay.
Okay, thank you.
Electric hybrid.
Okay, so now actually gradually what we are seeing a shift towards is such a solution, whereby the difference between this slide and the previous slide is the removal of a main engine. So if you, as you may know, most major cruise ships nowadays, they do not come with a main engine. They come with generators powering Azipod thrusters and all this kind of thing. So this is the typical setup for cruise vessels. So what this does is it reduces your emissions even further because you don't have a main engine, and the main engine has a lot of losses here and there. So diesel generators traditionally run more efficiently. And on top of that, you couple batteries to your bus bar. So batteries, like I mentioned earlier, provides things like instantaneous spinning power reserve, and they are able to stabilize the load by taking on the excess load when it comes online. So all this will also reduce wear and tear on your diesel generators, and in fact result in your maintenance schedules being prolonged. So this will result in also cost savings for maintenance. Now, in today's market, we are talking about DC bus applications. So instead of your traditional AC, now your bus becomes a DC bus. So for a DC bus, you need inverters on everything. For the batteries to connect to a DC bus, you need a DC-DC inverter. For the generators to connect, you need AC-DC inverter. And vice versa for your DC bus to output to supply the load. Because your loads are in AC, so you also need a AC-DC converter. So if you can see, as you can see, from the get-go, this definitely a DC bus solution will cost more than an AC bus solution from the get-go. But why would ship owners want to have a DC bus solution, you may ask? Well, you can actually further reduce your maintenance costs because your gen sets now you don't even need to synchronize. Your synchronizing is done by the inverter themselves. So the gen set just needs to start up, ramp up to a certain RPM, and then this inverter will regulate the frequency by itself and then just connect to the DC bus. In fact, on the DC bus, there's no frequency. So you can have variable speed control of your gensets, right? You will have very precise load management because all these are all electronically controlled at the inverter side already. As compared to an AC bus, how the load is controlled is by regulating the frequency on the genset. So if you regulate the frequency on a massive genset, 2-3 megawatt genset on board a vessel, you cannot have such precise management. So same thing with batteries, you have instantaneous spinning power reserve. And in such a mode, you are more able to do a pure battery propulsion mode, because in the event your battery state of charge runs low, you have your alternatives to charge it. So for battery charging, usually what we do is the PMS will program such that the generators are the last priority to charge the battery. So if there is a main engine coupled with a shaft generator on board, that would actually be more either the first or second priority, because when the vessel is running on fixed RPM mode, then that would be the time to charge the batteries. So this will apply on things like cruise ships or tankers where they are running long voyages. Okay. So what this means is you can minimize your emissions because you have a option to choose which source to run your vessel on, right? And of course, diesel generators is the last solution. And on long voyages, your main engine will run at constant speed, and you only have one prime mover running. And he is able to supply the load plus provide propulsion to the vessel plus charge the batteries, right? So you reduce fuel consumption in this way, and you optimize your genset operation by optimizing their speed at which you operate them at. Okay. So this is where we are at today, but the DC bus being a very recent development, so not much adoption is being seen yet. But what we are seeing is increase in interest on DC bus solutions. And in fact, we are also seeing like this, one DC bus and just batteries. So of course, such a setup, such a vessel is not able to operate for long, and usually it's crew boats or supply vessels, small vessels operating at very close to shore and fixed frequency with fixed payloads. So a few projects what we have discussed on is a fleet of such vessels, and then their batteries are either interchangeable or they can be charged at the port. So in fact, one of the case studies later that we are sharing will be such a vessel. Okay. So when we talk about hybrid, we definitely have to talk about the modes of operation already, because it's no longer a simple, straightforward thing to operate a hybrid vessel, right? So energy storage. So the energy storage itself has its own operation modes, but do not confuse this with the vessel operation modes. So energy storage operation modes will complement vessel operation modes. Okay, so what we mean by energy storage operation modes, meaning to say your batteries will be either in a state of charging, meaning to say their state of charge is low, just like your handphone battery, you need to charge it. So when the battery reaches, for instance, 80% state of charge, it becomes a power source. So it becomes a discharging mode. So which is essentially the same as a PTO mode. if we are relating this to traditional AC terms, like AC hybrid terms. But what is unique to battery is a standby mode. So standby mode will only be active when the battery has reached a sufficient state of charge. So they are on standby mode to take on whatever excess load that may come online during the operation of the vessel. All right. So slow charge will come in when you have a high state of charge, like for instance 80%. Then the system will have to throttle down the charging rate to preserve the life of the battery and to allow it to last longer. And vice versa, slow discharge. Like for instance, when the battery state of charge reaches either 30 or 40%, then slow discharge mode will activate to prevent blackout on the vessel, or to either that, or we will activate other sources of energy. Okay, so semi or local mode. Semi and local is a dive term, is unique to dive, but what is on the battery will be either local or remote, right? So if the inverter is in local or remote mode, so it depends on whether the inverter is start and stop by the start button or by a superior system, such as the energy management system. Okay, so in manual mode, so for instance, the operator will only be able to start the inverter at the inverter itself on the local panel, and the breaker will be controlled by the open or close key. So in automatic mode means remote mode, probably on the breaker, on the inverter, sorry. So it will automatically be controlled by the EMS, energy management system, which is us. And our system will be the one calculating things like the total power available on the bus bar. So why is this important to us? Because when the battery has sufficient state of charge, your power available on the bus bar will increase. And vice versa, when the battery has discharged to the level where it becomes a load, in fact, your power available not only decrease on the bus bar, your load increases also, because your battery now becomes a load. So our system has to take this into consideration and do the calculations accordingly. Okay, so in PTO mode, like I mentioned earlier, means the battery has reached a sufficient state of charge, allowing it to be discharged. So PTO mode will be active, and the inverter will be a part of normal priority selection and load dependent start-stop. So normal priority selection, load dependent start-stop, these are part of our power management regime. So load dependent start-stop means we will start up the energy source depending on the load. So if there's low load, means we can shut down whichever energy source we set as the priority. Okay. So in island mode, the inverter is able to be connected as the only feeder. So this will operate on those pure electric vessels that I showed earlier. PTI, vice versa, the battery has a low state of charge, it becomes a load, right? So our EMS, energy management system, will take care that it does not overload the generator plant. So we have to do the corresponding action, like maybe start up this genset or start up that shaft generator or whichever action. Okay. So standby, the inverter will be left in standby with the breaker closed. So this one means the inverter will respond instantaneously to ramp up the power output in the event of a surge. Okay, this is what standby mode is for. And we do this because we do not want to start up a genset. Okay, starting up a genset requires time, requires fuel, and you will wear out your spare parts faster, right? So when we talk about coupling of a battery to gensets, we also have to talk about asymmetrical load sharing, because your battery capacity is definitely different from your genset capacity. And on board a vessel, it may also have gensets of different capacity as well. So what this means is we will cater for the different capacities, rated capacities of the different energy sources. And depending on the load, we will start up the source accordingly. But of course, in situations such as this diagram that you see here, the battery is always the first priority. So the battery will take load up to their set point, and then after that, then the system will see the excess load on top of the set point, which generator to start up. Okay, so this is what we mean by asymmetrical load sharing. So whichever genset we start up, we will sync to the bus bar and do load sharing together with the battery. Okay. So just now we talked about energy storage modes. Now we will talk about power management plant modes. So the energy storage modes that we discussed earlier, those are all happening in the background. Those do not require human intervention. So the human intervention is at the plant level. Okay, like I mentioned, semi-auto and auto, these are dive terms. So what semi-auto means is on our system, it is still manual operated. Like for instance, the operator still has to go down to start the genset and close the breaker. But how the semi-auto function comes in is because he just needs to press one button, close breaker. So the system will do everything else. Synchronizing, close braking, close breaker, load sharing. Okay. And in auto means there is zero human intervention. So the entire, when the system is set in auto mode, our PMS will not allow a human to stop the genset or close open the breaker, because all the calculations will be done electronically. And now we have hybrid mode. So hybrid mode will take into account the batteries. Okay, so the batteries, whatever we discussed earlier on the energy storage modes, this will be incorporated as part of hybrid mode. Okay. And we also have another mode, zero emission mode, meaning to say we just run on pure battery mode. But of course, this is not for every vessel. It is only for very specialized cases. Okay. So what do we mean when we talk about all the different modes? So this diagram will illustrate better. So in diesel mode, diesel auto mode, our system will only start up the diesel generators. So in hybrid mode, it will be a combination of both the batteries and diesel generators. And our system will conduct load sharing between these two sources. So zero emissions is pure battery mode. And shore. Yes, so shore is another mode when it comes to batteries, because like I mentioned earlier also, the priority of the energy source used to charge a battery also has to be taken into account. And if there is a shore connection, shore is also one of the first few priorities to use to charge the battery. Okay. So the hardware that we use is our newest generation of power management systems. We call this PPM 300. So this is a distributed multi-master system. So what we mean by this is that unlike a PLC-based system where the PLC is the main brain, and if the PLC fails, you lose power management. But in our system, you have one of these racks on every energy source. So like for instance, if you have 4 generators on board, you have 4 of these racks. You have 1 battery pack on board, you have 1 more rack coupled to the bus bar. So multi-master means any one rack fails, the remaining units in the system will conduct power management by themselves. So one rack failure will not bring down the whole system. This is a part of redundancy that we built in. So I won't touch on every point, but what I want to highlight is this point here, full galvanic separation. So the IOs are fully galvanically separated from the 3-phase input. So means to say you are ensured of your signal integrity. And we also have another redundancy built in the form of this ring connection. So this ring connection refers to the connection between the units on board the vessel. So as each unit is connected to the unit beside it via Ethercat cable, at the end of the unit, there will be one line connecting the last unit to the first. So this represents a ring. So any one communication cable is cut, the other line will take over. So this is another redundancy that we built in. And in today's world, as marine gets more and more interconnected, we also have to address the issue of cybersecurity. So such a system, our system has network storm protection built in as part of our cybersecurity measures that we implement. Okay. Okay, so this is another system that we will use for high-end and high-tech applications. So we use Delomatic 4 for quite a number of navies worldwide. So over here in our region, namely Taiwan Navy, we have supplied a lot of Delomatic 4 systems to Taiwan Navy. So the hardware looks similar to PPM 300. It is rack-based and modular-based as well. So any one rack spoils, the customer can easily pull it out and replace it by themselves. They don't really need to load any new program into it because the program will be stored in the processor card. So if the processor card spoils, then yes, you need to reload everything. But any other card spoil is okay. Okay, so what we're trying to say here is we have a combination of different cards that perform different functions. IO cards, 3-phase input cards, and display units, operator panels. Okay, so we are soon nearing the end, and we'll share a few case studies with everyone here. So this case study is for these 2 ferries, Tycho Brahe and Aurora, operating between Denmark and Sweden. Okay, so this is a retrofit project, and we started out with a traditional AC bus coupled with 4 generators. So our power management system is doing the normal load dependent start-stop priority selection over here. So what has been added on is this DC portion over here. So this DC portion is in the form of 2 battery containers at the top deck, right? So what we are doing is our system is load sharing between the gensets. That's one. So what we have to do next is to load share between the AC DC converters. We have to balance the state of charge of the batteries meaning to say we have to prevent one battery bank from charging another battery bank. So that is what is happening here, and that is what you don't want. Okay, and essentially PMS converted to EMS. These are just terminologies. So currently how this vessel is being operated is the diesel generators are now the last priority. So the batteries will be the first priority, and every time it comes alongside to the shore, there will be a charging arm being extended and connect to a connector which will charge the batteries as it performs its shore operations. So since this is a ferry, it will be loading or unloading humans and vehicles. So while this is happening, the batteries are being charged. Okay. So, okay, so previously this project was completed sometime in 2016. So it was quite a few years ago already. And more recently in 2021, we have also completed this electric ferry called Groti, if you can see here. So the unique thing about this ferry is that it's designed to be a one-man operated from the bridge, because this is a small ferry and the crossing is 20 to 30 minutes long. It's not that long. And it does have one genset on board, but this is purely for backup purposes. So it's designed to be run by the operator, by the captain. And oh, sorry, I think can you all see now? Okay, so this is the vessel that we completed in 2021. And this is the actual screen that the captain sees on board. So if you notice carefully, there's two battery packs on the port and starboard side. The diesel generator is the last priority, and they have a shore connection. So as the vessel comes alongside, the captain, all he has to do is press this shore to start charging. So there will be a receptacle. Okay, if I show this slide, there will be a receptacle here. Can you all see my laser pointer? Where is it? Okay, so I assume that you can see where I'm pointing at. So there will be a receptacle here, and this arm, it will lower the connector into the receptacle, and then charging will start. So this is how it charges the batteries for this vessel. Okay. Okay, so with that, we have come to the end of my part, and let me know if you have any questions.
Any questions? Mr. Pahamutang, do you have questions there? You're raising your hand? Oh. Okay, so next time, attendees, please, if you have some questions and some inquiry, please post your question in our Q&A box so that your question and inquiry will be answered respectively by the member of the IIA Cebu chapter and of course to the speaker. So thank you very much, Mr. Wee, for sharing with us this new technology for marine propulsion. So may I call in our president, Mr. Baklay, to award the certificate to Mr. Matthew Lo Yung Wee.
Okay, sir. Okay, I Cebu chapter awards this plaque of appreciation to Mr. Matthew Lo Yong Wee, PEE, as technical resource speaker on the topic hybrid diesels under energy management system in the 21st Eastern and Central Visayas Regional Conference held on 27th to 30th day of July 2022 by hybrid at the Sky Hall A&B SMC Side South Road Properties, Cebu City, given this 27th day of July 2022. Signed, Engineer Ronmar Gonzalez, VP Technical Affairs, Engineer Erwin Salvador, PEE, a consultant and advisor, yours truly, and then Engineer Brian A. Basilan, PE, our Regional Governor for Eastern and Central Visayas. Thank you very much, Mr. Wee.
Thank you. Thank you so much. Thank you.
Thank you, Mr. Matthew. Sir Matthew, there is a question here just popped up a while ago.
Yes.
Hey, hello, Sir Matthew.
Yes.
There
Yes.
is a question here just popped up a while ago while we are reading the certificate, your award for certificate. Now, here is the question. Are batteries maintenance free? Types of batteries used? Battery charging cycles.
Yes. So
Is that maintenance free, Mr. Matthew?
yes, the batteries are
Maintenance free?
maintenance free, and the type of batteries used are
Cycle?
lithium batteries.
Lithium ion.
Yeah, lithium ion batteries.
Okay.
So the charging cycles, okay, because for the ferries, they operate 30-minute voyage, charge for 5 minutes. So they have to use high
5
voltage, high
minutes charging
current,
time.
charging. Yeah. And these batteries are from Sterling PBS and Corvus. Hello.
Okay. Thank you for that informative answer, Mr. Matthew Wee. So,
10,000.
any other question? Oh, another one popped up just a while ago, Mr. Wee, from Jesse Helm Asuncion. What are the typical energy capacity stored in a hybrid vessel in your projects?
Well, it depends on the size of the vessel. So, like for instance, the Tycho Brahe, that vessel, that one is a huge vessel. It's about 100 over meters long. So for that, the battery is 1 over megawatt hour. But for the vessel Grotte, Grotte, that one is a much smaller vessel. So the batteries are in around 5 to 600 kilowatt hour.
Okay. So thank you very. Any other more question? Maybe there are. If there are questions, please pop up right now so that Mr. Wee is still with us. So nobody. Okay. So there's no more question here, Mr. Wee. So thank you very much, Mr. Wee. Hoping to see
Thank
you
you.
again.
Thank you, Roberto. Thank you. Thanks for having me.
Okay. Thank you. All right. So we will have our working lunch. So during our lunch, we will have a video clipping of our sponsors. So administrator, please run up now the video clips.
Sir Bob,
Yes, sir.
can I insert
Yes, sir. Go ahead.
a few minutes, sir? I would just to discuss on the attendees on how they are going to change or rename their name on Zoom, since some are not indicating their complete name. Just this is for just the attendance logging purposes.
Okay.
So
Thank you. Thank you, sir. That's a valid concern.
uh, these are the steps on how you could change your name on Zoom as appeared on Zoom. So above your name, there are three dots. Just click it. Then a drop-down menu will appear. Then select rename and type the name as complete as it is. First name, middle initial, and last name. Then click change. So your name as appeared on Zoom will now change to the new name that you encoded. So I hope all have get or acquired on the steps on how to change the name as appeared on our Zoom webinar. So that's all, Sir Bob. I will now stop share.
Yes, sir.
Thank you
Thank you
for
very much for that wonderful hearing. Okay, so there, Lucio, thank you very much from InGCP. Now let us try to observe the video clips of our sponsors while taking our lunch. So this afternoon, our speaker will be Engineer Sir Brian, Engineer Magdaleno Baclay Jr., Engineer Erwin Salvador, Engineer Raymond Garcia. Oh, Raymond Garcia, Vice Mayor. Huh? Okay, so thank you very much. So, Administrator, please. Video clips. By the way, reminder to our members and attendees, please, if you have some questions, post it in our Q&A box so that it will be respectively answered by the members or by the speaker himself, by the way. Walter Degatan, do you have questions? Okay, so no more. So take your lunch, guys. Hello, sir. Ang kuha video clip. Hello? Hello?
Visayas, Mindanao, ay kamakaret nakakawaw. Yeah.
Malawag pa'y itiranyag, kiti aldaw, sumikat ka, ito'y lubong na baw. Pilipino, kung orgulyo grita na itero mundo.
Hawod ang imong dugo, maayo kini, maayo dire. Mga waray, dito. Ilocano, dito. Bisaya, dito. Galing, dito. Chabacano, dito. Bicolano, dito. Tapawenyo, dito. Galing, dito. Ang galing mo, ipakita mo, basta Pilipino, galing dito, galing dito. Ang galing mo, ipakita mo, basta Pilipino, galing dito, galing dito. Hindi ka ba napapansin? Pangarap ba ay nabibitin? Talay gustong sungkitin, pero ang layo ng dapat ahakin.
Dito sabay-sabay iaangat ang bandera at isa't isa. Dahil galing ng isa, mas magaling pagsama-sama.
Ang galing mo, ipakita mo, basta Pilipino, galing dito, galing dito. Ang galing mo, ipakita mo, basta Pilipino, galing dito, galing dito. Ang galing mo, ipakita mo, basta Pilipino, galing dito, galing dito. Luzon, Visayas, Mindanao, ay kamakaret nakakawaw. Yeah.
Malawag pa'y itiranyag, kiti aldaw, sumikat ka, ito'y lubong na baw. Pilipino, kung orgulyo grita na itero mundo.
Hawod ang imong dugo, maayo kini, maayo dire. Mga waray, dito. Ilocano, dito. Bisaya, dito. Galing, dito. Chabacano, dito. Bicolano, dito. Tapawenyo, dito. Galing, dito. Visayas, Mindanao, ay kamakaret nagkakawaw. Yeah.
Malawag pa'y itiranyag kiti aldaw. Sumikat ka ito'y lubong nabaw. Pilipibyo, kung orgulyo grita na itero mundo.
Hawod ang imong dugo, maayo kini, maayo dire. Mga waray, dito. Ilocano, dito. Bisaya, dito. Galing, dito. Chabacano, dito. Bicolano, dito. Tapawenyo, dito. Galing, dito. Ang galing mo, ipakita mo, basta Pilipino, galing dito, galing dito. Ang galing mo, ipakita mo, basta Pilipino, galing dito, galing dito. Hindi ka ba napapansin? Pangarap ba ay napipitin? Talay gustong sungkitin, pero ang layo ng dapat dahakin.
Dito sabay-sabay iaangat ang bandera at isa't isa. Dahil galing ng isa, mas magaling pagsama-sama.
Ang galing mo, ipakita mo, basta Pilipino, galing dito, galing dito. Ang galing mo, ipakita mo, basta Pilipino, galing dito, galing dito. Ang galing mo, ipakita mo, basta Pilipino, galing dito, galing dito. Luzon, Visayas, Mindanao, ay kamakaret nagkakawaw. Yeah.
Malawag pa'y itiranyag kiti aldaw. Sumikat ka ito'y lubong nabaw. Pilipibyo, kung orgulyo grita na itero mundo.
Hawod ang imong dugo, maayo kini, maayo dire. Mga waray, dito. Ilocano, dito. Bisaya, dito. Galing, dito. Chabacano, dito. Bicolano, dito. Tapawenyo, dito. Galing, dito. Luzon, Visayas, Mindanao, kamakaret nagkakawaw. Yeah.
Nalawag pa'y itiranyag kiti aldaw sumikat ka ito'y lubong na baw Pilipibyo kung orgulyo grita na itero mundo
Hawod ang imong dugo, maayo kini, maayo dire. Mga waray, dito. Ilocano, dito. Bisaya, dito. Galing, dito. Chabacano, dito. Bicolano, dito. Tapawenyo, dito. Galing, dito.
afternoon at exactly 1 o'clock p.m. Time check, 1. Hello everyone, this is Bob Cabarubias. This is your host for today. Now we are gonna have to start our afternoon session. So before we start, here I have to let you know that our internet has been powered by D2 through the effort of Engineer Catalino Munin. And of course, we acknowledge the presence of our former IIEE National President, Engineer Juby Panhilazon. Now, our program this afternoon, we will start at exactly 1 o'clock p.m. Okay? So I hope and pray that you'll be staying with us. And of course, it is better for you to ask questions so that we can acknowledge that you are really following our lecture here. So of course, you try to ask question. The questionnaire, you are going to write it on the Q&A box, okay? So that it will be answered by the respective engineers who are here with us in the panelist, or it will be answered by the speaker itself, okay? So with this, we are going to start our afternoon session. The speaker for this afternoon, he is a graduate of the Bachelor of Science and Electrical Engineering at the University of San Jose Recoletos. Professional Electrical Engineer, Vice President of GBR Electromechanical Services, IIEE Cebu Chapter President for the year 2015, with specialty in design, installation of power plants, industrial plants, substation, commercial establishment, short circuit protection and coordination studies, with sub-penal specialty in electrical testing audit, awarded by IIEE National as exemplary chapter president last 2015. And he is also our mentor for the prospective PEE. So he is taking his time to share his knowledge or his expertise in the boarding for the board exam for a professional electrical engineer. He is always with us, and those who are RE who wish to be with our review in our Cebu chapter, it is Engineer Brian Pasilan who will head the mentoring program. So, meaning to say, if you are already more than 5 years in the practice of your profession, you can now start your review in IIEE so that you become a professional electrical engineer. Okay? So, ladies and gentlemen, would you please welcome our first speaker for this afternoon, Engineer Brian A. Pasilan.
Okay, thank you, Sir Bob. I'm still adjusting my slides for a few minutes. Anyway, can we acknowledge first Mr. MC, our other guests, no, dignitaries?
Okay, so
Like
I have to acknowledge here our panelists first. So here we have the Cebu staff, Engineer Benito Semini is with us this afternoon. And then we have also Bienvenido, Chris Fernandez, Engineer Louis Angelo Colliera, Engineer Magdaleno Imbaclay, Engineer Hirira, Engineer Alan Sabandal, Engineer Alan Biton, and Engineer Isra Kadiven, Engineer Mark Anthony Davis. And of course, I have to tell you this again, that this internet has been powered by Dito. Dito meaning to say that is the new provider of internet here in Cebu City. So they have already a 5G program, a 5G internet. So you can do TikTok. This is a very fast internet. And of course, this is through the effort of Engineer Catalino Munin. And we have a ton of sponsors right now in our midst. So this morning we have just the nice interaction with the speakers. The engineer Russell, and also engineer Louis Angelo Coliera, and of course the foreigner who is discussing the hybrid and ships in Mr. Matthew Loyong Wee. So I hope you'll be with us, sit back and relax. Okay? So we have a wonderful speaker lined up this afternoon. Now, with this knowledge, you can now increase or you can now broaden your electric in the field of electrical engineering, either through your employment or by your as you are a contractor. So meaning it is now an add-on. Plus, of course, when you have to renew our license, we will have to use these points to be so that your license, our license, will be renewed. Okay, so please be with us. Sir Brian, are you ready?
Yes, Sir Bob.
By the way, this is an hour presentation. Okay, this is an hour presentation, and then we'll have an interaction because there are already a lot mga questions here in the Q&A box. So, Sir Brian, take it away.
Okay, good afternoon, everyone, and thank you once again for participating in our regional conference. And before I go direct to my topic this afternoon, also I'd like to acknowledge, the presence of our chapter officers from Eastern Central Visayas who are with us in our Zoom right now. So I've seen here kanina, Engineer Alberto Dalinia, the chapter president of Negros Oriental chapter, and also the VP internal, Engineer Dennis Alburo, and also our chapter president of Calbayog chapter, Miss Maria Richel Fuelias, and sino pa? Okay, we'd like to acknowledge also our National VP External, Engineer June Herrera. Good afternoon, Sir June. Thank you for coming here with us. I'll be looking forward to seeing you tomorrow. And again, Engineer Larry Cruz, our former National President. Okay. So, let me proceed. I will share my slide. So, in a little while. Okay, would like to confirm if everybody can see my slides, no?
Yes, sir.
Yes, sir.
Sir Bob? Okay. Thank you. Thank you very much, Sir Bob. Okay, so my topic for this afternoon, which I've been delivering it in IET-CPDC, so it's entitled Application of Short Circuit Currents for Equipment Specifications, and we'll be focusing on low voltage equipment, or specifically low voltage overcurrent protective devices. So this is like a counterpart of what Engineer Russell Paragoso has discussed this morning. He was focusing on IEC standards, but for this one we'll be focusing on IEEE ANSI standards. So the same approach, the same concept of application of short circuit currents with regards to specifying equipment ratings for OCPDs, like interrupting capacities and momentary ratings, and closed latch ratings, etc. Okay, so this is just like somewhat a continuation, but of a different concept, different standards. Okay. So our discussion this afternoon, we'd like to
this is our outline. No? So we discuss about some objectives, introduction of some concepts, no? Some definition of terms, and we'll be presenting some types of network reactances depending on the duty rating that we are interested to determine. No? So we have the subtransient, transient reactances, etc. And the type of short circuit currents, no? The asymmetrical short circuit currents, no? And this is very important, no? Since this is the value of short circuit currents that deals with our at that half cycle, no? Half cycle period. Okay. We have the peak and the RMS values. We'll be discussing about XR ratios of different equipment, but not so much, since this will be discussed thoroughly when you have the discussion of short circuit calculation. So this one, we are more interested on how to apply the output of the short circuit calculation, no? With regards to the equipment, especially for ANSI devices. Okay. Okay. So our objectives for this lecture, by the way, this lecture requires almost 3 hours, no? But I'll just compress it in an hour as much as I can. So I will have to beg pardon that there will be some slides I'll be skimming through, no? Just for the time, no? So we have to determine the applications of short circuit currents. So when we do short circuit calculation, we have to know where to apply it, no? Because if we don't know, then there's no value in solving for short circuit currents. Okay. So we have to know the various network system reactances, no? Like what we've outlined kanina, these subtransient and transient reactances, sources and types of faults, and we have to determine the type of modeling, no, for the specific type of faults. Like if it's a three-phase balance fault, so we have to use the three-phase balance impedance diagram, or the unbalanced fault diagram for unbalanced faults like line to ground faults, line to line, and double line to ground. So depending on the type of fault that we have to determine. Okay. So there's also understanding of the concept of per unit calculations. No, it's a very important tool for short circuit current, but we'll not be dwelling too much on the calculations per se. We just have to be familiarized. No. So excluding in this lecture is the discussion about symmetrical components, since this will be dealt in the short circuit calculation. No? The impedance network reduction, the unbalanced fault calculations, and protection coordination. Okay. So what is an electrical fault? We all know, no? It's any failure, no, that interferes the normal flow of current in the system. So as electrical engineers, we all know what is the normal flow from the source, no, going through the conductors, then to the load, then back to the source again through the conductor. So that's the normal flow. But any abnormal path, any abnormal occurrence in that flow of current, this is what we term as fault. No, it may be a line to ground fault, double line to ground fault, or line to line fault, or three-phase fault. No, so anything that short circuits the path of normal flow of current, it's a fault. No, so it would normally give rise to abnormal operating conditions, usually in excessive currents and voltages at certain points in the system. So that's why usually when we term short circuit currents, it's in the level of 1,000 amperes. Usually, no? It's 1,000 amperes. So we have audiences here in this station. So this is where I get my interaction from. No, hopefully the students will be prepared. No, later on. What is a short circuit calculation? So they still have to get their power system, no, course. Majority of them is in CIP. So Engineer Erwin Salvador and Sir Louis Lateria is here. they are monitoring these students if they are listening very well. Okay. So, nag-isilan ni sila. Dire. Bahalag nag-nosebleed, no? Okay. Moving on. Okay. So, the fault occurs when two or more conductors that normally operate with a potential difference come in contact, no? So, basically, short-circuiting, the bypass yung load natin, no? Instead of going to the load is no longer there. So both of these conductors, the incoming and going are incoming in contact. So there's no more potential difference, like the load that the load will impact, no, on the system. So basically, the resistance now is very, very small because we took away the load resistance, no. So what's left is only the conductor resistance, which is usually in terms of milliohms or microohms. So for the same voltage and the impedance now is very small, the current is very large in terms of 1,000 or 100,000 amperes, okay? So the contact may be physical or may occur in an arc. So it might not take a solid contact, it just a little gap, no, between the conductors. It would now also cause fault, no? That's what we call the arcing fault, no? So even though there's no solid contact, but the air gap now is very close, so the electric of the air is overcome. So that's why we see sometimes electric current, no, arcing between those conductors. So we can see the current now passing through, okay? So sa natures and causes of faults, we all know that one, insulation problem, no? It might be deterioration of the material, it might be of wet conditions, no? Or anything that causes contact, no, of those conductors, no? It might be moisture, no? So anything that causes insulation problems, no? It might be electrical in nature, no? It might come from lightning surge, switching surge, and other overvoltages, okay? So it might be external or mechanical, no? It might be pests, intrusion like rats, no? Cats. No? It is, especially if you have very big opening in your electrical panels and pests will go inside, then that could cause an external fault, no? For outdoor installations like overhead lines, vegetation, no, like distribution lines. So when trees, no, touch those overhead lines, then a fault again occurs, no. Sometimes wind, no, and snow. So in the Philippines we have no snow, so seldom lang itong nangyayari, or wala talaga, no. Pag may snow, lilipat ako doon sa lugar na yon, no, para komportable yung buhay ko, no. But since we are in the tropics, so wala talaga tayong snow dito. Okay? So before moving on, we have to tackle a different definition of terms. So what is an overcurrent? We will usually be facing this term overcurrent during the course of our lecture. So it's any excess of the rated current. Rated current is the normal current, no, operating in the system. Okay? So anything in excess of that, like for example, you have the full load current capacity of your transformer at 100 amperes. So anything excess of that, no, that is what we term as overcurrent. So it might be an overload, it might be a short circuit current. Okay, the difference between the two of them is the magnitude. Overload is slight overcurrent lang in terms of 100 amperes, no? But when we say short circuit current in terms now of 1,000 amperes from, or 10 times or 5 times of the normal load current. For overload, just like, it's like 10%, 20% more, no, of overcurrent from the rated current, okay? So, another common term is what we call the overcurrent protective device, or the OCPD. No, this is what the devices that we usually call as circuit breakers, fuses. No, so anything that causes tripping for any overcurrent. No, So it's a protective device that protects our equipment, our conductors from any excessive currents. Okay. So usually they have interrupting ratings no less than 5,000 amperes. No, even the smallest breakers, no, the miniature ones that you see in our households, the what we call the miniature circuit breakers, their interrupting rating is not less than 5,000 amperes. Is the minimum standard in the market. Okay. So pag may nakita kayong 4,005, hindi na yung standard, ha? No? So it's a safety factor that they've introduced the system para usually kasi yung the fault current that we experience in households, in the small transformers in our distribution system, usually it will not go below 5,000. No? So that's why they specified that they should be not less than 5,000 amperes. Okay? Because what usually happens if you don't specify the interrupting rating, the supplier will give you the minimum default. No? So that's the problem now, because if we will not determine the short circuit current, and they give you the 5,000 amperes, but the actual short circuit current is 10,000 amperes, what do you think would happen to our equipment when there's a fault? Okay, might be damaged, it might be destroyed, no? Correct, so it cannot handle the very large current. So it's very important that we have to rate the interrupting rating larger than our short circuit current that we have computed, okay? So that's what we discussed, no? The interrupting rating, what we call the kiloamperes interrupting capacity rating. That's why this is called, usually called the KAIC. But this is the term for ANSI. No? For IEC, I think Engineer Russell kanina discussed about the breaking current. So this is synonymous to the breaking current. No? So as per definition, highest current at rated voltage that the device can safely interrupt, no, under standard conditions. Usually rating in kiloamperes. Okay, that's why it's the KA. No? You can see that in our nameplate ratings of our circuit breakers. No, so you just look for this one, no? The 50 KA. No, that's what we call interrupting. We have examples for this one later on. Okay. So now short circuit analysis. Okay. What is the purpose of such? Just to... So this analysis is used to determine the fault duties, no? Or the required short circuit values, no? Of our circuits, no? In the system, no? So this is, the result of this one is what we use as a reference to specify our equipment, no? So if you do short circuit calculation with the analysis, you will now determine the rating, exact rating, no, or the proper rating that you have to specify in your equipment. So if it's 10,000, 15,000, etc. No, so we have to do short circuit analysis first before we specify. Okay, that's the bottom line. Sorry. So. Okay, so there's a lot of functions aside from interrupting ratings, no? And just to move this way. So, aside from interrupting ratings, they can be used for relay settings, no? For coordination, protection coordination applications, okay? But for this specific lecture, I'll be focusing only on the equipment ratings, no? Will not be touching on protection and coordination. So it can be used to determine the maximum and minimum three-phase short circuit currents and other faults, no? Like what we discussed kanina, the single line to ground, line to line, and double line to ground faults. Okay. So for relaying, that's what we discussed, no? So this is just the objectives of short circuit analysis, okay? So just to put it in a nutshell, no, after you're conducting a fault current calculation, no, either by hand or by software, no? So you tabulate now your calculated values, okay? Then you specify the appropriate interrupting capacity, no, for OCPDs. So like circuit breakers, not only interrupting but also withstand ratings, no, of our equipment, because not all equipment will interrupt. Some, like disconnect switches, they will not interrupt. They just still be closed, no. They cannot detect the fault current. So for those equipment, that's what we call the withstand ratings. They will not be destroyed when a very large current are passing through them, no. So different application, no. That's what they call the withstand ratings instead of the interrupting. So interrupting ratings is for circuit breakers. Withstand ratings is for disconnect switches and other equipment like bus bars, no, and other supports, no, bus bar supports. Okay. So short circuit analysis. Okay, this is a repetition, ano, na used for interrupting ratings for our various devices like fuse, circuit breakers, etc. Okay. Now we move now to the components of short circuit. So Engineer Russell a while ago discussed about, no, the factors affecting in specifying the ultimate, no, or the exact interrupting ratings. So in ANSI also, we have other factors to apply before we specify finally, with finality, the interrupting ratings or the withstand ratings, no. Different approach lang. Yung sa IEC, they are using K factors, no, other multiplying factors, because in IEC it's a current based, no, calculation. For ANSI, no, okay, sorry, no. So for ANSI, it's a different approach, no. So it's a impedance based calculation. So we have to know the components that comprises to determine the final short circuit ratings of our equipment. But for this one, I'll be focusing on low voltage circuit breakers lang, no? Not excluded yung medium voltage, okay? So the short circuit components for our interrupting ratings, no, or withstand ratings, is composed of basically two components, no. The I total is what we call the short circuit duty, no. Short circuit duty na we require as reference for our interrupting ratings. Okay, so the components of this one is the steady state current, no, in AC, the AC decay, because in a half cycle, no, it's usually larger at 1/2 cycle. So 1/2 cycle pala is a 0.5/60 of the, when we terms convert it, no, from frequency, no, when we want to determine how many seconds is that, no. So you just divide the 0.5/60, that's the how many seconds in terms of milliseconds, no. So in that period, no, like symmetrical current, no, at half cycle. So this is what we call the sub-transient symmetrical current, no, at this stage, no. So after so many cycles, like 1.5 to 4 cycles later, no, this one will decay. So until it reaches the steady state, no. So that's the nature of our short circuit current. It will decay because the sources of faults, no, like motors, synchronous motors, no, generators, no, their impedances will increase in time. So conversely, the short circuit currents will also decrease in time, no, until they reach the steady state. Okay, so that's what we have, what we call the sub-transient at 1/2 cycle and the transient at 1.5 to 4 cycles later. So low voltage breakers operate at usually 1/2 cycle. They are very fast, no? So the moment there's a short circuit, it will detect immediately, no? First half cycle of incipient of fault, no? So this is the largest current that the equipment can detect, no? Or is experiencing. Plus the DC decay, no? So it's not only in AC current that is a component of short circuit, we also have the DC decay that is influenced by the XR ratio of the system. So the bigger the XR ratio, the bigger and the longer the DC decay, no? So the highest contribution of the DC is at the half cycle, no? So this is the total components that we need to determine before we specify the KAIC rating of the breakers. So AC, short circuit current, steady state, and with AC decay, no? And plus the DC decay, okay? So we will be presenting waveforms for that, for proper or for much better visualization, no? So this is the half cycle moment, no? At this period, okay? So normally this is our symmetrical current, no? This one. When we say symmetrical, it is balanced or equal along the x-axis, no? The positive and the negative waveforms are equal, no? But since, no, there's a DC component now, this one, it will shift its axis, no? So as you can see, this waveform is now asymmetrical, no? They are not equal now because at the x-axis, the positive is larger than the negative. So this is what happens to our system when there's a DC component added to it. So at this period, malaki pa. Until it slowly decays at this period, until this period, until it reaches, no, the DC component will be eliminated after so many cycles, no? Until steady state na lang yung current. So the steady state current will sustain until the short circuit breaker is tripped out, no? Is tripped out. So if we have a defective circuit breaker, then it will not trip out immediately. Then the symmetrical component or the symmetrical current will sustain for how many cycles, no? Okay. So another illustration, no? Okay, this one, total is this one, para mas clear, okay? So half cycle, then after one cycle, the 1.5 cycle, where is it? 1.5 is this one, no? So after this one, mas maliit na yung short circuit current, no? Kasi nagdi-decay na until 4 cycles later. Okay. Usually, medium voltage breakers operate from 1.5 to 4 cycles. No, that's why they have 2 different ratings, no? The interrupting and the momentary. So for medium voltage breakers, this is the momentary rating, and 1.5 cycles later, this is now the interrupting, this period here. This is the region where they start to detect until they clear the fault. Mas slow yung medium voltage. Do you know the reason why? No? And even for larger breakers, sometimes, no, they have a delay, inherent delay. This is designed specifically because when we do selective coordination, no, or protection coordination, when the fault is at the downstream, which circuit breaker should be the one to first strip out? Is it on the main or on the branch? On the branch, di ba? So, meaning to say, we have to let the branch circuit strip out first before the main circuit breaker will operate, di ba? Because what would happen if the main would trip out first? Everything is gone, no? So that's the wisdom of this principle. That's why low voltage circuit breakers must operate faster than the medium voltage. So they operate at this region. And then later on, after many cycles, if the fault sustains because of the defective circuit breaker here, then this one serves as a backup. So this one will not rip out. But now a larger area of the system is compromised. That's the kwan lang. That's the trade-off if we have a defective circuit breaker. But that's the principle is you have to let the downstream breakers first operate before the medium voltage, okay? Or the upstream. Okay, so just to emphasize again, this is the 1.5 cycles. As you can see, mas maliit na yung short circuit value at this period, di ba? Compared to this one. So the DC component is this one, no? As you can see, no? It's just this waveform is being superimposed with this value here. So if we try to graph this waveform plus this one, this is the total, di ba? So as this decreases, so as this waveform also follows, no, through until the DC component is extinguished at this period, no? So as you can see at this period, mas maliit pa rin, no, until it reaches symmetrical steady state, no, until the fault is clear. Okay, so that's the behavior of our short circuit current. So as we can see now, no, as heads up lang, this period here is the largest current being experienced in the system, no? So when we rate our low voltage circuit breakers, usually when we do short circuit calculation, the answer that we have is only this value. So if we base that CAIC rating on this value, do you think this is enough? No, no? Because we have this one, we have not accounted for this one. So this is the purpose of our lecture right now, to determine how to determine the final value of our short circuit rating. Okay? So usually when we do short circuit calculation in terms of RMS, this is RMS. But for final rating, this is not enough. We need to determine the final exact value, total value. Okay? So moving on, nagka-interesting na yung kuha natin. Lecture natin, no? Okay. Sir Bob, please remind me of our time, no? So that I can adjust the pacing of my slides. Okay lang, Sir Bob? Okay, just skip ko na lang ito, ha? Yeah. So this is just the principle, no? I'll give you the slides for further study, okay? So again, we discussed about the impedance networks. When we try to solve this one, no, we need to determine what type of impedance network should we using, no? We recall kanina we have two types, no? We have the sub-transient and the transient. Okay, just to guess, what type of network should we be applying for this period here? Is it the sub-transient or the transient? Anybody from the virtual audience? Okay, come on.
The first up, sir.
First half cycle, this one.
Subtraction.
Okay, subtraction. Why? Okay, just to make things lively, okay, we have audiences here in the training room, no? So as the term connotes sub, no? It's below transient, diba? So the period of that is much lower or much, or if you say in time period, transient is sudden. But if you say sub, it's much faster than sudden, diba? So which is much faster, this period or this period? So this is period, no? So that's why we use the sub-transient. Now the impedances for this one, the values, by the way, for the reactances or impedances is, what do you think? Lower or larger than the transient? what is the relationship of current and voltage in current and impedance in Ohm's law or resistance in Ohm's law? Inversely proportional, di ba? So we say kanina this one is the largest current. Now, why can we say that this is the largest impedance here? Is it true or is it false? Okay. So Ohm's law lang ha. So we need to say the impedance values at this period is the smallest that can be experienced in the system, no? Until the impedance at this period increases, no? Okay. Kuha na? Okay. So we have to be careful in our impedance modeling. We will not be discussing short circuit calculation, but just the principle. So you will know what to expect, no? The answers that you will expect. Because if you will use the transient impedance at this period, what do you think about the current? What is the value? Is it larger, the largest, or not? No, if you use the value of transient at this period, it's going to be smaller, di ba? Because the impedance at transient is bigger than the sub-transient. So if you have made a mistake using the transient, because transient impedances are given in our tables, if you apply the transient at this period, then looking for the interrupting rating of the low voltage, it will give you a wrong answer, no? Wrong rating. So we use the sub-transient, okay, at this period. Okay. So here we have the example of the sub-transient impedance network at half cycle, no? So we have a 15 MVA transformer. I don't know if it's clear at your end. We have 8% impedance of 6% of the transformer and XR ratio of 25, no? So we have a fault here in this motor, no? So we are evaluating 1,200 amperes. But then again, because I'm focusing on low voltage circuit breakers, I will not be touching much on this one. This is just to represent, no, the impedances that we need to gather in solving for the short circuit. So we need to have the sub-transient impedances, sub-transient of the cables, of the motors, and other components, no? So for values of sub-transient impedances, I have given a table here as reference na, no, para hindi na tayo maghanap ng kahit saan, no? So may typical values tayo pag wala tayong makuha sa manufacturers, okay? Okay, so we need also to have the XR ratio. This is very important when we apply now for the final short circuit current or rating, no? So we have typical values, no? If our utility will not give us one, then we can use this table, no? So just be mindful lang of the location of the fault, no? For especially for generators or for mains, no? If it's supplied by a generator, no? So if it's a remote or long line, use this range of values. If it's a near a step-down substation, much higher XR ratio. And if it's a near a generator station, the largest, no? Meaning to say, the nearer you are to the source, the slower the DC component decay. The larger that your fault have to be evaluated, diba? We discussed the DC decay kanina, no? So if you are far from the source, you have a smaller XR ratio, you have a faster decay of DC component. Okay. So kanina na-discuss din ito kay Sir Russell, but it has the same concept but a different application, no? Okay. So sa utility, no? Meron tayong mga examples. Anyway, these are the formulas that you'll be using, no, for finding out for the impedances, no? I will not be discussing so much on this one because this will be tackled in the short circuit calculation, but just for reference, no? Okay. The positive, negative, so for unbalanced faults, no? Okay, so we can use this one, the impedance equivalent. Okay, so again, another example, no? Usually, if you have a utility impedance, no, at its own base, it's rated at 1 unit, 1 per unit, no? So if you have an XR ratio, no, you can solve now for your per unit impedance, no, of the actual, of the per unit of the utility, converting it to a new base. So for example, if you have a 3.5 MVA, no, 3,500 MVA, and you use a 100 MVA base, if you compute for per unit impedance, no, you can use the XR ratio value, no, of 15. So the XR ratio is a relationship of tangent theta, no. So the theta, no, is the inverse tangent of XR. So if you have XR 15, solving for the inverse tangent of the one, we have the theta of 86.9 degrees. Okay, so we need to use this this value here, no, in order for us to get the per unit in rectangular form later on. Okay, so this is a very helpful tool to determine the per unit of utility at a different base. Okay, so this is a example of a software output, no, just to make a comparison. That is the same answer. Okay, so table of impedances, no, pag wala tayong nameplate rating na makuha sa transformer, we have typical percent Z, no. So ito lang magamit ito pag sa short circuit calculation, mag-conduct tayo, wala tayong data, pwede natin magamit ito, no. So for certain KVA rating and type of transformer, liquid or dry, no, so we have percent Z, typical values. Okay, but it's still best to get from the manufacturer para mas accurate yung kuha natin. But worst case scenario, pag wala talaga, we can use this table. Okay, so just skimming through, no, just skimming through. Okay, so again, this is just examples, no. You can skim, you can scan it through, no. The same lang ito kanina. So getting the per unit impedance of our transformer. Okay, so we have to move further na. For cable impedances, meron tayo ding data, meron din sa PEC. So just cross-reference lang, no. If the but the PEC usually don't have much data for medium voltage. Usually low voltage yung impedances natin. Okay. Okay. So these are just some examples. Hindi ko na lang ito much further explain. If you have short circuit calculation, you can understand, no, how this calculation was made. We have to move further lang sa. Okay. So for motors, like we said kanina, this symbol here is what we call as sub-transient reactance, no, of the motors. So since we are evaluating for half cycle, everything must be in sub-transient values, no. So we need to have this value here, no. There's a lot of approach, no, for finding for sub-transient reactance. We can use a table. We can also use this formula here, no. Okay. So if we want to solve for the sub-transient reactance, and we are given the full load amperes and the lock rotor amperes, no. So we can still get the sub-transient, but we have to get the lock rotor amperes first, no. So we have this table here, no. So you have to determine the code letter of the motor, because for example, if you have a motor of code letter G, the kVA per horsepower for that is this one. So meaning to say, if you have a 5 horsepower motor, then the lock rotor for that, in terms, no, it's 5.6 times, no. So per horsepower. So the lock rotor KVA is 5.6 times 5. How much is that? Almost 25, no? KVA, or more than 25 KVA per horsepower. So that is 25 KVA is the lock rotor KVA. No? Then solve for amperes. So what is, you just divide KVA by the rated voltage. So we have now the lock rotor amperes. So divide the full load current over that answer, you can now have the subtransient reactance value. Okay? But again, we have typical reactances. No, if tinatamad tayo mag-compute, so diretso lang tayo sa table. But then again, cross-check lang, no? If within pa rin, no, sa difference. So if we have induction type motor for standard efficiency, usually yung subtransient niya is 16.7%, no? For synchronous motors, seldom naman ito. So we have in terms of RPM, no, low, if it's a high speed or low speed, or for the certain number of poles, then we use this table. Just be mindful of what is the RPM or the number of poles on that certain synchronous motor, so that you can select the proper reactances to be used. Okay? So ito, no? Kasi ang mga motors, usually yung nameplate nila, they have no subtransient reactance information. That's why we have to extract that information. We have to calculate the subtransient reactances. Okay? So for XR ratio, if wala tayong XR ratio ng motors, we can use this chart here for typical values, no? So, like for example, if you have a 50 horsepower motor at high efficiency motor yan, how much do you think is the XR ratio? So, how much is one? 11, 12? No? Oh, that? It's like 11 or 12, no? So you can use that. Just be mindful if what is that type of motor. Is it a high efficiency, a medium efficiency, or low efficiency motor? If it's high efficiency, you use this curve. If it's medium, you use this curve. And if it's a low, you use this curve. For certain horsepower, you can just intersect this one, no? You can get the value for XR ratio for our motors. Okay? So it's not an excuse anymore that we will not be having XR ratio values for motors. We have this table from IEEE. Okay? This is for synchronous. This one was for induction. This one is for synchronous. Okay? If you'll be solving for single line to ground fault, you'll be needing the negative sequence reactance. You have this relationship, no, for motors. Okay, so the negative sequence reactance is 1.1 times the subtransient for 2-pole, and for more than 2 poles, it's 1, no? So simple as that lang. Okay, you'll be understanding that when you conduct, when you perform the short circuit calculation. But when you need those data, just go back to this table as reference. Okay, I have 5 minutes na lang, no? I will have to skim through. This is the most important part. So, just for example, nakuha natin yung fault current natin, no? Ito na yung we mentioned kanina na RMS symmetrical, no? 11,000 amperes with an XR ratio of 23.48. By the way, the XR ratio is just dividing the total X or reactance over the resistance at the fault. At the fault yung summation na ng lahat, yung Thevenin's equivalent na reactance na. So, for example, mayroon itong value. Now, you have this value. Do you think direct na tayo makaspecify? Hindi pa? Ikaw, kung may standard sa market na 15 kA and you have this fault, do you think it's sure na 15 kA yung specify mo? Di pa, di ba? Because of those steady state and other components na hindi natin na-account because ito lang yung RMS symmetrical, pero yung asymmetrical hindi natin na-determine. Di ba? Okay. So, how to do that? How to determine? Ito na. Ayan na. Okay? So, by the way, just a heads up, the low voltage circuit breakers are rated in symmetrical amperes. But we'll be wondering, symmetrical, bakit kailangan natin i-determine yung asymmetrical? Because we need to apply the appropriate multiplying factor to account for the asymmetrical, the AC decay and the DC decay. No? So this is what it means, the multiplying factor peak times symmetrical RMS. So there's a formula, no? In our, you can see that in our violet book, no? The multiplying factor for the peak is the square root of 2 quantity 1 plus exponent to the negative 2 pi t over x over r. Nakita yung x over r? Di ba? So kung wala, hindi tayo natin na-determine x over r, ano mangyayari sa equation natin? Erroneous na. Di ba? Kasi nandito ito. So that's how important is the x over r. No? This one, ma-derive natin ito, no? With this equation, yung t. No? So meron pa rin yung x over r. Hindi talaga mawawala yung x over r. No? So the 11,000 amperes, ito yan. But we have to determine for the multiplying factor for the peak, no? Okay. So i-apply natin. Okay. Oops. Okay. So ito yung basic formula nung yung kino-compute natin, no? Okay. Hindi na tayo nag-touch na. Meron din tayong tinatawag na asymmetrical RMS. Ito yung usually ginagamit doon sa withstand ratings or for those fuses, no, that are rated in asymmetrical. But usually for circuit breakers, it is rated in asymmetrical peak. Ito isang mga fuses tapos sa withstand ratings ng mga bus natin. So different formula lang yung multiplying factor niya, no? But the important thing is when to apply, no? Ito is for the circuit breakers. Ito is for the fuses and other withstand ratings. No? Okay, so ito lang, may table tayo, no, ng XR ratio just in case na wala tayong information. Okay? So again, there's two approach. Okay. Just to get the formula out, to have the clearer picture, no, again. So ito yung asymmetrical peak short circuit current, no, with the multiplying factors. Ito yung momentary rating ng circuit breaker natin, no. If we use the 2.65 times, no, so meaning to say 11,000 yung answer natin kanina. Ito yung multiplying factor niya sa peak, no? So hindi natin ito magagamit because this is just a withstand rating for the circuit breaker, no? This is a closed latch rating, meaning to say pag may fault na yung system mo, tapos i-turn on mo yung circuit breaker, ito yung rating na ma-handle niya, na hindi siya masisira, no? So you have to specify the for asymmetrical peak, the closed latch rating at 31,000, no? So meaning to say we have to determine magkano yung closed latch rating duty ng system. So pag yung specify natin sa circuit breaker is below this one, pag nangyari yung sinabi natin kanina na may fault na existing fault na, tapos na-turn on ka ng breakers, ito yung dapat withstand niya. So you have to rate the breakers beyond 31,000. Okay? Ito yung interrupting ng circuit breaker, no? So when you saw for the multiplying factor, you got the answer for 1.588. Then multiply that yung answer natin sa RMS symmetrical, ito na yung ultimate or the final interrupting rating. Di ba? So yung sabi ko kanina, 15 kA, enough ba yun? Hindi. Di ba? Because of the very large XR ratio, 23. Pag maliit lang ito, posible. No? Kaya yung 15 kA, pero malaki eh. So, it might be near ito ng isang generator. No? So, 18,000 yung kailangan natin. Yung 15,000, hindi pala enough. So, that's the danger now if we will not account for the asymmetry of the short circuit current at 1/2 cycle. Pag mata-mata lang yung pag-determine natin na, sige, 11,000, slightly higher, 12 kA, okay na yan. 15 kA, okay na yan, di ba? Yun yung usual natin ginagawa, basta mas malaki lang. Pero hindi pala. I-account pa natin yung XR ratio to get the multiplying factor required, which is this one. Di ba? Nakita yung XR ratio dito. So, solving for this one, we got the 1.5. We have to multiply it with our answer. This is the talagang the true CAIC rating or duty that we need to specify. Okay? So ito yung kaibahan, no? So I think I'll be this one na lang for further one, mataas pa sana ito eh, no? Meron pa.
Okay, mga 15 minutes.
Oh, 5 minutes. Oh, okay. Sorry, sir. So, may 15 minutes pa pala. Okay, sige. So, medyo napakuan yung kuan natin, no? Okay, let's go back, no? So, if we try to solve lang, no? Again, another example. Just try, no? Example lang, no? Magkuhan ka ng multiplying yung XR ratio na maliit. So, let's just say, may calculator tayo dyan, no? Let's just use this formula, no? Yeah. Pero yung baka mahirapan kayo mag-calculate doon sa E, yung LN, no? So, anyway, just try using a lower value of XR ratio, then you can see mas maliit ito, no? So, that's the significance of the XR ratio, no? Because that influences the DC component decay. So the bigger it is, the higher the asymmetrical, no? Okay, so mga examples lang, mga typical values lang ito ng subtransient, no? Well, you can see subtransient if you have the symbol for that is double apostrophe, no? So when you see this one, it's usually the subtransient reactances. No? So for induction motors, we have IEEE typical values, no? For larger than 1 horsepower and with RPM of less than 1,800, ito yung gagamitin natin, no? For half cycle, no? In relationship, sorry. Ito. Sorry, ha? Okay. So this will be used for short circuit calculation. The important thing lang is what to apply, ha? Subtransient reactances. Okay? Now, this is the type of equivalent short circuit ratings applied, no? So at half cycle, yung subtransient network for medium voltage breakers like what we discussed kanina, sa half cycle ito yung close latch, yung pinakamalaki, no? Yung 2.5, 2.6 times, nakita nyo kanina sa solution, no? Ito yung rating niya, yung umaabot ng 30 kA, di ba? Kita nyo kanina. So, for medium voltage, dalawang ratings yan. Close latch or momentary and the interrupting. So, the interrupting capacity is much smaller na, no? Much smaller na because 4 cycles later na, so ang yung transient na rin yung gagamitin, no? Like I said, hindi ko sana gustong i-discuss pa muna yung medium voltage, but just give you a heads up na anong kaibahan ng value of short circuit current from closed latch or half cycle and 4 cycles. So medium voltage, dalawang rating. Yung low voltage, isa lang, no? Symmetrical lang. Pinag-simplify yan ng IEEE. But for medium voltage, kasi may delay. Di ba? Yung sinabi natin kanina, dapat hindi mag-operate yung upstream device para maka-operate muna yung downstream. And usually the downstream are the low voltage circuit breakers. Very fast. But this one is a delay from up to 1.5 cycles. No? So just for clarity, please, ilang seconds yan? 1.5 cycles. 1.5 divided by 60. Ilang seconds yan? 0.25 seconds, di ba? Okay. 0.25. Okay. How much is 1/2? Divide by 3 yan. No? O 0.25. So 0.25 divided by 3. No? Kasi half cycle yan. No? Okay. So very fast. No? That's how fast our circuit breakers, low voltage breakers operate. Ilang seconds? 0.008. So 8 milliseconds. No? Yung isa is 250 milliseconds. Very big difference sa delay. So kaya nga may dalawang rating yung medium voltage kasi at the first half cycle, it will not trip out but it will withstand. No? It should withstand the required short circuit current at that period. No? So then pag hindi nag-trip talaga yung downstream, siya na mag-trip, ito na yon. Mas maliit na rin na current yung iti-trip out niya. Okay? So, for low voltage, isa lang, no? Interrupting. Kasi half cycle lang siya. Yung momentary niya, the same lang yung current, tapos, tsaka yung interrupting, the same value lang, no? Kaya isa lang. Yung fuse is interrupting but in asymmetrical value, no? Yung sa mga withstand rating is bus symmetrical rating. So yung 11,000 mo kanina, much higher, a little higher than that, pwede na yun for bus bracing. Yung hindi ba kuan yung bus bars natin, hindi mawasak, no? Yung bracing niya. So i-rate mo lang a little higher than the 11,000. Okay? Ito yung ibig sabihin niya, no? Then for protective relays, instantaneous settings. So yung power cables, thermal withstand. So there's a lot of short circuit currents that we have to deal, but we just have to know which one to use for certain equipment. That's just the bottom line, no? Okay. So typical ratings for medium voltage breakers. Okay. So yan, different brands. Pero wala akong pinagkuhan na brand, ha? I'm just using lang those that have available standard data. Okay? Yeah. So, like I said kanina, for a medium voltage circuit breakers, this is an SF6 type circuit breaker. We have in fact 3 ratings, no? Meron siyang symmetrical, no? Meron siyang asymmetrical. Asymmetrical ito, ha? Hindi yung kwan. Okay. And we have the asymmetrical peak, no? Or kung sa IEC pa is making current, short circuit making current, kung saan it's closed latch rating. So ito yung pinakamalaki. Yung asymmetrical peak is 125,000, no? Yung symmetrical, ito yung interrupting na niya, it's 61,000. Yung symmetrical is 50, no? Okay. Pero ang gagamitin lang talaga natin yung kwan is yung 50, no? But depende talaga sa XR ratio. We have to be mindful of the XR ratio, okay? So this is the difference of medium voltage circuit breakers. They have 2 or 3 ratings. No? Okay. Ito lang yan, no? But for low voltage breakers, isa lang. Ito lang yan, no? Okay? So, ito lang, 65,000, no? So yung answer natin kanina na 18,000, dito mo yan i-compare. No? So, 18,000, malayo pa yan sa 65,000, di ba? So, walang problema. Parang natutulog lang yung breaker natin pag mag-trip out. No? Okay. So, pero ang problema, pag oversize mo yung, much oversize yung kaig rating mo, anong problema? I-kick out kaya ng amo mo. Kasi mahal na yan. No? Kaig is expensive, ha? So we have to do as much as we can accurate calculations. Baka sisipain ka na ng amo mo. No? So we have to be mindful pa rin. No? Okay? Okay, so 5 minutes more. So just some more examples for logo nameplate ratings for our equipments, no? Okay. By the way, ito yung calculation, but we have a table for shortcut. Na hindi lang po na muna pinag-discuss, no? Para magkuhan kayo. But we have a table from IEEE Blue Book, no? Diretso na. Okay. You can compare actually, no? Hindi ko na kuhan dito. Anyway, I'll give you that one, no? Kasi hindi ko akalain na abot pala dito. So, I will give you that table for comparison for faster na lang na evaluation. So, the table there consists of a XR ratio and range of kaig ratings, then the typical specify mo na yung interrupting. Okay? So, yun talaga ang pinakamadali sa Blue Book. Pero wag lang muna kasi baka tatamarin na kayo mag-compute. Okay? But you can do a comparison talaga. No? So, I think I got the wrong slides. Okay? So, that's it for me. And thank you very much. So, we still have time for Q&A. Okay. Okay,
Sir
okay.
Brian, thank you very much for sharing the idea of current. By the way, current and voltage are invisible. So meaning to say, we cannot see them both. However, we know it's cause and effect. That is why for current must be taken care of because there'll be fire or you might get electrocuted. So if you're planning again to be a PEE or professional electrical engineer, this short circuit calculation and tripping coordination, it will be done in details with Sir Brian. So let us go to the question and answer portion. So here, Sir Brian, we have here a question from Anonymous. Shall we entertain this, Sir Brian, with the anonymous attendee?
Yes, yes, okay lang, Sir Bob.
Sir Brian?
Yes, yes, okay.
Shall we entertain this anonymous attendee? Okay.
Yes,
So, Mr.
yeah.
Anonymous attendee, why is it that OBO requires the short circuit calculation in all electrical plant, including small kubo, less than 4 LO, where in fact it is best applied to motors, impedance, or shall I say, big loads? Obo na, sir.
Okay. So the perennial debate, yeah, good question. But yes, it might be a small combo, but its power supply is coming from a 250 kVA transformer, no? But just for one lang ha. Anyway, the common supply transformers for those areas, usually it would mga 25 kVA, no? The common transformer supplied by utilities. As per experience talaga, yung 25 kVA transformers, usually yung mga kaig ratings niya na ma-determine natin is less than 10 kVA. No? Usually 75 kVA up, yun na yun mag-exceed ng 10 kVA. Yes, that's a valid question, but as engineers kasi, no, we need to be consistent with our designs, no? So para may basis talaga tayo bakit nag-specify tayo ng 10 kVA, we have to do short circuit and design analysis in our plants just to prove na talagang na-determine talaga natin yung required duty, even though small kubo lang yan. No? But I know the practicality of the calculation, but really we have to be consistent lang as electrical designers. Even though medyo talagang hindi na practical sometimes kasi maliit talaga, no? But for good measure, okay din naman na mag-conduct tayo ng short circuit calculation para kasi pag ang design mo is puro kubo lang tapos hindi ka mag-perform ng short circuit calculation, malilimutan mo talaga yung short circuit calculation, no? Para nag-exercise lang tayo, no? So para sa akin lang personally, kasi dinirequire ito ng BE natin na to provide this analysis. Wala kasing exception, no? Kasi sometimes, no, hindi natin alam saan nanggaling yung kinuhanan ng source ng bahay kubo. It might be nag-share siya doon sa isang malaking transformer. Kasi walang ibang supply doon na talagang available. Yun lang, no? Pinahiram siya ng neighbor niya, ng malaki, no? Although it's illegal tapping na in a sense, no? But just in case lang, no? Yun yung wisdom bakit even the small kubo ay pinag-require ng design analysis, no? But anyhow, pag master ka na ng kuan, alam mo talaga na pili na sanang wala, no? Yeah. Master kubo, no? But just for good measure lang, no? So that's the explanation, okay?
Right.
Thank you,
This
sir.
is just to prove. So right, this is to prove that the one who make the plan is an electrical engineer. If you are not an electrical engineer, you cannot
Correct.
compute that.
Correct.
Now,
Kasi
next,
marami tayo.
question from Mr. Joel Musilio, our buddy. From our buddy, Sir Bry, ang result ng computer program ng short circuit, for example, 63 kA, kailangan pa nating multiple ng factor ayon sa formula na nakikita mo. Hindi pala. Ang 65 kA tapos decide tayo na gagamitin slightly higher. Thanks.
Okay.
Joel Musilio.
Yeah. Yes. Depende yun sa modeling ng software mo, Sir Bob, no? May data kasi ka ma-extract yung asymmetrical current, no? Just have to be mindful lang ano yung pinag-display mo na data kasi yung software natin makompute niya lahat nandun na yung XR ratio, nandun na yung other reactances, other situations na kailangan ma-incorporate. It's just a matter of displaying the data, no? So it's just a matter of displaying the data talaga. So if you have that display the data na makita mo yung asymmetrical peak or asymmetrical RMS, then just extract that data, Sir Joel, no? This is for talaga manual calculation, but for software you have to select the option that the data displayed is asymmetrical RMS or peak na talaga. Then when you have that one, then that's the one that you have to use na. So Sir Joel, you just have to be mindful lang yung ano yung pinag-display mo na data, okay?
Okay, sir. Right, last question from the anonymous attendee. Good afternoon. Question po. If ang standard po ba ang medium voltage or or high voltage circuit breaker, nyo ba is IEC or dapat IEC is CC? Po dapat gamitin or pwede pa rin gamitin ANSI sa STC ang gamitin sa evaluation po?
Yes, actually, the IEC standard applies to all, medium voltage and low voltage. Walang kuan yan. Walang walang distinction yan, no? The thing is, you have to be consistent lang. If your equipment is rated in IEC, you have to use the IEC short circuit calculation considerations. If it's in ANSI, then use ANSI. So, yun po, sir. Pag IEC, ANSI, regardless of voltage rating. Okay.
Yes, sir.
So
Thank
is it
you.
okay?
So, awarding of certificate. May I request?
Okay, thank you.
Okay. Last question na, sir. So, awarding of certificate to be given by our president of IIE Cebu chapter, Engineer June Baclay. Sir June?
Good afternoon. The IIE Cebu chapter awards this plaque of appreciation to Engineer Brian A. Pasilan, PE, as Technical Resource Speaker on the topic Application of Short Circuit Current Determining Interrupting and Withstand Ratings of Low Voltage and Mid Voltage Overcurrent Protection Devices at the 51st Eastern and Central Visayas Regional Conference, held on 27th to 30th day of July 2022 by a hybrid at the Sky Hall in A and B of SMC site South Road Properties, Cebu City. Given this 27th day of July 2022, signed by yours truly and by Engineer Runmar Gonzalez, VP Technical Affairs, and Engineer Erwin J. Salvador, PE, Technical Consultant and Advisor. Sir Brian, congratulations.
Thank you very much, IIE Cebu. Thank you very much, Sir Bob, and thank you for the opportunity of sharing, and wishing you good afternoon, everyone. Okay.
Okay, thank you, Sir Brian. Our next speaker to be properly introduced by Engineer Noel Ratelia. Sir Lowell. Sir Lowell.
For a while, Sir Bob,
Sir Lowell.
may technical difficulties lang.
Okay. Okay.
Okay, so our next technical speaker is a graduate of Bachelor of Science in Electrical Engineering at the University of San Jose Recoletos. He is a former electrical instructor at Don Bosco Technical High School from 1989 to 1992. He was a former project management officer of the United Nations Industrial Development Organization, UNIDO, from 2012 to 2015. Currently, he is the technical director of SunInvest Solar Technologies from September of 2017 to present. He was the IIE Cebu chapter treasurer for the year 2020, and he's also a BOD for the United Filipinos trained in Germany Incorporated for the year 2020. His specialty is in design and installation of solar PV systems, solar PV training, and energy management consulting. He was awarded by the Japan International Cooperation Agency as certified solar PV trainer last 2005. Currently, he is the IIE Cebu chapter president. Without further ado, I would like to introduce Engineer Magdaleno M. Baclay Jr. A warm applause.
Sir Noel Ratelia. My topic this afternoon is about the importance of voltage drop calculation in solar PV systems. A topic that we electrical engineers has to really master, because if you notice right now, there are a lot of solar installations, and most of them probably are installed by non-electrical or non-licensed electrical practitioners. Because if you ask many of them, why did you size your, for example, your wire from the inverter to the battery in that size? You cannot answer. You just said, because this is the Malaysian standards, like that, but they cannot show numbers. That's why we electrical engineers are the ones, no, that are most fit to do this. And the problem is, well, the topic is a very basic topic in electrical system or electrical engineering or electricity. A very interesting thing about this topic is that when I was working before with the Department of Energy, way back in 2005, many years ago, when this topic is given as an exam, no? Even license ECE or sometimes even license EE, cannot, out of 20, no? Only 5 will be able to calculate correctly the problem. Of course, we're not saying that you don't know what about theory, but the problem is the understanding ba of the circuit. So, the carelessness lang siguro ba, no? Why they're not able to calculate properly the voltage drop. So, in fact, in the years that I'm doing the training together with JICA, kinig yung kuan, no? Itong voltage drop calculation, ito yung makita na kung maraming mga electrical practitioners have difficulty of calculating. Now, since our focus is solar, I'd just like to describe a little bit what are the components. So as you can see from this slide, the main components are, of course, if you are off-grid, there's the battery. Then you have the charge controller for protection of the battery. And your power source, the generator in the system, is the PV module or solar panel. And then you have DC appliances if you are using DC, DC system like DC lights or DC fans, for example. Or if you're using AC appliances, you'll be required to have a DC to AC inverter, so that you can use your AC appliances. So, ganito lang, no? The system is basically composed of very few components. But the problem is, as I said, because of its simplicity, a lot of people are able to install, even the non-licensed. In fact, just last week, I visited an installation here in Cebu, somewhere in the north. I asked the installer, what is your background, sir? And he said, he's just a graduate of non-technical ba? But he just attended a 3-day seminar somewhere, no? And he's able to calculate, he's able to install. Because they're given just the list of materials, then if you have the list of materials, you're given all these materials, then you can install, of course. But the problem is it properly sized or properly installed? And then are they using the proper components as well? Which is in most likelihood they're not using, because they're not experienced electrical installers. That's why I want to emphasize in this presentation about the issue of voltage drop, because in most cases where solar PV systems are installed, memorize lang ba? Memorize lang yung sizing ng wire. For example, from the solar panel to the inverter, diretso na yan. 4 mm² or 6 mm² na solar cable. Kasi nandyan sa market yan ang mga binibenta ng wire. So, parang memorize na ba? And then between the charge controller or inverter to the battery, 35 mm² dyan na wire kasi yan ang nandyan sa mga suppliers. But without calculation, the problem is walang calculation. So dapat we have to understand how to do the process of calculating. That's why I'm giving this as the presentation. So the topic is voltage drop. Now voltage drop, of course, for the name voltage itself, we know by the formula of Ohm's law, to get the voltage, you have current and resistance. You multiply mo yung dalawa, you get voltage. So in this case, kuryente. So let's say for example sa solar, by the way, take note when I showed you the components, there are sections of the system, right? Sections, like from the solar panel to the controller, that's a section. No? Another section is from the controller to the battery. No? And then from the, let's say, battery to the inverter or controller to the inverter. So this is another section. So take note of that, because in every section of the system, iba-iba yung ano natin, iba yung mga parameters that you have to consider in calculating. So ito yung basic formula, voltage drop, current times wire resistance. As we all know, ang kuha natin, mga wires like copper wire for example, meron na yan, merong resistance yan. Because wala pa tayong tinatawag na superconductor na medyo affordable or readily available in the market na walang resistance, zero resistance, no? So talaga lahat ng wires na magbenta na ma-procure natin, meron talagang resistance. May resistance. So that means if there's a resistance, kung meron kang kuryente, by Ohm's law, meron kang voltage drop dyan sa wire. Now, it says here, voltage drop is a power loss in the cable. Why? For example, meron kang current na 10 amperes sa wire, no? And then, meron kang voltage drop na 1 volt in that wire. So what would be the power loss? How would you calculate? You multiply what? Volts times amps. Wala kang resistance. So, mayroon kang voltahe, mayroon kang kuryente, you can get power. So, volt amperes, diba? Volts times amperes equals watts. So you have voltage 1 volt, which is the voltage drop, times the R current, which is 10. So you have 10 watts power loss on that cable. Now, if you increase the current, let's say 20 amperes, the same wire, and then the voltage drop increases also, 2 volts, then you have a power loss of 40 watts. Okay, multiply ng 20 times 20 amperes times 2 volts. So that's the power loss. If you have a value of the resistance, you can use the formula na I squared R, di ba? Yung pa natin sa power loss, I squared R. So if you have the current and you have the resistance, of course, you can calculate in another way using the I squared R formula. Now, the cable resistance is determined by size and length. So, kung mataas if the wire is long, no? And then if the diameter of the wire is small, your resistance will be higher. But if your wire is short and the diameter of the wire is bigger, then your resistance is lower. So yan ang meaning nito, no? Cable resistance or wire resistance is determined by size and length. And then the current is determined by system voltage. Now in the solar PV system, one time I visited an installation. The capacity of that installation is 1,000 watts. Or meaning there were 4 pieces of 250 watt solar panels. Okay? Kasi mostly in the year early 2000 or late 2000, mga popular yung mga 250 watts na solar panel. And then in that installation, 4 pieces of 250 was installed. And then I noticed during that inspection that there were 10 batteries na lead acid ba? 10. 12 volts batteries. And then those batteries were connected in parallel. So what would be the system voltage of that installation? 12, because the standard, the nominal rating of batteries, especially lead acid batteries, is 12 volts. So kung i-parallel mo yan, that's still 12 volt system voltage. Kasi parallel. But if you put it in series, what happens to the voltage? But it will be bigger because you will add up the voltage for each battery, no? But in that example that I visited, the batteries were connected in parallel. And the solar panel capacity is 1,000 watts because 250 times 4 is 1,000. So what is the effect if that is your layout? You are using 12 volts system voltage. So if that is your layout, gabay mo voltahe, the effect is that you have a bigger current. Taas yung kuryente in that system because you are using a low voltage, which is 12 volts. But if you increase the voltage, let's say from 12 volts to, just like in this slide here, if you increase the voltage, the system voltage, what is the effect? The current will be lower. So this is also useful information in order to minimize your losses, power loss or voltage drop. You have to increase the system voltage. In this 12 volts, use this 24 volts or 48 volts. The problem is when we are installers, our problem is where to buy, where to buy 48 volts inverters, for example. No? What you can buy locally, usually 12 volts input voltage, and output to 20, no? Or sometimes 24 volts input voltage, then output to 20. And it's very rare to find 48 volts. But if you, of course, if you can find a 48 volts inverter input, sometimes it's quite expensive. No? So right now, there are hybrid types. No? You can hybrid inverters that have 48 volts DC system. No? Pwede ka makagamit ng 48 volts hybrid na inverters. Okay. So again, the rationale, basta malaki yung voltahe, ang kuryente, maliit sa system. So, going back to the example that I mentioned, yung kanina, yung 12 volts ba, yung 48 volt, yung 10 batteries in parallel. So what happens, there was a large voltage drop between the solar panel to the charge controller, as well as a large voltage drop between the controller to the battery. No? And then clearly, the installer is not an electrical engineer because the wires were very small. Nagmay wire. So, pag proper training. So again, we have to go back to the basics para ang design natin or installation properly sized up. So to reduce voltage drop, we use, of course, bigger wires if our budget allows, of course, and if the design dictates. And then, of course, minimize the length of your cables para ma-reduce ang voltage drop. And then, use also higher system voltage to reduce the current. Instead of 12 volts, you go to the higher voltage 24. In fact, as a rule of thumb, if your capacity of solar panels is already 200 watts or above, it is advised already to use 24 volt system voltage. Basta 200 watts na ba, let's say, you buy a 250 watts or you buy a 400 watts solar panel, you have to use 24 volt system voltage so that you will minimize the current and the voltage drop. Because as we said, the voltage drop depends on current, as will be explained later on. So voltage drop is critical in low voltage systems, especially sa 12 volt system, which is the most common voltage for off-grid, especially solar home systems. Now, this is an illustration of different sections, as I said, sections of the system. Let's say you have a battery, you have a charge controller, and then you have a TV set, and then you have an LED light, for example. Now, if you look at the point between the controller, this is DC or CC, this is the controller, and this junction box, VO. Now, the voltage drop here will increase increase ang voltage drop, no? When you turn on the TV and the light. Kaya nga mo dako ang voltage drop ulit. Bakit? because you have an increased current. That's why it says the voltage drop depends on current. Okay? Kung turn off ang TV, that means the voltage drop will be reduced because maliit yung kuryente. Okay? Naintindihan nyo? Nakita nyo dito na parallel yung TV at saka yung light. So, according to Kirchhoff's law, there's a node, di ba? So, current entering is equals to current leaving, di ba? So, ang current leaving is in I2 at saka yung I1. No? Those are the current leaving from the junction of PO. Okay? So, that means what would be your total current? IC. IC is equals to, by Kirchhoff's law, what would be your IC? Equals I1 plus I2. Okay? So, by Kirchhoff's law. So, that's why kung 0 yung 1, I1, which is turn off yung TV, so your IC is equals to I2. Right? Now, since you have a resistance on the wires, so you have voltage drops. Okay? Now, so these are just relationships. These are just relationships of voltage drops, no? Meaning, the DC, kung off yung dalawang switches, equal yung voltahe. DC equals V2 equals V3. Kung walang kuryente, wala kasi kuryente dyan, no? So again, but the relationships will change kung naka-on na yung mga switches. No? Basta mayroon ng kuryente. Okay? So I will not elaborate all the details about this slide. Basta the lesson here is kung mayroon kuryente, mayroon kang voltage drop. Okay? Sige. Now, ito yung sinasabi kong exam na binibigay sa mga graduate sa engineering ba? Nasisabi ko, out of 20, 5 lang ang nakasolve, no? Of course, a little bit complicated than this pala. Pero more or less the same problem. Okay, when we are calculating for voltage drop, we have to know where is the voltage coming from. Saan siya galing? So dito siya galing sa 13 volts na source. It could be a check controller, it could be from the battery, no? Basta, just understand where is it coming from. So let's say from the source is 13 volts. Now, there is a wire with a distance of 20 meters to the load, no? The load is a light. Okay? Now, it says here that the resistance of the wire is 0.02 ohms per meter. This is a copper wire. By the way, if you look at the Philippine code, no, there is a table there on the DC resistance of copper wires. Now, if you evaluate an 8 mm squared copper wire, okay, and then you reduce it to 1 mm squared, you would get a value of 0.02 ohms per meter. Yeah. No? Of copper. So that, in other words, there is 1 inch squared na wire, na copper, with a 1 meter length, that has a resistance of 0.02 ohms per meter. So that is a very useful number when we are sizing wires for solar, as I will explain later on. So just take note lang. And then this wire has a current, no? Current flow of 0.5 ampere going to the LED light. Okay, the question, what is the voltage drop total of the wire? How many wires do you see here? 2 wires. Ito yung problema sa mga nag-calculate ito. Kakalimutan nila na dalawa pala yung wire. So they forget to multiply by 2. Ito talaga, out of the many years that I've been doing training solar, most practitioners even makalimutan yung pag-multiply ng 2. So hindi sila makakuha ng correct number. Okay? So, example, since you have a voltage of, since you have a resistance of 0.02 ohms per meter, and then your length is 20, so what is the total resistance of that wire? One length lang muna. So 0.02 times 20, that's 0.4. That's the resistance of one wire. But, dalawa yung wire, no? Okay, so meron kang multiplier na 2, no? 2. So don't forget to multiply by 2. Okay? So you have you just collect your data. You have the resistance, you have the length, then you have the current. Multiply everything. Then you get voltage drop of one wire. But since there's a 2 wire in the circuit, there are 2 wires. No? So you multiply by 2. So that you can get the total voltage drop. So meaning, the voltage that will be measured at the terminal of the line, there's a circuit pa. No? So it will be 13 or less than 13? Less than 13. So what is the number that you will subtract from 13? 13 minus 0.4, no? Yes, 13 minus 0.4. So the terminal voltage at the light would be 12.6. Okay. So naintindihan, no? So that's voltage drop. Okay? As I mentioned, no? Very simple to look at. But as I said, out of 20, 5 lang ang nakakuha sa answer. Nakalimutan ang 2. No? Yan ang exciting about voltage drop. Okay, another example. You have 2 lines, and then each line, of course, requires 0.5 ampere to work. The mga yung required power consumption or current consumption for the light, no? So you have 0.5 ampere per light. Now, each light has a different distance or length of cable. Okay? For example, ito sa L1, light 1. Ang total cable is distance is 20 meters from the source. Okay, distance ng 20 meters from the source. The other one, what is the distance from the source? The L2, 30, correct? No, 30 meters ang distansya from the source. So, in other words, kung mataas yung isa na wire, isa shorter, that means they have different what? Aside from different voltage drop, with different resistance, or like different resistance, no? Okay. So, if still the same, no? The same, this wire size, let's say 1 mm². Halimbawa, no? Let's say ito yung given na 0.02 ohms na resistance per wire. Just to simplify na ba? Okay. So ito yung mangyayari, no? Ito yung resulta. So the total voltage drops for each sector, let's say here, itong sector number 1, the voltage drop there is 0.4, no? Then sa second, 0.2, no? Then the other one is 0.4. Okay? So iba-iba, no? So that means at each terminal of the light, iba-ibang voltage na measure mo because of the voltage drops. So for example, ito sa L1, sa light number 1, ang voltage drop is total is 0.6, no? And of course, so what would you measure then? What is the voltage? Muna, no? 12.4. The other one would be 12.2, no? I-less lang ba, no? Okay? Now, anong significance kung alam natin ang voltage drop? Ang significance dito is we'll be able to design properly the size of the wire. No? So, ang importante maintindihan natin yung concept ng voltage drop, and then we will be able to size properly the wire. Example, dito sa solar, meron tayong sinatawag na sections, no? Between the PV
to the CC. What is PV to the CC? Solar panel to charge controller. So that's a section. Okay? So PV is photovoltaic, so solar panel. So solar panel to charge controller. For a 12-volt system, ang recommended na voltage drop is not in terms of percent. So usually, ang gawa natin sa understanding natin na dapat 5% lang ang maximum voltage drop in the system. But for solar low voltage system, hindi percent ang binibigay o ginagamit. Kundi specific voltage number talaga, no? Hindi siya 5%, kundi voltage. For example, between the solar panel and the charge controller, the voltage drop must not exceed 0.5 volt. Okay. 0.5 volt sa isang wire o sa dalawang wire? Sa dalawang wire. Correct, no? Dapat alam din natin, sa dalawang wire yan, total na yan, Silvi, no? Total voltage drop from line 1 to line 2. So, isang circuit. Hindi ito, marami rin nalilito, no? Minsan, makalimutan din nila, i-divide by 2, for example, no? So, depende sa approach nila. Basta, yan, yung mga voltage drops na numbers ito, these are total voltage drop between the 2 points. So, another section of the system is the battery and controller. By the way, do you understand what is controller? Here in the training room, mayroon kayong kita dyan. No? Charge controller is basically a device to protect the battery versus or against overcharging and over discharging. So battery protection siya. Baka mayroon nagsabi sa inyo voltage regulator. No, it's not a voltage regulator ang controller. It's like a switch. No? Switch na siya to protect the battery from being overcharged and also to protect the battery from being over discharged. So yan ang function ng controller. Now, take note, no? Diyan sa table na yan. What is the smallest voltage drop between the battery and controller? Why? Why is it small compared to the other sections? Maximize ang power na makuha? Doon sa supply? Okay. The reason is, as I mentioned, the controller is protection. Now, the function of the controller is it senses the voltage. So the voltage of the system is the one that it senses, especially the battery. So, ang parameter na tinitingnan niya is the voltage. So, ngayon, connect nyo sa topic natin, voltage drop. So what if the voltage drop is large between the controller and the battery? So what type of voltage that it will sense? Accurate or not accurate? Not accurate. Correct? Okay. Voltage drop na taas. Pero sabi niya, 0.1 na dapat ang voltage drop between the two components at a system voltage of 12. So, again, kay protection man siya sa battery, dapat the voltage drop should be very small. Not more than 0.1 volt. Now, between the load and the charge controller, it's between 0.5 to 1 volt. Of course, this problem of lights not turning on, it is resolved because the new technology is, the new LED lights today can work from, let's say, 10 volts to 36. So, hindi na kayo problema o kanang high voltage or low voltage. Ang siga gabot na ang mga LED lights. Okay. Now, this is for 12 volts. What if we apply the 5% rule, which is what we know, no? Kung 5%, let's say, kung 5% yung limitation, so it will be about 0.56 volt, no? Or kung 11.1 ang battery voltage, that would be 0.56. So masyadong maliit na ano natin, no? Mas sense na voltahe. Dahil malaki yung 5%. That's why we did not use the 5% for low voltage system calculations sa voltage drop. We use specific voltage drop number. 1.5, 0.1. Depende sa section sa system. Now, question. What would be the voltage drop allowed between PV panel or solar panel and charge controller when you are using 24 volts? Sa 12 volts, that was 1, or no, 0.5, no? So, kung 24, you times na mo 2. Yes, so that will be 1 volt, no? So, kung sa battery, it's 0.1 sa 12 volts, so it would be times 2, so that would be 0.2. Yeah. Then, kung 1 volt, 0.5 volts, times 2, no? Okay. 2 volts. Sakto ba? Okay. And so on. And then if you are using 48 volt system, ang numbers nga makuha niyo sa 24, i-multiply niyo ng 2. Okay? So then you will get all the numbers. Okay. Now, example. Sabi ko nga, there's a significance of voltage drop in sizing wires. For example, you have here a 24 volt system. No? And then, between the charge controller and the solar panel, as we mentioned, 1 volt ang allowed voltage drop maximum. Now, in this example, there's a 60 meters distance from the panel to the controller. And then there's a current of, in this example, and for illustration, 12.9. So, the resistance, how would you calculate the resistance? If you are given these parameters, you're given voltage drop and then you're given current. So what would be the formula you're going to use? Ohm's law, correct, no? So how would you find current? Voltage over. Sorry, how would you find resistance given a current? Voltage over current, okay. So what voltage are you going to use? Kung one wire lang ang natin, isang wire lang. What is the voltage that you are going to use? Let's say sa CC to PV. Huh? 0.5? How did you calculate that 0.5? Yeah, because you have maximum of 1 volt for 2 lines, so you divide it by 2, so you get 0.5 volt per line, per wire, no? Okay. Very good, no? So, nakuha natin yung resistance. Muna siya. Maximum resistance is 1 volt over 2. Kay wire, isang wire man natin, no? Tinitingnan, isang wire. So, 0.5 divided by 12.9, you get 0.0. Do you have a calculator? I-try nyo. 0.0388. No? That's the total resistance of the 6 meters wire. But if you are going to calculate per meter, how would you calculate per meter? Huh? You're going to divide the 0.0388 by 6 meters. Correct. No? So that's why you have a 0.0065 ohms per meter. Now, as I mentioned, ang 1 mm² wire has a resistance of 0.02 ohms per meter. Now, without having so many formulas, like itong visual natin ba na resistance plus ohms times rho times L over A, no? Di na gamit, anak, no? Why? Because we can actually calculate this quickly, no? By understanding the relationship of resistance and diameter or area. Example, look at this above figure. This is, just imagine this is a 1 mm² wire ba? Ang yang area, cross-sectional area, no? Gamay, no? And then, ang yang length is 1 meter. Okay? As I mentioned, ang iyang resistance, ang kanyang resistance is 0.02 ohms ang 1 meter na 1 mm squared wire. Okay. If you connect 1 mm squared wire in 4 times parallel, so magiging total area niya is 4 mm squared kung i-times 4 mo ba. So what is the effect on the resistance of the wire? Is it going to increase or going to decrease? Decrease? Increase? Kaya hindi na po naman diameter, so increase ang what? Resistance. Well, you try to calculate using what you learn in college, no? Or in school. Kung naka 1 ohm resistor, i-parallel mo ang 1 ohm 4 times. What happens to that 1 ohm? Times 4? Parallel? Or? Same? Are you sure? 1 ohm by parallel ba? 4 times. Divide by 4. Yeah. So, maliliit yung resistance. Basta ang 1 ohm, parallel mo siya ba? Delete yung resistance. Di ba? The same case sa wire. Kung ang wire, iparallel mo siya, ang resistance niya total would be decreased. So, in this case, kay alam natin, 1 mm squared, kung 4 mm squared, anong resistance niya? Times 4 or divided by 4? Divided by 4. So, this will be 0.02 ohms divided by 4. So, what would be the answer here? Say, na-calculator niya? Yeah, 0.05 ohms will be the total or equivalent resistance sa 4 mm squared. Now, since by that reasoning, what is the proportionality here? Inversely or directly proportional ang resistance sa area? Inverse. So by ratio and proportion, for example, balik ka sa atong katong table, if your 1 mm squared is 0.02 ohms, ang imuhang yung imuhang unknown wire diameter or wire area would be kining point yun sa di pagkuha ang 3.1 i-divide ang T sa T ini 0.02 by S. Asang S? Kaya per meter. So, ano kas per meter? Kaya meter na itong ibasihan. No? So, this is a shortcut method of sizing the wire based on limitation of voltage drop. Don't worry, we'll be given notes or you'll be given copies of this presentation. So, I don't know picture. Tagaan mo yun no? So, okay. Once you know the wire, no? Of course, these are not standard wires. Asa mo mungita o standard? Ato mungita sa? Ato ang Philippine Electrical Code. Doon kayo maghanap. No? Of course, kung doon kayo sa Philippine Electrical Code, tingnan nyo yung mga capacity, magtataka kayo, ang liit ng wire, kaya man yan sa 2 mm squared. No? Yun sa page, sa capacity. No? Kaya man yan. Pero, we're not about capacity. We're about number one, voltage drop. Our objective is to minimize the voltage drop. No? Otherwise, kung gamitin natin yung capacity table without considering voltage drop sa low voltage system, magka-problema tayo doon na mag-increase yung natin, mga losses. So that's why this is the recommended steps in sizing your wire sa low voltage system. Okay? Now, application. Right nowadays, there are very large solar projects, no? Mga solar farm, mga 100 kilowatt rooftop, no? Marami, no? Sometimes you will be overwhelmed. Minsan, makalimutan yung basic pa. So, we have to think in simple terms. Otherwise, kung Mag-verbal tayo, laki nito. Paano ma-calculate ang ano to, wiring to or voltage drop? No? You have to think in simple terms, like between 2 points. Let's say, yung yellow na yan, that's a combiner box, meaning yung mga solar strings back, no? Doon gina-combine yung mga wires galing sa mga circuit, mga solar strings. Strings meaning mga solar panel ba na naka-series. Okay? And then from that combiner box, there's a wire or a pair of wire na papunta sa inverter. Now, in solar farms, which is as we speak, no? Meron tayong mga kasama ng plant ngayon sa solar farm sa Toledo. Those are very large areas. So meaning, napakalayo yung distansya, no? From the solar combiner boxes to the inverter. Usually, itong mga central inverter, may ano siya, mga maraming inputs. May mga inputs, no? Na let's say 24 sets, depende na. So that means, kailangan talaga ng tawag na combiner box para ma-consolidate mo yung output ng mga solar panels. Okay? But thinking simply pa rin, you have to understand that if there is a wire in the system, there should be a what? Voltage drop. There should be a resistance on the wire, no? And then just to illustrate ito, let's say for example, number 1 ito. This circuit number 1, meron kang distansya na 322 meters, for example, just for illustration. Ang layo, 322 meters distance from the junction box or combiner box to the input of the inverter. And then, in this case, the wire used is 125 mm squared. Okay? 125. And then the current, no, of this circuit is 127.5 amperes. Okay? And then, the direct current resistance of the wire, based on the table, is 0.0515 ohms per 305 meters. Morning, makita natin sa ating code. No? If you look at your PET, mayroong isang table dyan, makita yung DC resistance of the wires. And then, calculate din natin yung ohms per circuit by multiplying the distance, no? And so on. The resistance per 25 meters, no? Okay? And then, voltage drop, how do you calculate voltage drop? Ito, no? Ito sa right side, tingnan nyo, ito. So the voltage drop is the ohms per 35 meters times the total length, no? 322 meters, no? Times the current niya, itong 2. Huwag niyong kalimutan, no? Because ito talaga yung makalimutan ng mga engineer, no? Na i-multiply yung 2. Kasi dalawang wire yun. Okay? So, you have a 13.88 volts voltage drop from the source to the input of the inverter in this example. So, the power loss is how much? There are 2 ways to calculate, I squared R or volts times amps, no? So, power loss. So, the power loss is 1.7 kilowatt, no? So, pura na siya gusto ka heater nga nang magpapukal ng tubig ba? No? So, by that, ano ba, no? Illustration. So, naku kaya siya. That's why you have to be mindful of voltage drop. Okay? So, I think this is all my presentation today. And we will be distributing copies of this for all the participants who are listening and participating, including you guys here in the room. Okay, thank you very much and good afternoon to everybody. Thank you for listening.
Thank you, Sir Jude, for that wonderful sharing. That is a DC current. So it's more Ohm's law without the power factor. So, and a question that is here at the Q&A box. So meaning to say that we'll have to proceed There are no inquiry. So meaning to say that is very clear, the explanation of our speaker. So may I request Engineer Luel Ratilia to award the certificate to our president? Sir Luel?
Yes, sir.
Sir.
IIEE Cebu chapter, plaque of appreciation is given to Engineer Magdaleno Imbaclay Jr. as technical resource speaker on the topic importance of voltage drop calculation in solar PV systems. Given in the 21st Eastern and Central Visayas Regional Conference held on 27th to 30th day of July 2022 via hybrid at the Sky Hall E&B SM Seaside South Road Properties, Cebu City. Given this 27th day of July 2022, signed Magdaleno Imbaclay, President, IAS Cebu Chapter, Ronmar B. Gonzales, VP Technical Affairs, Brian Ipasilan, Regional Governor, IAE Cebu, IAE Eastern and Central Visayas, and Erwin J. Salvador, Technical Consultant and Advisor.
There's a question, President. Thank you, Prince. Question, sir.
There's a question here about award certificate. So, Sir June?
Okay.
Sir June, I'll just go ahead. Sir June? Hello, sir. Good afternoon. Just like to ask a question. When installing inverter to the battery, sir, is it per battery or we will connect the batteries into series or parallel prior installing the inverter to the batteries? And when we connect the inverter, it is via series or parallel? Just for clarification, sir. Thank you, Mr. Anonymous. Next time, Mr. Anonymous, will give us your real name. It's June, go ahead.
Example. Okay, I think what I understand from your questions. Actually, ang suppose siguro, ang ibig niya sabihin siguro, kung meron kang battery, dapat bang i-directa mo buwan, install sa, connect sa inverter, iparallel mo muna. Okay, typically sir, ganito, you have, during your design, you have to check muna, no? What is the specification of your inverter? Let's say hybrid, for example, a hybrid inverter. You have to understand or know what is the system voltage sa DC side allowed for that inverter. So nowadays, most of the hybrid inverters, they require 48 volts DC sa DC side niya. So that means your battery has to be connected to form a 48 volt system as well. Either you're using a lead acid battery or lithium ion battery. So ganun sir, no? First you have to match the system voltage of your inverter to the system voltage of your battery bank. Yun ang importante sir, no? Okay, I hope I'm able to clarify this sir. You can, of course, you can follow up. You can ask a follow-up question just in case you were not able to get it. Or you can also, probably, no? You can email me, sir, if you have some follow-up questions. I'll just write down my email here in the chat box. Kung may mga question yung interesado ba. So, June Baclay, that's Sun Invest. Solar. So you can sir, no? Just email me your question. Just in case meron kayong mga follow-up. So June Baclay, that's solar@gmail.com. That is my email address. Okay, thank you, sir.
Okay. Consultation is free from Engineer June Baclay. Thank you very much, Sir June. our president of IIEE Cebu chapter.
Kasi gisod ka na sa
Next
din, pabay ka.
speaker is Secretary. Bigawat. Okay na. Thank you, Sir Jun. Thank you, Sir Jun.
Yes, yes, ma'am.
Okay, our next speaker for this afternoon he is a graduate of Bachelor of Science in Electrical Engineering at Cebu Institute of Technology University. Master of Engineering, Electrical Engineering, major in Control System Engineering at University of San Carlos. President and General Manager of EGS Multi-Vector Solution Incorporated. Department Chair, Electrical Engineering at Cebu Institute of Technology University for June 2008, May 2019. He is an member IIE Cebu Chapter President, year 2015, with specialty in electrical design, installation and testing and commissioning, academic lectures, associate professor faculty, awarded by the IIE Cebu Chapter Board of Directors with exemplary award as IEE Chapter President at 2015. Would you please welcome our speaker for this afternoon, Engineer Erwin J. Salvador.
Mic. Tayo no? Gamit kong mic. Hello, maayong hapon. Good afternoon, everyone. So I hope that we still have energy and strength to listen. Okay, sa bunso na bagyo, no? So straight yung ano natin, yung lectures. Alright, so now I am tasked to present to you the fundamentals in power quality assessment. By the way, thank you, Sir Bob, for that introduction. Alright. So the outline, so the outline of my presentation is basically the introduction. So here we'll be somehow reviewing some electrical structures, electric power components, and basic spectrum and signals. The types of loads, so the linear loads, the non-linear loads, and also the behavior in the power systems and its characteristics. And we will also enumerate the power quality problems, or all the disturbances in electrical system, types of disturbances such as flickering, voltage dip, voltage sag, transients, okay? And of course the harmonics, which is very familiar to us, that will really cause a lot of trouble in our electrical system. Wait, ako saan ko? On na akong video dito. Oh yeah, on na. Then the source of power quality problems and harmonics. So I mean to say, saan galing yung mga disturbances na yun, no? And also the harmonics. And of course, the effects of the harmonics not just in the system but also in the different equipment. Effect niya sa transformers, sa motors, sa mga electronic devices, and of course, last but not the least is the power quality solution and mitigation of these disturbances and power quality problems. So to begin with, power quality can be defined from different perspectives, whether you are from the supply side or the consumer side, or the customer, or the utilization. So perhaps in the generator sides, it's basically maintaining the 60 hertz, and for the transmission as well and distribution. And for the utilization side, perhaps we have to maintain the plus minus 5% voltages and also the frequency. Okay, so normally power quality is applied, no? Not just for the consumer but also in the generation, transmission, and distribution. So depende kung ano yung perspective natin. So this is a basic structure of our electrical system. We have the generation. Okay, so we have the generation, the transmission, the distribution, and the utilization. So, kind of review of some the important electrical power quantities. So we have the power, no? The true power as defined. It is measured in watts. It is the actual conversion of energy electrical energy being converted into usable energy. And of course, the voltage and the current, I don't have to define this one. So voltage is very important as well as the current. So we'll be dealing more on the wave form of these two electrical quantities. Okay, the sinusoidal waves of voltage and currents. So if we may add power factor, reactive factor, apparent power, reactive power, impedance, and so on and so forth. So those are important electrical component or electrical quantity that we need to deal with. So again, as we talk about power quality, we'll be dealing more on the spectrum of the signal. Okay, so to begin with, so the sinusoidal wave, it looks like this, no? Although there are other analog signal, like if you're familiar with control system, so meron tayong mga different types of signal, may mga steps, no? Meron tayong mga rectangular, no? Meron tayong impulse, no? We have parabolic, but of course in electrical system we'll be dealing more on sinusoidal wave with the fundamental frequency of 60 hertz. So if our signal or our spectrum is smooth, so we can directly calculate other parameters like average values, RMS. We can also determine the peak value, so positive and negative peak. Although the formula that has been derived is ginamitan din siya ng mga mathematical derivation like integration, like that. No? So this is a one cycle wave with a period t. Then here comes now the disturbances and other factors that really affect sa ating supply. Kaya mangyayari, we will be able to generate what we call non-sinusoidal waves. No? So non-sinusoidal because if you take a look at the figure, it's not smooth enough like in the left side. Alright? Then the calculation for a smooth signal, mas madali siya, no? Yung power madali lang, no? You have to multiply the voltage of the current and the displacement of this both current and of course the cosine value of displacement sa cosine current saka voltage. But here it's different. So you have to apply solution to differential equation like Fourier series, parang gano'n, no? Mas mahirap siya. Okay? So that's why we entitled here fundamentals, because we can talk a lot about power quality in this topic, but the limited time, no? So normally the output of distorted power can be determine using mga equipment like power quality analyzer, mga energy management monitoring system. Okay? Kasi pag kinalculate mo yan ng mathematical, talagang mahirap, no? Kaya pagkuha mo lang sa average power, you will do a lot of summation, you know, a lot of tedious calculation. But as you take a look here, distorted yung signal natin. Okay. So, yun na nagkakaroon na yung problema sa load side natin, no? Not just the load side, but also in the other perspective, if you are in the generation side. So what are the electrical load, types of electrical loads? So we have linear loads, no? So pag sinabi natin linear, ito yung mga loads natin. Like resistive loads, no? Those resistive loads are just simple as electric heater, incandescent lights, okay? Only resistive component. Okay? But pag sinabi natin inductive loads, these loads are motors, all right? Electromagnetic types of loads. Transformer is not considered as load, basically, no? Although it's an inductive, it also consumes power, but somehow we do not include it as a inductive load, no? Then capacitive load, if we have capacitors or condensers, or perhaps a synchronous motor with leading power factor, that becomes a capacitive loads. So, ito yung mga yung mga linear loads na tinatawag. Pag ito yung loads natin, maganda yung takbo ng signal, ng spectrum, ng voltage saka current. So, however, as the development goes, electronics, okay, communications, and other digital loads or digital systems developed. Okay? So, yun ang mga tinatawag nating non-linear loads. So, these loads, which are the non-linear, the impedance changes with the applied voltage. So, the changing impedance means that the current flows by the non-linear load will not be sinusoidal, even with it's connected with sinusoidal voltage. So, example of that are the variable frequency drive or variable speed drive, and we all know that we vary the speed, and we also know by equation that the synchronous speed is proportional to the frequency. No? So speed is proportional to the frequency. So as we vary the frequency, so yun, may iba na yung signal, no? And of course, computers, mga high frequency na telecommunication equipment, UPS, and other electronic loads. So those loads that are dependent sa frequency, yun ang mga nonlinear loads, no? It creates harmonic current. So we'll be talking more about the harmonics in the following slides. So I mean to say, it is not the same as the fundamental frequency. Pag sinabi natin fundamental frequency, yung 60 Hz. No? So ang waveform niya is really different. So under this condition, the voltage waveform is no longer that proportional with the current. So what are the characteristics of voltage and current in a nonlinear load? So the non-sinusoidal periodic waveform of nonlinear loads can be represented through Fourier analysis. Is a solution to differential equation. So since we know that the wave that has been formed is non-sinusoidal, so you cannot just calculate immediately. So you have to synthesize the calculation in such a way in order for you to get the average, okay, the RMS of the non-sinusoidal wave. So therefore, we have to conduct Fourier series. No? So summation of the DC component and the sine waves of various amplitude, meaning various voltage, current, with the displacement, okay, meaning the angle. So all the waves with multiple frequencies having the fundamental frequency of 60 Hertz. So for the voltage and current, the equations are just the same. The formula is just the same. So of course, we will not go through this one. Again, pag may equipment ka, makikita mo to, madali ito makita. And we have the omega, which is the function of frequency, no? It's a function of frequency. So therefore, the frequency has a big factor on calculating the voltage and the current. So how much more if you wish to calculate the power factor of this? I mean, two non-sinusoidal wave, you have to calculate the power factor between the voltage and the current and also the average power. So napaka tedious talaga ng calculation. Unlike yung purely sinusoidal, madali lang, di ba? So I times B times power factor. Here, so you have to do some mathematical calculation. So again, the voltage and current equation represents sine waves that are multiples of fundamental frequency. These are called harmonics. So the effective value, or the RMS, of the current waveform, where the amplitude of this harmonic can be obtained with this equation. So this is the square root of the summation of the amplitude square. So from the number of order, meaning 1, 2, 3, 4, and so on and so forth. So that's how you get the, and this is also applied with the voltage, by the way. Apply din po to. Now, what is this non-linearity, no? Ito yung tinatawag na mga distortion sa waveform natin. So the waveform can be determined in different distortion, like total harmonic distortion. So which be dealing with this one in the following slide, mga standards, how we're going to get this one. And total demand distortion, which is the current. The crest factor, which talk about the peak, and the form factor. So these values are needed in order for you to, yung malalaman mo na mataas na yung PhD mo, mataas na yung PDD mo, and that's the time you have to propose a solution, no? Or mitigation, and we'll be dealing that as well. Different types of solution like filters, passive, active filters, mga grounding system, and so on and so forth. And again, you must have an equipment to have these values. And we will have an example of that now. Mga screenshots of the power quality outputs using equipment. So the PhD is defined as the ratio of RMS value of the total harmonic current and the RMS value of fundamental current. So the PhD, or voltage, by the way, it can also be voltage. The PhD is expressed as the percentage. The fundamental current is given by this equation. So this is the fundamental voltage, and the rest are the nth order. Alright? It's basically this, this also exceeds the IEEE, 500 limit of 5%, and would require some type of mitigation if mo exceed ka ng 5%. No? In order for you to reduce the harmonic in the acceptable level. So that's why yun ang mga solution natin, mga filters, yung mga isolation transformers, no? So going back, as what I mentioned kanina, in the buildings nowadays, marami ng mga computers like BPOs, like mga, kahit yung mga yung mga makina na sa mga sa mga industrial plants, mga computer based, mga board na siya. So power quality is becoming a big issue sa industry, no? So that's why the design also evolved, no? So as a designer, we also need to consider the harmonics. Okay, as we going to later on, we'll be talking about the transformers, no, mga K-factors, and mga zero sequence, yun. I-consider mo na yun. Kasi marami na talagang mga non-linear loads available sa industry. So, TDD, on the other hand, deals with evaluating the current distortion caused by harmonic current and the user facilities. So, the definition is similar to THD, except that the demand current is used in the denominator of TDD instead of simply the fundamental current. So, ito, iba na yung denominator mo, no? It is the RMS maximum na siya, no? Demand. So, TDD can be described the current distortion as a percentage of full load demand current and its best power quality index to explain current harmonics at the consumer end. So, therefore, the TDD value provides information regarding the linearity of the load connected in an electrical system. So, meron din siyang sort of table sa standards sa IEEE na basis mo, no? Kung mataas na ba yung TDD mo or okay pa ba siya, acceptable pa ba siya. Because one of our topic later on, yung mga effects. If we were not able to mitigate this distortion, this mga disturbances. So, crest factor is the just ratio of the peak and the RMS. So, kung simple ano lang ka, sinusoidal, di ba? Maximum is just simply square root of 2, no? RMS. So it's just ang factor niya is 1.41 but in a non-sinusoidal wave it could reach as much as 4 times, no? So napakalaki talaga, no, ng So form factor in a purely linear sinusoidal waveform, so the crest factor is equal to square root of 2, no? So yun nga, 1.414. Okay, so the form factor is defined as the ratio of the RMS of the waveform to RMS value of the fundamental waveform, and it can be written as IRMS and this one, no, the fundamental value. So a simple illustration of other waves other than the fundamental. So again, if our waveform is just as smooth as like this one, no distortion, so ang crest factor natin is just a multiplying factor of square root of 2, no? So not that much, so 223, diba? Automatic, ilan ba yung peak niya, no? 220 times square root of 2 lang, diba? Pero pag non-sinusoidal wave is different. So what will happen now is, you have a fundamental, this one. Then we have the third, okay? So if you sum up that pictorially, it will give you a distorted sine wave. Ito na yung resultant sine wave mo. However, if there are still more harmonics present in the system, so mas distorted pa siya, no? So and with that, mataas na yung crest factor mo, yung PHD, yung TDD mo, yung mga triplet harmonics mo, marami na, no? And it will sum up into zero sequence, and it will create heat sa kable, sa winding, and it will reduce the efficiency of the utilization sa equipment. So marami siyang effect. Okay? So that's why we have to, kaya na, I think there was a discussion, energy management, no? Demand side management. But there's also an energy management, not just yung kanina, yes, outside the meter, totoo yun. But as a believer of energy management, so dapat we as electrical engineer, we need to manage first yung sistema natin, yung system natin. So mean to say, maganda yung electrical wiring, okay? na-mitigate yung mga harmonics, yung mga voltage drop natin, controlled natin. So with that, we can save a lot of energy. No? And one of that is to have a good quality of power. So this is just to compare, no, the one that I was talking about. If linear loads, smooth sinusoidal wave, Ohm's law can be applied, no? But in the non-linear loads, you cannot just simply apply the Ohm's law, no? Because you have to synthesize the equation into mathematical equations. The crest factor is just 1.41. However, if non-linear loads can reach as much 4 times, no? Then kung power factor man siya, madali lang, no? But here, marami ka pang kino-consider, and so on and so forth. Alright, so halimbawa, yung neutral current, no? So neutral current could be 2.7 times, no, the linear current, even if single phase. So that's why dati yung neutral wire na dinidesign, 50% of the line, no? Ngayon, makikita mo na yung mga BPO buildings, di ba na yun, di ba? Line 1, line 2, line 3, no? So ang at neutral, normally 50% lang dati dinidesign sa size nito. But now, as much as 2 times, no? 2 times of the line. Kasi nga, ina-anticipate na nila na yung zero sequence current due to harmonics can also contribute, no? So, though it's an overkill, no? Mga kwan. Pwede mo lang 100% yun. So, ito yung parang comparison ba na mangyayari if our loads are non-linear. Well, power quality problems can be defined as any problem manifested by voltage, current, frequency, okay, or perhaps failure or misoperation of load or equipment. So sometimes there are books that categorize quality power as dirty power, no? Dirty power quality. So includes power system events. What are those power system events? Yung mga surges, yung mga power interruption, mga flickering, okay? Examples of dirty power quality sources includes mga lightning, no? Lightning surges, alright? So power quality experts prefer not to call as dirty. So, pangit naman pakinggan, di ba? So ginawa nilang power quality problems. Because power is like any commodity na binibili natin sa merkado. So, yung bigas natin na ganador, compared natin sa NFA, syempre, mas maganda yung quality ng bigas na ganador, di ba? So, the same with power. Okay. Pag maganda yung power supply natin, syempre, hindi na tayo gagamit ng mga voltage regulator. So, I've been to some of the advanced countries. Diba tayo dito, pag gumagamit tayo ng mga kahit projector lang, di ba? So, ginagamitan pa natin ng mga voltage regulator. So, I visited some of the countries, hindi na sila gumagamit, no, ng mga ganong klaseng mga UPS, mga maliliit na voltage regulator. Kasi maganda yung ano nila, power, no? So, minsan sa atin, lalo sa mga probinsya, so yung voltage nagda-drop. So, the quality of power has often classified as, again, clean or dirty, no? Clean power refers that the sinusoidal voltage or current without any distortion. On the other hand, dirty power describes power that has distorted sinusoidal wave. So, distorted voltage or current sinusoidal waves. So again, power quality can be defined into two perspectives. Either you're in the supply side or the consumer side. No? So how much does power quality cost? So it has economic implication if we were not able to somehow mitigate the distorted power. So the common denominator of the power problem is the cost. Okay? So how much, no? Is the cost measured by loss of production, or is the cost measured by potential legal consequences, or whatever types of cost? So maraming cost implication pag marumi yung power natin. Hello. Okay, so here comes now the power quality problems categories. One is the conducted low frequency phenomenon is characterized by the following. So we have over voltage, under voltage, transient, includes voltage surge, voltage swell. So we will describe that one by one. There's a fluctuation, there's flickering, a short time, a long time flickering. And again, you can only obtain these values sa mga equipment, PQA, voltage dip, yung pagkawala ng kuryente, power, no? Voltage interruption, imbalance or unbalance, power frequency variation, so induced low frequency voltages, harmonics, enterharmonics, harmonic resonances. So these are category 1. The next one is the radiated, no? Frequency phenomenon, like magnetic and electric field or electromagnetic interference, EMI, then radio frequency interference, or RFI. So these are the categories that may occur in our power system. Well, voltage disturbances, marami, no? So if you take a look at the spectrum, at the normal signal, nagsag siya, no? So, ito yung nagsag, di ba, na ganun. Then, nagswell. So, may bukol. Yun. At certain period of time. So, siguro may switching, siguro may temporary fault. Okay? Then, bigla nawala yung power outage, interruption. So, na-zero. Then, pwede rin na may mga harmonics. So, marami dyan, no? Non-sinusoidal na yung labas ng, ng signal natin. May mga spikes, no? May mga flickering, mga ganon. May mga noise. Okay, so marumi. Marumi yung natin, yung signal or spectrum. Okay? So, maraming cause ng disturbances. So over voltage from the normal, so biglang biglang tumaas yung voltahe. All right? So over voltage is any change above the prescribed input voltage range. This is self-explanatory. No, maraming cause, no, na nangyayari. Lalo na pag we have client na minsan nagreklamo is a residential subdivision, katabi niya yung malaking industrial. So talagang apektado minsan yung nila, yung supply nila, no. They're connected in the same distribution line. So that may be one factor, no. Katabi nila yung malaking Okay. So this one is baliktad, no? Biglang nag-under voltage. So probably may fault, no? Ground fault, or ano ba? So I won't explain this one. It's very self-explanatory. Under voltage can be caused of many factors, no? Sa power supply. Under voltage can occur due overloaded. Okay, and so on and so forth. So voltage side, take a look at the spectrum. There's a certain time lang na bumaba yung voltage tapos bumalik sa normal. So the power quality equipment can also view this kind of spectrum. Makikita mo yung how many millisecond, how many ano. So so RMS value level to 10 to 90% of the nominal. So the bar frequency duration of 1/2 cycle to 1 minute. So with that duration, that can be considered as voltage sag. No? Of course, kung lang minuto na, power ano na yun, power interruption na yun siya. So this can be generally caused by weather, okay, and utility equipment problem perhaps, which normally leads to system fault. So probably sa distribution line nyo, where your facility is connected. So for example, a fault on the parallel feeder circuit will result in voltage drop in a substation bus that affects all the other feeders. So yun nga, may katabi, no? May katabi kang ano, may nag-fault. No? Until the fault is cleared, then yun, doon pa mababalik. So the same concept could apply for a fault somewhere on the transmission system, distribution system, and so on and so forth. Or there might be some line to ground fault. Yun. Can cause also a switching of heavy loads. Papasokin yung ibang ibang mga loads, no? So induction motor can draw perhaps 6 to 10 times of the full load, no? Especially pag walang method of starting, and that relatively affects the signal. So voltage swell, okay, yun nga yung sabi ko, biglang tumaas pero saglit lang, no? Saglit lang. So nakaka-affect ba sa load natin? Hindi masyado, no? Hindi masyado, but kung always, well, it becomes destructive, di ba? It becomes more noticeable kung always lang, even yung sag natin. So it may cause breakdown of components sa mga power utilization equipment natin, no? So it may the effect may be gradual, and eventually it will cause breakdown. It will accumulate, no? Especially yung mga control ng mga electronic equipment, yung kaya minsan, di ba, may sabihin, uy, sira na yung TV, hanggang 2 years na yung TV. Di ba? But yung sa'yo, matagal na sira. So probably yung lugar nyo, ayun, you always experience this kind of disturbances. Okay? So according sa IEEE 1159, so you could have 110%, 180, pwede ka hanggang times 2, pero hanggang 1 minute lang, di ba? So, okay pa yun. Okay pa yun siya. Up to 1.8 per unit, no? Instantaneous up to 30 cycles. Then, probably temporary over-voltage hanggang 20% until 1 minute. So, with that, okay pa. Pag sumobra, over-voltage na. Hindi lang siya swell. So, fluctuation, nag-fluctuate, di ba? Nag-fluctuate yung signal natin. So, defined as systematic variation of voltage waveform envelope or a series of random voltage changes. So, parang ganun ba? Yung ano natin, nag-fluctuate siya. So, generally, the variation ranges from 0.1% to 7% of the nominal voltage with a frequency less than 25 Hz. So, imbalance or unbalance defined as the ratio of the negative or zero sequence components to positive sequence components. So, remember, yung voltage signal natin tsaka yung current signal natin can be derived into 3 sequences, no? The positive, the negative, and the zero sequences. So all the positive sequence, they're equal with respect, although they may not be equal in magnitude comparably with the negative and also with the zero. But because of the unbalance, you can solve that, no, using symmetrical components. Yun, makikita natin yung mga imbalance mga voltages. So normally may mga line to ground fault, pwede rin yun, or mga arc faults, ganun. So that's one. Okay. So voltage imbalance are caused by unbalanced phase loading condition. So defective transformers, maybe ground faults or ungrounded system. Okay. So marami siyang Yung electrical noise is a signal na nasa spectrum natin na nagka-carry siya ng noise, no? It's a high frequency signal that rides on our fundamental frequency. So sumasabay siya. So kaya tinatawag siyang noise, no? It's also types of distortion. So noise may be caused by any of the following, yung RFI, harmonics, nonlinear loads. Even though microprocessor-based equipment is grounded in accordance with NEC, some continues to have failures, so execution and reading errors, and unpredictable and intermittent operation because of the electrical noise. So ang matatamaan talaga nito yung mga yung mga sensitive equipment, mga electronic equipment. Kaya kami sa sinasabi na if we have inverter na mga refrigerator, inverter na mga aircon, di ba? Uy, nag-brand out. Uy, bumalik agad. Yun. Kasi pagbalik ng power, may sudden increase of signal. So transient defines as short period of time. No? So transient voltage surge can occur, no? Power lines perhaps. Lalo na pag may lightning, no? So na nangyayari. So it goes to the conductor even if it is outside the primary distribution line. It will also reflect sa secondary, sa transformer. Okay? So including telecommunication and other data links. So it is a significant deviation from normal AC voltage sine wave. So typically lasting from a fraction of 1 microsecond to 5 milliseconds. So a TVS can be categorized as deviation generated from natural resources, meaning yung mga lightning, no? Mga switching, and so on and so forth. So the electric charge then spread, no, through the system pag tinamaan yung natin. So traveling waves that will cause disturbances sa load side natin. So it doesn't mean na yung natamaan yung distribution line hindi pwede makapasok sa secondary line natin. So that's why if we have loads that are very critical, yung mga UPS, mga data center, so dapat nakaprotect yun siya, no? May mga yung insulation, kasi yung insulation yung matatamaan. So impulse, transient, so the magnitude measured not from zero, but at any instantaneous part of the wave, no? Halimbawa dito, may nag-spike, no? Yun, no? May impulse. Kasi yung impulse, ganun yung impulse eh. Biglaan ba? Almost zero time. So may nag-spike dyan. Yun, may negative impulse. Ayun. So, may impulse din dito. So, an impulse transient has a fast rise time. So, fairly rapid decay. Kaya ka-impulse siya, no? So, and high energy content. So, duration can be from a few microsecond up to several hundred microsecond. So, a typical impulse transient shown, kanina ito, okay, it calls a spike. No? Another term is spike. So, it adds to the sine wave. As a result, uh, it, talagang delikado siya. No? Delikado siya sa load natin, sa system natin. Ang oscillation naman, so, kahit tingnan nyo sa drawing, ni-oscillate, no? Dito. So, any part of the instantaneous value of our sinusoidal wave, yun, may siya. Oscillation transient has a fast rise height, and it oscillates, no? And it decays exponentially. Right? So, yun. A typical oscillatory transient can last up to 1 cycle, which is 16.7 millisecond, or even longer. Alright? So, disturbances. So, the only way we can have this one, if we have oscilloscope, oscilloscope, or again, any advanced equipment that can show the wave. Interruption is talaga naputol yung yung supply. So mahaba yung time, tapos biglang bumalik. So maraming babantayan dyan, yung mga motor, yung mga different loads natin. So it may cause loss of data from the computer, di ba? Minsan, nag-run out. Ano ba hindi ko na-save. It's another disturbances. Di ba? Complete loss of power lasting for a few seconds or even cycles or even an hour or day. A variety of factors can cause power interruption such as tripping of the main breaker, or again, kung utility yung may problema, kasama ka sa power interrupt. Frequency variation, okay? So it could become faster or kaya yung mga kayo na may solar topic, if you are grid tie na so the frequency is the system is also protected with over and under frequency para ma-match yung Okay, so here comes now harmonics. So those are disturbances, mga distortion, types of distortion. So let's go with harmonics. So harmonics are voltages or current at frequencies that are integer of the multiple, which is 60. Okay, so halimbawa 120, so 2 na yan, 3, okay? Yeah, add and even, no? So they are designated by their harmonic number or multiple of the fundamental. For example, harmonics of 180 is becoming 3 of the fundamental. So if you take a look here, we have the fundamental harmonics, then we have the fifth harmonics, and also we have the resultant, pareha kanina, pinakita ko kanina. So, it will cause a non-sinusoidal wave. Okay? Because it's being added vectorially. So, yun ang mga harmonics. So, industrial power system, example 15%, 20%, or 25% total harmonic current distortion may be experienced. So, the THD can be determined by calculating the square. Pakita ko na kanina yung formula. Okay? So, this yield to the root mean square value distortion as a percentage of 60 Hertz. So, itong 15, mataas na yan, 15, 20, 25. Note that the odd number harmonics current are additive in a common neutral, especially the triplet, triplets harmonics. Whereas the even order harmonics cancel out to 0. So the odd order, 1, 2, 3, 1, 3, 5, like that, such as the third and all odd multiples of the thirds, which is 9, 15, are equal to the phase for the three-phase forward system, which is the triplet harmonics. So triplet harmonics is some odd value multiplied by 3, no? Halimbawa, add 1, 3, 5, 7. So multiply by 3 yan. So 3, 9, 15, 21, and so on and so forth. So this can be the zero sequence current or voltage. So are equal in phase of the three-phase power system. Therefore, they add in the neutral. So yun ang sabi ko kanina, yung mga design sa mga bagong building ngayon na maraming mga electronics, maraming mga digital equipment. So pinapalakihan na nila yung neutral wire. Kasi they're assuming that marami ng triplet harmonics, which is the zero sequence, which is will add to the neutral. No? Also, additive through polysins, they're equal but not equal in phase. So whereas for the second harmonic and all even harmonics, 4, 6, 8, are not in phase, and sum of the positive and negative neutral current equal to 0 and for the three-phase 4 wire. So ito yung sabi ko kanina, no? So phase A, phase B, phase C. So for the normal, they're displaced with 120 degrees. Then may nakitang triplet harmonics dito sa A, tsaka B, tsaka C. As a result, pag labas dito sa neutral, na-add yung tatlo, no? So meaning, this neutral current, neutral wire should carry higher current compared to the line wires. Okay? So mainit siya. So ito yun, no? Ito yung parang inano ko lang. So third harmonics, okay, then we also have third harmonics here, third harmonics, then so adding up the three, linear pag-add lang, linear. Because in symmetrical components, they have no displacement. The zero sequence currents have no displacement, so therefore it will just be added. So ito, yun nga, diba? 1 times 3, 3. 3 times 3, 9. Next is 5 times 3, 15. So, next 7. 3, yun, 21. So, what will be the next? 27, di ba? So, 9 times so on and so forth. Pero, etong mga values to, liliit yun. Mas maliit yun compared sa third harmonics. So, harmonics are caused by nonlinear loads. So, diniscuss na natin kanina. So, I don't have to, ano pa yan. Other devices such as those that will change in impedance is also caused by the harmonics. Harmonic can also cause overloading. So, obviously, di ba? Overheating, okay? Overheating of the neutral conductor, and also it will cause noise stripping. So marami siyang disturbances pag hindi natin ito siya ma-mitigate. And it will also affect the efficiency of the equipment. Yung voltage drop, no? Malaking rin yun bagay. Kasi nga, yung kuryente niya, no? So harmonic current may contribute to capacitor failure as well. So there's a resonance effect. No? So that's why there's noise stripping na mangyayari. Resonance occur when the power system, which is the inductance and the capacitance, come untune. So it becomes resistive. No? So if you are familiar with fundamental in communication, so I think you will understand the resonance. So ito, no? So parallel resonance condition at 300 hertz. So when that frequency attain, there's gonna be a resonance happening in your system. So having the 60 fundamental harmonic frequency at 300, yun, attain niya yung ano. So with that, maximum yung current natin. So when maximum current, so di ba pag nag-resonance siya from the basic circuits or basic communication, maximum yung minimum yung impedance, di ba? So with the minimum impedance, we will have a maximum current. So it will result into tripping or blown fuse. It will also result over init, no? Biglang init. Ayun. So this harmonic source develops excessive voltage at the capacitor terminal, resulting in extremely high current flowing through the capacitor. Okay. Saan galing tong mga mga problems sa harmonics? Una, I mean, not just harmonic but also power quality problems. So power system faults. So kanina, I think today, may mga nag-discuss regarding weak faults. So dapat maiwasan natin yung fault kasi pag nag-fault yun, power quality problems yun. There's a momentary voltage reduction, complete loss, interruption. So usually temporary faults are confined overhead distribution lines, yes. Then apektado rin yung side natin. Lightning surges, it's one. Direct lightning to the power system conductors that will cause overvoltage. Then with that, it will reflect to our load and it will destroy, no? Or it will affect the insulation capability of our equipment, lalo na yung mga electronics, because of the amplitude of the voltage, 100, even current as well. Load switching and surges, there are silent transient disturbances. So, example that yung example ko kanina, yung subdivision na yun, always affected sila, no? Because katabi nila yung napakalaking planta. So every time there are switching or whatever, mag-on sila ng mga malalaking makina. So they somehow experience some flickering. So somewhere in Madawi din siya. So that's why I suggest na you ask the utility na yun, they can be connected at different feeder. So grounding design and installation can also affect. So improper ground system which has multiple ground points are common cause of PQ or power quality disturbances. And that is very obvious. No? So grounding system which do not have sufficiently low ground impedance and do not have the proper amount of current to flow. Every time do may mga ground faults, yun, it will really affect our system. So wiring design and installation, as designer, as professional electrical engineer, or as practicing electrical engineering. So at the very first part, before na-implement, at the drawing pa lang, dapat tama na yung natin, tama na yung design natin. So because it will generate heat, okay? Miss ko na minsan nga yung mga nire-rehab namin. Naghahanap pa kami sa neutral ground. Minsan nagkakahalo-halo na. Yung equipment ground, tsaka neutral ground, hindi na magka-connect, no? May nakikita kaming green. Tapos yun pala, yun? Yung current carrying pala. Tapos may mga, kasi spaghetti wiring na. Then only to find out na, yun, mainit yung nila, mga breakers, mainit yung marami na mga problema, no? So, sa design pa lang, dapat okay na. Eto. So, effects. So, bakit ba kailangan natin i-mitigate yung mga harmonics na yan? Because it will create a heat, no? There will be a thermal stress na mangyayari. In general, the presence of harmonic current increases the losses and thus the thermal stress of the equipment. So copper loss, iron loss, the electric loss, okay? So in a given power equipment, one or more or above losses may determine the thermal stress. Yung kainit, no? Insulation stress, okay, yun din. No? Primary depends on instantaneous voltage magnitude. Okay, so the presence of voltage harmonics can result in an increase of crest value of the voltage. Affected na yung insulation natin. Thus, increased insulation stress. So this increase is not of concern of most power system. Okay. So yun nga, pag may voltage, may surges na pumasok sa system. So napakataas ng peak, no? Or kahit transient lang yun siya. So yung insulation ng level ng winding, yung wires, yung mga electrical components, mga capacitor, inductor, ano pa ba, mga diode natin sa mga electronics, matatamaan talaga yun, no? With a very much high voltage. Load disruption is defined as the objectionable abnormal operation or failure caused by the voltage distortion. Many electronic equipment are susceptible to the load disruption because their normal operation depends on the existence of the sinusoidal voltage sources. So the effect of the harmonics of the electronic equipment are this. Okay, we'll discuss in this section later. So, what else? Tingin ako sa oras. I still have, I'm halfway. So sa transformer, affected din siya, no? So the effect of harmonics on transformers, it will increase copper loss, okay, which is thermal stress, iron loss, possible resonance between transformer. Diba yung previous slides? So may chance, no? So winding and line capacitance. Diba? Diba in our basic circuits, the line with respect to the ground has a capacitance characteristics, tama ba? So, with variable frequency, there's a possibility na maka-resonance siya, no? Maka-resonance, which is, will again draw more current. Insulation stress, neutral overheating, because again, the triplet harmonics are the zero sequence current. So, mag-overheat siya. Di ba? So, basic na So, you're familiar with K-factor, no? So, the UL established the method for testing of the transformer. If you come across with K-factor of the transformer, is a certain feature of the transformer that allow to handle extra heating of harmonic current. So when we specify transformer, write that transformer at that. Aside from the voltage, the cooling system, the connection, delta Y, and so on. So we might as well consider the K-factor specification of our transformer. So, it has to do with the design stage. Pag nakita mo yung karamihan nakakonect sa low voltage na yan, we have low voltage transformers, are more on electronics, then you might as well consider the specification of the K-factors. So, the K-factor is meant to apply to transformers serving general nonlinear loads. So, that's what I mentioned lately. So, there's a derivation of that, the labeling of the transformer, especially the dry type transformer, to withstand the effect of the harmonics. So, the K-factor rating indicates the transformer's ability to tolerate the additional heating caused by harmonics. So, we have an experience on this. Yun, kami yung nag-design. Ginawa namin may mga low voltage transformers. lightings, no? Lightings. But the initial design, we were given the load listing. Ito yung mga lights. However, the owner nakabili siya ng mga mga ilaw sa ibang bansa. Sabihin na natin sa China. Then puro electronic balas and so on, dami. So pinalitan yung mga ilaw na original based sa design. Yun, napakainit talaga ng uminit yung transformer na kinabit nila. So syempre, takbo sa designer. Bakit ganito? Bakit ganyan? So again, only to find out that napalitan yung mga connected na mga ilaw. Isang mall, isang project, isang mall. So that's why the following design talagang siniguro na namin. So ano ba yung ilaw talaga ikakabit dito? Yun ang ikakabit, sir. So yun, kinonsider na namin yung specification ng K-factor na transformer. Aside from elevating a little bit, increasing the capacity, we also included the K-factor of the transformer. So there are two types of calculation, the UL method and normalized method. And by the way, it's just a formula, no? So you don't have to really do it by yourself. Okay. Most importantly, I will also show you also the table here. Kung ano yung nararapat na K-factor na i-apply mo in a particular sets of loads. So for the UL method, so this is the formula. This is the summation of this is the order, which is the H, the per unit RMS value of the harmonics expressed per unit. Almost time na, sir? May time pa ba, sir?
Last 5.
Last 5?
Okay, sir.
Ginawa ko. I'm in the 42 slides.
Oh.
Give me more time. Okay, I'll just go through na lang this one. No? So, ito yung another formula. The normalized method. Yan, sabi ko, fundamentals, paano na to. Okay? So, in the order, let's say, order 1, 3, 5, and so on and so forth, then, parang kinalculate lang. So, the K-factor, the summation of this one, is 11.24, using UL method, using normalized method, may differential lang ng konti, 11.54, using the formula in terms of frequency and also this one. And, okay, so this is what I'm referring to. Application of the K-factor, the transformer, depende. So if normal lang, you can just make 1.0. Then kung mga building, 4 and so on and so forth. Obviously, the higher the K-factor, the more expensive your transformer is, no? Okay, syempre, mas durable. So it also affect the rotating machine. Of course, the zero sequence will produce additional losses because of the zero sequence. And the positive sequence harmonics. Again, this is on order, ha? Iba yung positive, iba yung add o even. Ha? Baka malito kayo, baka bisa lang negative, sinasabi natin even. The positive is add. So, produce a rotating magnetic flux which rotates with a speed of h omega in the positive direction and the magnitude to the harmonic current. Okay? Ang negative naman, may malaking effect din yan because it rotates in the opposite direction. So meaning parang, di ba, if your synchronous speed is clockwise, then the rotor speed is also clockwise. But because of the negative opposing direction, counterclockwise, parang try to opposing the actual rotation. So as a result, hindi na tama yung yung speed niya. It develops the direction opposite. Right? And as a result, it really affects, no? So the performance of the induction motor it's actually affected. Okay, so again, una transformer, tapos motor. Capacitor bank are also affected because if sa harmonics, kasi magiging heatsink yung capacitor natin, yun, masusunog siya. Okay? So, masusunog siya. Pasensya na ha, I have to go through na lang. 1 hour is really, napakaikli talaga ng 1 hour. So, the presence of the harmonics and the capacitor band can cause increase in the electric losses. Of course, heating, resonance, di ba? Then, of course, overvoltage. So remember, capacitor is an element that store voltage. Diba? So mag-overvoltage siya. So ang dami pala, no? Ang daming affected. Switchgear. Obviously, switchgear makaka-affect sa interrupting capability ng mga breakers natin. Protective relays, lalo na sa ground fault, ground protection, it may not able to distinguish properly the actual ground fault. But again, because of the zero sequence, yung mga methods of protection natin together with the ground fault relay, diba? So yung sa current ay mga residual, ay mga ano pa ba yun? Marami, no? And zero sequence detection. So there might be may mga noise stripping, di ba? So hindi niya ma-distinguish ng maayos kasi napakadami ng harmonics current. Metering device, lalo na, no? So if induction type, even solid state, affected talaga siya. So, hindi na tama yung hindi na tama yung reading mo. Mali-mali na, di ba? Lalo na sa electronic equipment. So, I keep on repeating this one. Somehow will really affect. So, single facing, okay, so hindi na natin itong pag-usapan ng So, it's a loss of one line perhaps, and affected talaga yung So let me have some practical solution. So one is grounding and banding integrity. Okay, so all your telecommunication, radio, and all electronic must be properly banded or grounded. Alright? So iba yung systems ground, iba yung equipment ground. Pag maganda yung grounding system mo, and maganda yung takbo ng power quality, di ba? Proper wiring, so obviously, pag spaghetti wiring siya, for low voltage perhaps, no, or maybe control of the switch gears, it will give you a good power quality. Those are just practical, no, but may mga talaga, mga power quality solution, like TVSS, no, transient voltage surge suppressor. So normally, parang kinaklap niya lang. So, halimbawa, wala to TBPS. So, may incoming na transient, napakalaki na spike or over voltage. So, diretso siya sa load. So, affected yung load mo. No? But because of this TVSS, so this unit clamps the impulse spike. Okay? So, most popular to protect our computers, maglagay tayo ng TVSS. Okay, so sa bahay-bahay, pwede tayo maglagay. Filters. So harmonic filters are used to reduce undesirable harmonics. So this can be passive or active filters. So passive filters consist of low impedance path. The frequencies of harmonics to be attenuated using passive components like inductor, capacitor. So sa basic communication natin, we have discussion regarding with the different types of filters. So in the system, if the system varies or change of harmonics, passive filter will become ineffective. But here comes now the active filters. So the active filter, the good thing for the active filters, ano siya, it will generate an opposite signal of harmonics para ma-cancel, no? So active filters perhaps very expensive, but it is now more becoming cost-effective, compensating para sa mga changing harmonics. Lalo na pag dynamic yung harmonics mo, no? So active filters is more reasonable. Alright? So it's an electronic, ano, no? Again, it can be series filters or shunt filters. Alright? So passive filters is a static use of inductors and capacitors. Active filters is sometimes referred as active power line conditioners. So they differ from passive filters in that they condition the harmonic current rather than block. So yun sabi ko kanina, it has the capability of producing or to counter, no, created harmonics. Okay? Wala pa. 5 minutes. Okay, isolation transformers. Sige lang. 20 slides. Used to isolate sensitive loads from transient and noisy deriving from the mains. No? Sige lang, may ano naman, may notes naman. So these devices effectively reduce conductive electrical noise by physical separation of the primary and secondary. So we are very much familiar with grounding transformer, section transformer. So marami na kami na-implement na ganitong klaseng na setup. Isolation transformer, especially for single phase, yung mga data center, pwede rin yun siya. So the thing is, the ratio is just only 1:1. So you don't have, hindi talaga siya transformer, kasi pag transformer, you have to step up or step down. But the ratio is 1:1, isolation lang siya. Para in-isolate mo lang. Voltage regulator, common sa atin yan, mga UPS, these are mga solutions, no? Okay, so I'll give this to you, the notes. Kayo na lang mag-ano. So mga possible solutions, kung ito yung mga problems natin, yung mga cause, sources or effect. There's so many books related on power quality. So this is the device that I'm talking about, Fluke 435 Series 2. Gamay na lang, konti na lang. Okay, so the PQA can read, no, a lot of quantities, a lot of information. Voltage, current, power, voltage sag, voltage dip, marami, flickering, unbalanced, transient, and so on and so forth. Harmonics. So I captured some of the results from our client, which I cannot disclose. Okay? Halimbawa, this one, na-record niya yung voltage, no? Etong mga oras na to, line 1, line 2, line 2, line 3. So, THD, nakuha niya yung THD. Nakuha rin niya yung sa current, yung TDD niya, yung total demand distortion. Ito yung total. So, hindi ito pwede solving using Fourier series. Pero sabi ko kanina, di ba? This one is another data, but it's kind of summarized data. So I consider it's fast. Okay. So these are the captured image. This deep voltage dip event. Okay, so may biglang nagpahanap ako sa engineer ko, pahanapan mo nga ako ng mga captured na voltage dip. There's an instant na nag-drop yung voltage. Ayun. Okay. So I think these are just the same. Harmonics, very high harmonics. You take a look this one. This very distorted. In fact, the THD is 45%, 55%, di ba? Napakalaki, 58%. So napakarumi ng ng system. So pinaliit yung yung period. Ito, medyo klaro na yung ano, yung waveform. That's the good thing of PQA equipment. You can also use the computer as well. So this is another mas clearer siya. Pinaikli na naman yung ano niya, yung period. Mas clearer na. So there's a harmonic event here. Pero mataas pa rin, no? So limit should be 5%. So eto, what's this one? This one is the flickering perceptibility, no? So standard should be ano dito yung standard? 3% ba yun? So in electrical engineering, flicker is defined as short-term voltage fluctuation in the power supply system. So long-term perceptibility of flicker perceptibility, eto, this one. This long-term, this short-term, is further measured for cumulative irritation caused by very occasional gross flicker events, which may be too infrequent to cause meaningful short time. And of course, short time flicker perceptibility is the measure over a short period, no? Irritation. Yung mga flickers naman to siya. Okay, standard for short term, depende sa voltage, so 0.8 and 0.6 sa long term. So that's why pasado to siya. Okay, power, you can also measure power factor. And ito yung THD, average, maximum, minimum. So nakikita dito yung yung power factor reading and power. Ayun, ito medyo mataas, hindi ko mabasa. Power factors only rises on 0.85 lesser load. Kasi pag nag-PQA tayo, mas maganda yung 24 hours or 7 days a week, no? Para makita talaga natin yung ano. Okay, this one is another data. Voltage harmonics. Kapit na, time na. Yes, Sir Bob.
Okay.
Eto na, tapos na.
3 minutes to wrap up, sir.
Okay, tapos na. Sorry talaga. So, 5% yung limit natin, no? The TDD, ito, may 5%. Depende sa sa ratio ng, hindi ko mabasa, short circuit and normal current. Okay, so I hope that fundamentals. I hope that nakuha tayong magandang learnings today. Thank you so much. Back to you, Sir Babcab.
Okay, Sir Erwin, thank you very much. Being a master of electrical engineering and also a professor, you can now, during your, if you have a project, you can mitigate for a power quality. You assured your customer for a power quality. Thank you very much, Erwin.
Thank you, sir.
So may I call
Thank you so
in,
much.
Engineer John Baclay? You're welcome. Engineer John Baclay, you award the certificate.
Correct na sila. Ikaw din. Kaya ito mag-introduce nila.
Okay, so IIEE Cebu chapter awards this plaque of appreciation to Engineer Erwin J. Salvador as technical resource speaker on the topic Fundamentals in Power Quality Assessment in the 21st Eastern and Central Visayas Regional Conference held on 27 to 30th day of July 2022 via hybrid at the Sky Hall A&B SMC side South Road Properties is Cebu City given this 27th day of July 2022. Signed, Magdaleno Imbaclay, President, IAA Cebu Chapter. Ronmar Gonzalez, VP Technical Affairs. Brian Pasilan, Regional Governor. And Erwin J. Salvador, Technical Consultant and Advisor.
Thank you, Engineer Luel. So the notes will be given to the Secretariat. So the Secretariat will be the one to distribute the notes. Thank you so much for listening. I hope to see you in incoming webinars and seminars in the future. Thank you, and God bless everyone.
It is very kind of you, Sir Erwin.
Very
So,
kind.
okay. So our next speaker. Okay, all okay na. So, our next speaker will be properly introduced by Engineer Luel Ratilla.
Sir Bob, I'll be introducing you. Nabali, Sir Bob.
Okay, bali. Okay, so go ahead, Sir June.
Okay. Good afternoon. Our next resource speaker is a graduate of Bachelor of Science in Electrical Engineering at the University of Santo Tomas. He's a Master in Business Administration from the De La Salle University. He is also a registered electrical engineer, an ASEAN engineer, an ASEAN Chartered Professional Engineer, a member of the IIEE Energy Efficiency and Conservation Committee, also a member or an expert on energy efficiency and energy management, and he is also the former national president of IIEE in 2007. Ladies and gentlemen, please welcome Engineer Raymond Marquez. Sir Raymond.
Can you hear me? Can you hear me?
Yes.
Okay.
Yes, sir.
Yes.
Loud and clear, sir.
Yeah, many
Ngayong hapon,
many
sir.
thanks to Sir June for the introduction, and hello to Bob. Long time no hear.
Hi, sir.
Okay, let me share my screen.
Yes. Thank you, sir. Okay, sir. You're loud and clear.
Okay, can you see my screen?
Yes, sir.
Okay. Again, mayong hapon.
Introduction to energy audit.
Yep, mayong hapon or good afternoon.
Hapon.
Okay, the topic is quite timely because if many of you have received probably from DOE requirement on energy audit every 3 years, and the deadline is December 31, 2022, whether you're a type 1 or type 2 designated establishment. For type 1, as a review, it's 500,000 to 4 million kilowatt hours annual consumption, while for type 2, it's 4 million kilowatt hours and above. Okay, so you are required to have a detailed energy audit by December 31, 2022. So this is timely. Okay. Well, we're closing to end July, so that means you have barely August, September, October, November, December, 5 months to go to comply with the requirements, okay, of the RA 11285. Okay, so let me start. Medyo maingay lang. Where is that sound coming from? Please check sound. Hello. Can you hear me? Can can we mute ourselves? IAE Cebu 1, please. Medyo noisy. Hello?
Hello, sir.
Yes, can we mute IAE Cebu 1 because it's noisy? Sorry. Okay, so I'll be talking about introduction to energy audit. Normally, this topic is 3 or 4 days, no? 3 days lecture, then 1 day practicum. Okay, but it's like it's an on introduction of energy audit. Okay, so for you to understand what energy audit is. Okay, so first let's start with the definition. This came from ASHRAE. Okay, so let me read. ASHRAE and other entities have defined energy audits as a processes in which engineering service providers identify and recommend efficiency opportunities to clients. So there are two objectives. First one is, of course, to reduce the energy use and or cost of operating a building, while the second one is to improve the indoor environmental quality experienced by the occupiers, no? Especially for commercial buildings. Okay, so basically it's to reduce the energy use of a particular building or facility. Okay, so I'll be talking more of commercial buildings in this presentation, but I can tell about briefly about the industrial energy audit. Okay, let me get the laser pointer. Yeah. Okay. So okay, so there are different levels of energy audit per ASHRAE, no? And in the DOE circular, it doesn't mention about what level of energy audit is required, no? So we clarified with DOE, and they said that level 1 or level 2 is acceptable for now, no? For now. Okay, so that means I'll explain more about level 1 and level 2 later. Okay, so the first stage or level 0 is this preliminary energy use analysis. So before we go through level 1, which is a walkthrough, we get to get information of the potential building or facility. Okay, before, no. So let's say normally we ask for latest single line diagram, latest equipment schedule or list, then mechanical schematic diagrams, and electrical single line diagrams, okay, among others, no? So we can really be prepared when we go to the walkthrough. We can look for what we intend to look for and ask the questions that we think would be relevant. Okay, so okay, so that's level 0, no? In preliminary energy use analysis. Now let's go to level 1 walkthrough. I'll go more detail later on. It's basically 1/2 day or 1 day of walkthrough with experts from our team or from any team that goes through the facility, whether it's commercial or industrial. Currently, we have one complete team, one expert on building envelope, 2 mechanical engineers, and 2 electrical engineers. No, but because of the more queries and possible more jobs on energy audits, we are expanding to another team, no? And that's for commercial buildings. No, but of course for industrial, I'll be tapping experts for particular system. For example, compressed air or steam system or refrigeration, for that matter. So during level 1, you go to the site half day or 1 whole day and look into the possibilities. No? For commercial buildings, it's basically building envelope, mechanical, and electrical system. While for industrial systems or industrial plants, you have systems like steam, compressed air, refrigeration, HVAC, hot water, compressed air. Okay, among others, no? Plus production, of course. Okay, then So that's level 1. Level 2 is energy survey and analysis. This one is more detailed, meaning there's metering involved. No? We bring in our flow meters or energy meters to validate what is available on site in terms of information. Okay, and that's why it's more expensive to conduct level 2 versus level 1 because there's metering involved. And for commercial buildings, we normally have a 7 to 8 day cycle of data collection. Okay, and then level 3 is detailed survey analysis. This is similar to level 2, but the metering involved is about a month, minimum of 1 month to 6 months. So very expensive in terms of, metering. No, kasi it will involve, I guess, more meters and more time. Like it's 1 month or 30 days, and it's normally there's rental of equipment. Okay, so that's basically the 4 levels. So now, who can conduct energy audit? The energy assessment provider may be one person or a team. One person can do it if he has all expertise on all systems. No? But it's quite difficult to have one person to be the expert, especially the Philippines, that because there's delineation of responsibilities. Like, for example, if we're electrical engineers, we should be confined with electrical systems, while mechanical systems should be confined to mechanical. Mechanical engineers should be confined to mechanical systems. Okay, so in our company, we have a team, as mentioned earlier. No? And here, you have a building envelope expert, mechanical engineer, electrical systems expert, control systems expert, and energy modeler. In our case, we have 2 mechanical engineers, 2 electrical engineers, and I do the energy modeling as well as the financial modeling. Okay, so in more detail, what is level 1? Preliminary walkthrough audit. Level 1 audit allows the overall energy consumption of the facility to be evaluated. It is expected to give an overview, providing a rough estimate of savings and costs. So here, I emphasize it's rough estimate because there's no metering involved. Of course, there are plants or buildings that have sub-metering, then that's where we will use all that information and get and process it to come out with energy utilization index, as mentioned here. Okay, so the process of level 1, it's conduct preliminary energy analysis as in level 0. No? Conduct walkthrough survey, identify low cost, no cost recommendations, identify capital improvements. No? Part of the report is to estimate savings from utility rate change, or let's say improvement in efficiency. Compare EUI. EUI means energy utilization index. No? For in the case of commercial buildings, it's normally kilowatt hour per square meter. Okay. In case of hospitals, it could be kilowatt hour per beds, or probably square meter. For hotel, it's kilowatt hour per square meter or number of rooms. No? So depending on the available indices of each building. In the case of manufacturing or industrial, you have kilowatt hour per metric ton of product or ton of product. No? Okay, so it's a gauge of really input output of in terms of energy. Okay, then part of the report is summarize utility data, estimate savings if you EUI met target. Okay, so it's a macro. The level 1 is macro in terms of information. No? And normally, because of the requirement of the law, but it doesn't state whether level 1 or level 2 is required. So I normally propose level 1 to have a baseline, no, of the facility. Because come 3 years from now, 2025, DOE might impose level 2 on the facility. Okay. Okay, so level 2, energy survey and analysis audit. Okay. Level 2 audit identifies the source of energy of a facility, the amount supplied, and what the energy is used for. It also involves short-term metering and logging. So as I mentioned earlier, there's short-term metering. So in our case, for commercial buildings, we capture a 7 to 8 day cycle. No? So we can see the profile of the building on a weekday versus a weekend. No? Okay, so you can see the spikes, on a 24-hour, on an hourly basis. Okay, so process is detailed site visit. So you have a walkthrough, then a detailed site visit. Then we review mechanical and electrical design, the condition and O&M practices. We measure key parameters. So let's say if you're using centralized chilled water, we measure the flow of chilled water, and then we measure energy of the chillers or the pumps, of the cooling tower fans, etc. Okay, so to come up with a system efficiency. Okay, then we analyze the capital measures, savings, and costs. Mas detailed siya, so though we can get estimates really of how much does it take to retrofit or improve on the efficiency of system or the building. Okay, and of course there's a meeting with the owner operators to review recommendations. Okay, so in terms of report, you estimate low cost, no cost savings, perform detailed end use breakdown. Okay, this end use breakdown will detailed, let's say 60 to 70% of a building is HVAC. And then let's say, are you using hot water? How many percent is that? If you're using steam, if you're using elevators, no, and the likes, you can easily see the breakdown. No? So you can focus on which one has the largest potential in terms of savings. No? And then you estimate capital project cost and savings, more detailed because we solicit estimates from suppliers on, let's say, replacement of chillers or pumps or cooling towers and the likes. And then we can do the savings calculation. Okay, so it includes building description and equipment inventory, then general description of the measures, no? And the recommended measurement and verification method. Of course, in this report, for level 2, you have more or less the saving, the simple payback of each energy efficiency measure. Okay. Okay, and then we go to the next slide, level 3. Okay, as earlier mentioned also, it involves, this is long term, meaning 1 month to as long as 6 months. So very expensive because it involves meters that are to be installed on site. No, okay, so that basically it's the same as level 2, although in terms of data, it's more data involved. No? Okay, so we compare the 3 levels, no? 1, 2, 3, in terms of process. If you notice from level 1, you have a few process, so it's cheaper and it's shorter versus level 2. Okay, and then level 2 is long, more extensive in terms of process, and you'll notice in terms of report, it's also extensive. So it's more expensive and longer in duration. And of course, level 3, it's the more expensive one because it entails the entire process of energy audit. At the same time, the reports is very extensive. Okay. Okay. The following slides came from my my webinar that I enrolled with the APO. APO is the Asia Productivity Organization. Okay, and it's about energy audit and energy management. Okay, so here, so I'm sharing these slides to you because they are very relevant, and I think I want to share it to you for guidance. No? Okay, so key consideration for measurements to estimate energy use. Okay, one question is, do we need to measure everything? No. In our case, for level 2, we look for the major energy use. No? So that's where we need measurements. Okay, let's say we have compressed air, well, for industrial, compressed air, steam, refrigeration, no? These, and then production. These are the major usage in the industrial facility. No? While for commercial buildings, it's HVAC. You have elevators and you have common areas. Okay. So then we need to measure enough to estimate energy use and savings for the required level of accuracy. Okay. It's acceptable to make estimations and use documented data depending on details required. Okay, so especially if we're conducting level 1, we will make use of utility meters. And if you have sub-meters, we will extensively use information available. Okay. So we can also consider saving potential and accuracy versus cost. And then there's risk. Okay, so doesn't mean that we need to install, let's say for level 2, to install 50 meters on site just to measure. No? As far as our experience, we have maximum of 25 meters installed in a mall because they were asking for more detailed efficiencies of systems. You know? But that doesn't mean that for a particular building we need 25 meters. Depending on how strategic is the location of the load. Okay. Now measurement types. No, you have spot measurements, which is normally for level 2, and you have multimeters to be used, gauges, pressure gauges, tachometers, lux meter for lighting, thermometers. If you have boilers, you have stack gas analyzer. Again, for short-term metering, you have electric current or power, CTs and BTs, motor runtime, occupancy schedules. These are information that we need on site. Standalone battery powered. Here system specific measurement of flow, pressure, dew point, velocity, and temperature. Okay. This is for chilled water, hot water, and refrigeration. And okay, for long-term metering, you have more or less what they call permanently installed equipment because it's 1 month to as long as 6 months, and more of energy meters, no, to be installed on site. Okay, so tools that we use for data collection, you have power loggers, of course, 3-phase. You measure power factor, power, kVA, kVAR, and hertz, and to determine the load on motors, pumps, compressors, fans, and production equipment. Okay, right now I have 4 current data loggers and 8 power quality analyzers. Very expensive. Okay. And 3 flow meters that can measure chilled water flow and hot water flow. Okay, sample current logger. Okay, multimeter clamp meters. We have also power clamp meter, okay. Digital. Infrared thermal camera, portable ones. We use that for checking hotspots in the system, whether it's electrical, steam, refrigeration, hot water, and compressed air. Okay. Then sample of outputs of infrared thermal camera, temperature loggers. So that means you can store data enough to evaluate it, no? Especially if for level 2 we need 8 days data, no? So we have most of our data loggers have more capacities available. And then, of course, the PQAs. No? You have, as presented earlier by the previous speaker, it's Fluke. We have we're using AccuVim 2, and we're quite satisfied. It's using Rogowski coils, and we can do 6 points at a time with our newest PQA. Of course, ultrasonic liquid flow meter, so there's no shutdown. This is for chilled water and hot water. And we need to remove the insulation and install this. Then we leave it at site for the next 7 or 8 days to get information and data. Yeah, we have pressure measurements, pressure loggers also. Okay, so we can have enough data on pressure installed. Normally, we have our own gauges also in case that the existing gauges are not calibrated or defective. So we either use our pressure loggers or our calibrated pressure gauges. Okay, ultrasonic detector used for steam or compressed air for determining leaks. No? But this is more expensive equipment, but you can easily see leaks by, well, visual and of course using soap and water to determine the leaks. Okay, you have anemometer for HVAC use, especially for indoor air quality. Okay, we don't have this because this is quite expensive, and it's not too often that you use flue gas analyzer. But I do have a vendor who can rent out this gas analyzer and even the gas ultrasonic flow meter. Gas meaning ammonia or CO2. Okay. Okay. Basic for us electrical engineers, lighting measurements, lux meters. You have indoor air quality measurement for CO, CO2, and RH. Okay, sample installation of temperature measurements of the chillers for commercial building, chilled water flow measurements using ultrasonic flow meter. Okay, so yeah, no interruption on site for chilled water and hot water. But I guess for gas, ultrasonic gas, there'll be some minor shutdown. Okay, that's for previous one is for mechanical side. Now on the right side are the electrical side. So energy meters to be installed on the electrical loads. Now for safety, of course, PPE safety shoes, scaffolds, rubber gloves, scanner bulbs, equipment grounding. Then for mechanical equipment stoppage, sometimes when we install the pressure loggers or even temperature loggers, we have a short stoppage because sometimes there's leaks on the wells, temperature wells and pressure wells. Okay. Checklist of requirements prior to building's energy audit. Of course, utility billing on electricity, water, fuel. Normally 12 months, but it could go as long as 36 months, especially during the pandemic. No? Then we ask for a site plan, floor plan, equipment schedule, mechanical schematic diagrams for each system, and electrical single line diagrams. Okay, we have here the outline of level 2 commercial building energy audit. Okay, based on ASHRAE again. So there's an executive summary, methodology. Under methodology, you have 4 parts: baseline facility description, then part 2, walkthrough analysis, part 3 is building and systems report, and part 4, energy analysis summary. And lastly, part 5 is detailed recommendations. Okay, so basically that's the level 2. level 1 will have the same outline, but of course there's no metering data, so we will use the data collected on site. Okay. And okay, so I'll be presenting a case study in the US. No? Why in the US? Because all of my clients in the Philippines we have an NDA or non-disclosure agreement. So that means I cannot share information based on the level 1 or level 2 audits we conducted with them. Okay, so I'll be sharing this level 2 Franklin building in the US. I guess I still have time, no? Okay, so as mentioned in the outline, you have the executive summary. Okay, of course, this is the last part that you will have to prepare because you have to complete the entire report before you develop this executive summary. And what's the content of the executive summary? It's the results you mention, and if you read it, you see a brief description of the facility and the potential of savings, no? And what measures are applicable for that building. Briefly, a brief discussion of measures. In this report, there are 2 buildings involved, the 140/160 Franklin, and that's 2 buildings. Okay, so same on the level 2, and even in level 1, you have the methodology. No? So what are you using in terms of standard? No? So in this case, it's ASHRAE level 2 energy audit was selected. Okay, so then you describe how did you do with the investigation, data collection, and the documentation review. Okay. And then you go to part 1, which is a baseline facility description. So basically, you mentioned about how big is the area, and if they're using glazing in the glass, or windows or doors, what kind of materials for roof, what's the general occupancy in terms of schedules, and the likes. Now, then, in terms of what are they using in terms of HVAC? No? So on the right side is the brief building description. So, and then the primary building type. No? So you specify whether it's an office building or hotel or apartment, and so on and so forth. No? Then we proceed with the energy performance summary. Of course, in the US, there is 2 normal sources of energy, no? Electricity and natural gas. Electricity for their air conditioning, while natural gas for their heating. No? Could be through the boiler or some other heat exchanger. Okay, so here, kaya normal sa kanila that they have electricity and natural gas. Okay? And then you have here the EUI, no? Energy Utilization Index of the existing. Okay, so basically it's you compute for kilowatt hours. There in the US they use kBTU per square foot per year. No? In our case, it's kilowatt hour per square meter per year. Okay, based on energy utility billing, you divide it with the gross floor area. Then you come up with that EUI for commercial buildings. Now for cost index, it's really cost, meaning in dollars or in peso in our case. That's peso per square meter per year. Okay. Now analysis of metered electrical demand. No? So you have maximum demand, minimum demand that you have in the contract. Okay, and then they get this index also based on watts per square meter. Okay. Now on the lower right is a comparison with similar buildings. So in their case, this building is 52 while yung comparison has a higher EUI. So that means they're quite efficient. Okay, now preliminary building use. You mentioned about average hours per week, average number of occupants during normal occupied period, and after hours cleaning. Okay. Then you tabulate the overall building schedule in terms of the days of the week, and the hours open, hours closed. Then from there you have a preliminary energy allocation to end users. So here in their case, it's 3: heating, cooling, and domestic water. Okay. In our case, it's cooling and others. Okay. Okay, meter consumption monthly data. Okay, from the utility. You tabulate the 12 months here. Okay, and the cost. Then you go into details. HVAC system. In their HVAC kasi it's heating, ventilation, so mayroon silang heating. Then you have cooling. Then you have fans and the controls. So it's a brief description of their system. Then on the right side, it's electrical system, particularly on interior lighting, what they're using, exterior lighting, and in terms of controls. Then, since they're using fossil fuel, diesel in particular, or natural gas pala in their case, for domestic hot water. Okay. And then, brief description of operation maintenance procedures. In this case, there are no current documented O&M procedures. Okay, then let's go to part 2 or walkthrough analysis. So here, it's like a zoning, no? So A, B, C, D, E, F. Function type, you'll see it on the right side, yung function types. So here for space A, you have 2 as a function type, which is corridor. And then condition area in terms of square foot, space usage in terms of hours per week, and weeks per year. Principal lighting is type 1, which is fluorescent on the lower right. And HVAC is 33, which is VAV. Okay. Yeah. So here, tabulate. Okay. Next is building shell characteristics. No? So here it mentions is the building insulated? Are they using glazing? Is the roof insulated? Floor, is it insulated? So, and in terms of ilan area, how big is it is insulated? Then operation maintenance on the lower left, and then right side lighting system data. They get this watts per square foot. Okay, in terms of index for lighting alone, and then compare. They're using 100% fluorescent. Okay, part 3 is building and system support. Okay, so it's more about envelope. And when you say envelope, it's window, walls, first walls, doors, roof, and glass. Okay, so ito yung coding nila. W1 is wood. D3 is an insulated metal. D5 is glass. R2 is roof, concrete block, deck. G11 is single glaze, in terms of windows. Then G12 is single glaze pero skylight. Okay, with the corresponding R values, and if there is glass shading coefficient, and then in terms of area. Okay, lighting system characteristics. Okay, so here it mentions typical watts per square foot, design of controls, typical watts per square foot, and the lighting levels. Okay, then on the right side, HVAC system, it describes the heating system, cooling system, and air system. Okay, now energy performance target. So kanina, it's they presented yung current energy performance. Now, ito naman target. So here, again, electricity and natural gas, they are looking at reducing the electricity and natural gas. Again, so there's a computation of EUI. Okay. If you do some energy efficiency measures and corresponding electrical demand, if there's reduction. Okay, part 4 is energy analysis summary. Okay, so here.
Sir Raymond, interruption.
Yep.
Excuse me, Sir Raymond.
Yep.
Interruption, Sir Raymond. Can you wrap up your topics, Sir Raymond?
Yes. Maybe 2
minutes,
slides
because
na lang
the
to.
time is almost done.
Yeah.
Okay.
Yeah.
Okay, thank you, sir.
Okay, so here, okay, almost done. Part 4 is, okay, it tabulates yung actual use, tapos yung target. So here you see yung target, yung reduction, computation in terms of KBTU, no? And in terms of dollar. Okay. And then on the right side, what specific breakdown of the annual energy use. Okay, in terms of space heating, outdoor air heating, space cooling, outdoor air cooling, fans, pumps, etc. Okay. Naka-breakdown siya. Ngayon, in pie chart naman, you see na biggest nila would be space heating. Okay. So yun ang mag-focus sila. So on the right side is the recommended energy conservation or energy efficiency measures. So they list down 13 measures, no? With the corresponding implementation cost and savings, no? Computed estimated savings. Okay, so they can come up with a simple payback. Okay, so yan, kasama yan. Then lastly, detailed recommendations. So on a per measure, kasi level 2, it's on a per measure level. You describe the energy efficiency measure in particular. Okay, that's it, sir.
Okay, sir. Thank you very much. So energy efficiency is output over input, and that is the efficiency. So we are very glad that we have a speaker like Engineer Raymond Garcia, who shared his talents for the energy audit. Would you kindly give him a round of applause?
Thank you.
Thank you, sir. Sir, there's a question here, sir. There's a question here.
Yep.
You may read that, or
Yes.
if I may read.
Yeah, you can read it and I'll
Okay,
respond.
hello, Sir Raymond. Ask lang ko.
Yes.
Okay. Hello, Sir Raymond. Ask lang ko, sir. If we pass katong about the DOE submission that the energy consumed or used last 5 years, and we have different plans, is it per plant or as the whole company?
Ideally, it's per plant, no? Kasi per plant may have different profile. So you can have one big report, one company report, but you need to have breakdown of each plant, no? Kasi iba-iba ang EUI ng each plant. Okay?
Okay, thank you very much, sir. So I hope the anonymous attendee is satisfied with our answer.
Yeah.
So, Sir Raymond, may I request for the awarding of certificate, may I call on Engineer Louis Latilia to award the certificate? Sir Lowell? Sir Lowell? Hello? Hello?
Hello, sir.
Sir Lowell, go ahead.
session. IIEE Cebu chapter awards this flag of appreciation to Raymond A. Marquez as technical resource speaker on the topic Updates from IIE Energy Efficiency and Conservation Committee in the 21st Eastern and Central Visayas Regional Conference held on 27 to 30th day of July 2022 via hybrid at the Sky Hall A and B SMC site, South Road Properties, Cebu City. Given this 27th day of July 2022, signed Magdaleno Imbaclay, President, IIE Cebu Chapter, Ronmar B. Gonzalez, VP Technical Affairs, Brian Ipasilan, Regional Governor, Erwin J. Salvador, Technical Consultant and Advisor. Thank you.
Thank you.
Thank you, sir. Sir Raymond, thank you very much. It is an honor for us. Okay. Okay. So our next speaker for this, last speaker for this afternoon, he will be formally introduced by Engineer June Baklay, our President of IIE Cebu Chapter. Sir June? Sir June? Sir June Baklay? Hello, Sir June. Sir June Baklay? Hello? Sir June? Okay, Sir June, I think there's a technical glitch there from the administrator. Anybody from II Cebu? Is there any technical glitch or what? Okay. Hello? Hello?
Okay, so sorry for the gun because we have technical issues here. So our next speaker for this afternoon is a graduate of Bachelor of Science in Electrical Engineering from Central Philippine University. He is a registered method of disposing discarded mercury containing lamps, uh, utility model, intellectual property office, Bureau of Patents, Republic of the Philippines. He is also a chapter president, former chapter president of IIE Iloilo in 2020. A member and Pollution Control Association, a member of the Pollution and Control Association of the Philippines, Iloilo chapter. He is currently the CEO at HG Care Environmental Engineering Services, COO at SG Care Waste Management Services. Help me welcome our next speaker, Engineer Alan Biton.
Good afternoon. Thank you. Thank you po, sir. Oo. Audio check lang po, okay po ba?
Yes, sir.
Allow me to screen sharing. Good afternoon po. Medyo nagka-problema lang ng technical. IIEC po, can I do the screen sharing? Audio check
Yes,
lang,
sir. Go ahead, sir.
Audio check, okay po ba?
Okay po, okay po.
Okay. Sige.
Yung visible po yung PowerPoint nyo.
Sige. Naantay ko pang lumabas dito sa akin. Okay na. Okay po, sir, no?
Yes, sir. Presentation na po yung yung makikita.
Sige, okay. Thank you po. So, pasensya po medyo nagkaroon ng natagalan siguro sa antay siya. Okay. So, the Research and Development Committee for this 2022, promoting research and development culture among the EE practitioners. So, the contents of this presentation are the following: about the IAE R&D Committee, the review of R&D concept, the R&D opportunities for EE, and the R&D committee activities. So we have the 2022 members of the Research and Development Committee. Our chairman is Sir Engineer Nelson Andres, the vice chairman, yours truly. So we have our secretary, Engineer Roland Manalang, and the members, Engineer Mandy Soprepena, Engineer Dan Alvarez, and Engineer Bacorio, Engineer Arnold Balburo, Engineer Greg Malyari, and Engineer Reynolds Sibayan. Our support from the admin. So we have our overseer in the person of Engineer Ramon Gatsalian, our champion advisor, the previous speaker before me, Sir Raymond Marquez, Engineer Raymond Marquez, and our secretariat, Ms. Maika Dailan Crisologo. Naglalag lang po yung kwan eh. Sandali. So these are the profile of the R&D committee. So we have the chairman from the Bataan chapter, the dean of the College of Engineering and Agriculture, yours truly from Iloilo chapter, Engineer Roland Manalang, also from the Bataan Peninsula State University, Engineer Mandy Ismael Sobrepena from Western Institute of Technology, Iloilo chapter, Engineer Dan Alvarez Bacorio, the senior commissioning engineer from IIE Saudi Arabia chapter. We have also Engineer Arnold Alboro from Isabela State University, IIE Isabela chapter, Engineer Greg Malyari, Bataan Peninsula State University, IIE Olongapo Zambales chapter, Engineer Raymond Sibayan from Holcim Philippines La Union plant, IIE La Union chapter. So we have this appointment as the members of the 2022 Research and Development Committee as issued by the incumbent president in the person of Honorable Feliciano Padua. The duties and responsibilities of the Research and Development Committee. The committee overseer ensures the right focus of the committee on its mandate to endorse to BOG resource requests on projects. The champion advisor that pushes for the committee innovations and new advocacy projects relevant to committee mandate. The committee chairman leads the mandate of the committee, set committee KPIs for committee overseer approval. The committee secretary input actionable items to action logs, the minutes of the meetings, and our secretariat support do coordination with the resource logistic requirements with the admin department and do compilation of records in the website. The mandate and KPIs of the Research and Development Committee. The Research and Development Committee is responsible for the conduct of studies and implementation results intended for the improvement and upgrading of any electrical system products and new technologies. The KPI or objectives or key performance indicators is to promote research culture within our organization, facilitate contests on innovations, inventions, or projects related in EE professions in the IAE affiliated schools, provide assistance to members with relevant research projects for mainstreaming, publication, and patenting, represent IAE for R&D activities and collaboration efforts with various stakeholders. The time plan and program of the committee are as follows. So we do the monthly meetings and research and innovation contest or steer dip. Steer dip will be presented to you later, such as sa mga naggawa ng mga ng activity ng Research and Development Committee. Conduct R&D seminar and training, paano ba ginagawa yung research and development papers, and scouting for researchers needing assistance. So nandun po yung Research and Development Committee. Pag meron kayong mga ideas or what, or innovations na pwede gusto nyong i-channel through the Research and Development Committee, nandito po yung committees for that. Review of R&D concept. So by definition, R&D is a model of numerous innovative and out-of-the-box activities powered by science and technology to develop or enhance the products and services in private, public, and social sectors of the industries. Kung makita niyo po science and technology, so combination of professions na nandiyan, yung mga scientists natin, and technology, tayong mga engineers po. So R&D, R stands for research. These are the activities, the development, and the aim for research is new knowledge, and the aim for the development is increased effectiveness and increased efficiency. The process, we start from generating the ideas, refine the ideas, basic research, applied research, do the development, come up with the innovation, and scaling up, upgrading. So kung meron mga existing na mga technology na in the future, pwede pang ina-upgrade, meron po na ganun na ginagawa. So the phases of engineering method. May apat po yan na method of research and development. One is the phase in the engineering method. So the phase one is the idea, which we have to identify the problem. Phase two is the concept, existing solutions, requirements, constraint, possible solutions kung meron. Phase three, planning. We do define the objectives, the plan, program, and schedule. Phase four po is drawing, schematics, models, algorithms, proof of concept, mga computations. And phase 5 is the development. Prototypes, we do the prototypes, experiments, validation, and verification kung meron na pong prototype. And the phase 6 is the last phase, launch the technology or the innovation na nagawa po. Evolution of role of R&D. From the teaching-centric, the R&D conducted to improve teaching and capacity building. Peer-centric, R&D conducted to contribute to the overall scientific knowledge from publications, patents, impact factors, citations, H-index, and SES. And the society-centric, R&D as a tool for positive societal change, impact assessment, economic gains, and startups. So the DOST Research and Development Agenda, yung DOST po is very supportive for mga inventions, mga innovations na gawa po ng mga kapwa natin. So ambition natin 2040 ng DOST is Science for the People approach harmonized national R&D agenda in the various areas: agriculture, aquatic and natural resources, health, industry, energy and emerging technology, disaster, risk reduction in climate change adaptation, National Integrated Basic Research Agenda or DIBRA. So tayo po sa electrical engineering industry, pasok tayo dito sa industry, engineering and emerging technology. So this program is till 2040 po, malasakit, pagbabago at kaunlaran. Science for the people approach. The 6 P's metrics for the evaluation of R&D proposals. Kung meron tayong mga proposals, ito po yung guide metrics. So the publication, the patents, the product, the people services, places and partnership policies. Pero may bago pong ginawa ng new metrics na na-include yung 2 I's na tinatawag. So the social impact and the economic impact of the project. Yung resulta po ng invention or what. Research and innovation, continuous cycle po yan. So we do the research, knowledge and technology, gawa tayo ng innovation, and then it will generate financial, maka-generate po ng financial na income. And then ulit naman, research naman, ganon, cycle lang po siya, continuous. So hindi po tayo dapat mawala ng mga ideas na pwede nating i-develop through the Research and Development Committee of the IIEE. Ang definition po ng innovation as presented po, yung problem recognition plus the problem solving plus the solution exploitation equals to innovation. So kung combine mo po yan, it will give you the creativity na impression. So you are very creative kung ganon. As per Thomas Edison po, anything that won't sell, I don't want to invent. So in-invent po si Thomas Edison na naging yung social economic impact po niya is very profitable po. Turning an idea into solution that adds value from a customer's perspective. So let's say sa ganitong sitwasyon natin is nasa pandemic po tayo. So ang issue dyan is yung safety ng mga areas natin na expose tayo. Ano pong pwede natin i-develop in line with our electrical engineering industry na makatulong po as engineering control measure na ma-control natin, ma-mitigate natin yung mga infections. So yun pong mga idea. Mamaya makita niyo po yan. Example of upscaling from the traditional power transformer to this one. Power transformer pa rin siya pero minodify niya yung mga design niya. Also this one, insulators. Dati porcelain, ngayon ganito na siya. Upscaling. So the insulation tester from the analog type to the digital type. So the digital type was invented and then developed further in enhanced, naging kuha na siya, digital na po. So it's a matter of also innovation done through research. The research type methodologies, scientific method, engineering method, empirical method, and analytical method. So ang compare lang po natin dito are the two, the scientific method and the engineering method. On the scientific method po, they start with a question, ask a question, and do the background research, construct a hypothesis. Hypothesis is a scientific intelligent guess. Test with an experiment. Procedure working? No. If no, troubleshoot. Procedure, carefully check all steps. Balik ka sa test and experiment and then go with the procedure working outlet. Check. And then if yes po, analyze data and draw conclusions. The result align with the hypothesis. Tanong. Pag align siya, communicate results. Results align partially or not at all with the hypothesis. Balik ka ulit. So experimental data becomes background research for new future project. Ask new questions from your hypothesis, experiment again, and then balik-balik po. Now, in our industry, engineering, electrical specifically, we define the problem, do the background research, specify requirements, brainstorm, evaluate, and choose solutions. We develop the prototype and the prototype solutions. We test the solutions. If the solution meets the requirements, communicate the results. If the solution meets requirements partially or not at all, so we go back based on results and data, make design changes, prototype, test again, and review new data. So paikot-ikot pa rin up to the point na makuha natin yung objective po natin. Research areas for electrical engineering. So kino-compare dito yung scientists saka yung engineers. Scientists and are investigators. They are observers. Ask why this happened. Explain our world. Sa engineers naman po, designers tayo, problem solvers. Ask how can I make this happen? Improve our world. So makikita niyo pong difference. The R&D opportunities for EE. Ito po 'yon. Oo. Kung meron kayong mga ideas na meron na pwede nyo develop, these are the areas kung saan pwede siya. Sa applied electromagnetics and RF circuits, control systems, robotics, common po yan, computer vision, embedded systems, power and energy. Sa ngayon po dito, power and energy. Very kwan po ito sa mga renewables. Ito renewable energy, and then the electrical machines, the smart grid, the power plants, smart building, additive manufacturing. So ang trend ngayon is to go for the smart grid, and then meron naman po mga smart buildings na nag-apply na dito. Power plant, parang present po lahat talaga ito. So those are the areas na may mga opportunity po yung research and development related to electrical engineering. So these are the programs na nagsusupport po sa research and development sa Philippines. Yung NICER, niche centers in the regions, NICER for R&D, establish the R&D centers in the regions to promote regional development. The RD leadership program engage R&D experts to lead in strengthening the research capabilities of higher education institutions and research development institutions. The CRADLE, collaborative research and development to leverage Philippines economy program. They create the synergistic academy-industry relations to integrative Philippine research and development, and the business innovation through SNT BIST for industry program. Facilitate the acquisition of strategic and relevant technologies by Filipino companies to support R&D activities. So sa under po yan ng DOST, nagkaroon po ng, I thought that was last year, calls for proposals for 2022. So the programs that supports this RDBIST, the Cradle and NICER programs. So meron pong schedules of call for proposals. Ganyan po yan. And then tapos meron pong budget. As of December 2021, 76 approved projects po ang nagkaroon in 10 regions. So may budget po na 344.5 million. So open po yan. Pag meron pong mga idea tayo, dahil sa mga electrical practitioners, kung meron po tayong mga idea, very much open po yung committee to support that idea. Tutulungan po kayo. Hanggang from the start, paano gagawin, up to the patenting, makahanap ng mga fundings, ganon. All you need is the idea. So nakita nyo po, May 3, 2021, 2022. So meron po siguro ito for 2022. Later on, makikita may update ako. Meron akong na-encounter just 2 weeks ago na funding din galing from one of the government institution. So the Sustainable Development Goals of the United Nations in the various areas are as shown. So yung research and development must be in line with these 17 goals. No poverty, zero hunger, good health and well-being, quality education, gender equality, clean water and sanitation, affordable and clean energy. Pasok tayo dito. Decent work and economic growth, industry innovation, infrastructure. Pasok din tayo yata dyan. Reduced inequalities, sustainable cities and communities, responsible consumption and production, climate action. Pasok tayo dyan dahil sa mga renewable energies natin. The life below water, life on land, peace and strong institution, partnership for the goals. So the DOE initiative, so nagkaroon po yung DOE ng ganitong Department Circular Memo titled na Providing a National Smart Grid Policy Framework for the Philippine Electric Power Industry and Roadmap for Distribution Utilities. Ito po yung target nila. So ongoing na pong mga ginagawa dito this was done through intensive research and development. Ito po yung mga various areas niya. Smart Distribution Utility Roadmap. Level 1, ganyan. Level 2, Level 3, Level 4, Level 3, Level 4. So sa Level 4 is yung full deployment of AMI. From the various aspect, networks, customer service, convert, and continuous parallel program. So makikita niyo po sa customer service, yung Level 0 is conventional metering. Level 1, implementation of automated meter reading, AMR. Level 2 po is initial implementation of AMI, smart meters, data management system, data centers. meter siya, parang kuha na ngayon eh. Meron nag-a-adapt na yan. Scaling up AMI deployments and full deployment of AMI. So the three areas ng Smart Distribution Utility Roadmap Program ng DOE are the networks, customer service, and continuous parallel programs. The vision of the smart grid vision by 2040, self-healing grid, full RCOA, RPS, GEOP, and net metering implementation. Net metering, integrate po yung mga renewable energy natin. So medyo pa na yan eh, ongoing sa ngayon. Full customer choice, demand response, peak load management, virtual power plants, islanding, optimized ESS, EMS and DER management system, smart homes and cities. The smart grid vision is to transform the Philippine power sector into a secure, stable, flexible, sustainable, digitally enabled, and interoperable system that provides reliable, efficient, and quality energy towards consumer empowerment. So lahat po ito na-realize through research and development. So inline po yan sa ating industry, the electrical engineering. The R&D committee activities we had. So this one, kasi nung 2020 yata, full yung yung COVID, ang pandemic. So nagkaroon lang po ng nagkaroon po ng activity last year. Yung steer dip na tinatawag, inline, kasabay po yan ng ANC natin, 46 ANC. Steer Dip Pro, acronym po yan ng Showcasing Technological Innovations and Resources developed by EE practitioners. Steer Dip. So this was the topic discussed. So nagkaroon po yan ng forum. Forum lang po dahil hindi naman maka face-to-face nung that time. So kaya nagkaroon lang po ng forum. Normally, nagkakaroon po ng research and development contest yan annual. So the last year, hindi siya ma-realize. So forum lang pong ginawa. The topics presented were as follows. Use of collaborative robot for smart factory. The UBGI map, engineering control measure device for floor surfaces. Ito po related po to sa current situation ng country, yung COVID po. And then development of local mass transportation, the hybrid electric train. Relay logic trainer with transistor logic used sa schools po, simulation. Innovation works for the people, the role of engineering in sustainable development. Selection of deep neutral network for leaps components. Electric vehicle fast charging, charging in minutes technology. Maganda po ito. Pico hydroelectric generation with 3D printed impellers presented by our chairman. So that was a successful event ng ANC, initiated by the Research and Development Committee for 2021. So mga attendees po dyan is around 700 plus eh. Success, ganda po, dami. So maganda yung interaction, mga questions na ginawa. So sample po ng entry form for the contest ng Electrical Engineering Faculty Research Contest. So open po ito sa mga state universities, private man or including the private schools. Ito po yung forms. Instead, we will be doing the updates later sa 47th ANC natin kung possible po yung research contest. So mag-update lang po kami niyan. And then, ito po yung format and content guide. So pag meron po kanyo, kung kailangan nyo po ito, kung meron na kayong mga idea dyan, mamaya may contact person po tayo, yung secretariat natin, nandun yung email niya to make queries for this. Open po yan sa mga sa mga schools natin sa academe. Sa mga private practitioners, pwede rin yan. So ito yung sinabi ko kanina in line with the present situation ng country natin, which is we are experiencing the pandemic. Actually, this project was realized 2020. 2020 po siya. Dahil nung 2020 po sana, yung NMYC was supposed to be hosted by the Iloilo chapter. So, January, okay na kami doon. Meron mga planning, pumunta na kami. Preparado na talaga. And then, suddenly, nung March 14 yata yun, nag-declare ng lockdown. Swerte ako, nakauwi ako. I was in Manila on that day, a day before the lockdown. So napauwi ako ng Iloilo. So ito po yung dinevelop ng through the effort ng Iloilo chapter supported by the 2020 Research and Development Committee. Kuan po siya, UVGI map kung tawagin, ultraviolet germicidal irradiation map prototype. UV, yung UV light po ba? Yung UVC. Kasi yan is nag-exterminate po yan ng mga viruses. So ang ginawa diyan is we did this. Napansin kasi namin mostly sa hospital pag pumunta ka, continuous po yung cleaning ng disinfection ng mga floors nila. Sa malls, ganun yung ginagawa, pinupunasan, minamap, ganun, no? What if kaya gumawa tayo ng something na very siya, simple lang, madaling i-maintain. So ito ang ginawa, dinevelop namin. Ang prototype po is nandito po sa akin. This was supposed to be applied for patent. Pero siguro it will be funded by the DOST. Meron naman pong application diyan kung gusto niyo i-fund. So, ayun, the problem, identify the problem, the solutions, and then do the calculations. So, due for clinical testing naman siya. Actually, pag tinest mo to yung surface, kunan mo ng sample, swab mo siya, test mo kung may may virus doon, and then ipadaanan mo ng UV map, and then swab ulit, retest kung effective siya. So, nasa due for na siya for clinical testing. We were supposed to host the 2020 NMIC, pero nung 2020 po, medyo kwan yun. Kwan pa talaga, grabe yung COVID. So ito yung sinabi ko kanina na opportunity updates. If the OST has funding na around 300 million, ito naman pong nilabas ni NEDA, DVM, Joint Memorandum Circular 2022, last May 31 lang, 2022. Addressed to all heads of departments, agencies, bureaus, offices, commissions, state universities, and colleges, government-owned and controlled corporations, other instrumentalities of the national government, and all others concerned. Ewan ko yung others concerned dito, pwede din ng private. But the subject is implementing guidelines on the use of the 200 million Innovation Fund under Republic Act number 115/18, otherwise known as the General Appropriations Act of 2021, pursuant to, in reference to RA 11-293, otherwise known as the Philippine Innovation Act. So may opportunity talaga sa atin, especially sa academic side. Open ito. The joint memorandum JMC was issued last May 30-31. Tapos yung deadline ng proposal, yun nga lang, nakalagay dito extended siya until July 15, 2022. So sa mga academic dyan na side, baka may mga contact kayo sa NEDA, regional offices, pwede nyo itong i-inquire kung meron kayong mga kwan. Kasi entitled dito, under Section 7, Funding Threshold and Limitations, grants should not exceed 30 million if the scope of implementation of the project is national. Number 2, grants should not exceed 15 million if the scope of implementation is regional or interregional. And number 3, grants should not exceed 7.5 million if the scope of implementation is local or through LGUs or SUCs. Kung i-search nyo lang ito, yung nasa academe, state universities and colleges, pwede nyo itong makita sa website ng DOE and NEDA and DVM po to go over with the one. I don't know lang kung if yung extended na proposal nila na acceptance sa metals, kung na-extend pa po. The budget is 200 million. So kung merong project yung school na ganito, meron silang gustong i-fund, i-apply lang. So ito yung sinasabi ng mga opportunities po. So marami po talaga ang mga possibilities kung meron kayong mga ideas, put into realization. The R&D committee of the IIE is in support po sa inyo. The logo of the R&D, yan po ang logo. The circle represents star continuity and infinite. Bulb is idea innovations. Continuous po. Continue lang ba? May mga idea kayo. So, upgrade or what develop. Ano yung problema? Solve natin. Ganon. Interesting po. So, very encouraging. Welcome po kayo lahat, mga fellow members, through the R&D committee natin. So, the race represents the 11 chapters of IE glowing. The IE logo represents the patrons. Tayo po. Tayo pong mga member ng IIE. The green background sa para po sa nature, health, and growth. So that ends my presentation. Nandito po yung email address, ang contact person po natin sa R&D committee, si Ma'am Maika. Yan po ang email address niya. Kung meron po kayong mga queries, please feel free to contact lang po. Mag-email lang po sa kanya. It will be relayed to the committee. So that ends my presentation po.
Okay. Thank you, Sir Biton. That is very interesting.
Okay na po, sir.
Now, may I call yep, very
Sir
nice
Robert.
presentation. Yes, sir. So, there are no questions here, so we proceed to the awarding of certificate. May I call in Engineer Louis Rotilia to award the certificate. Sir Louis. Sir Louis.
Hello? Okay na po, sir.
Okay. Sige, sir. I'm waiting for my colleague to award the certificate to you, sir. Sorry for the delay, sir.
Sorry din po sa may technical glitch dito.
Yun nga.
Kanina pa ako naantay dito siguro. Nag-overheat yung laptop. Sige, sir.
Oo.
Actually, yung chairman natin ng R&D, sir, nandyan yan sa Cebu, sir. Si Sir Nelson, nandyan yata sa Cebu ngayon. Yung chairman natin ng R&D.
Okay. So, he will be joining us.
I don't know kung baka mag-drop by siya.
What about you, sir?
Baka,
Are you coming here?
Ay, hindi. Alanganin na. Iloilo.
Okay.
Oo. Kasi kung...
It will be an honor.
Sige lang. Next time siguro. Oo. Kasi virtual lang naman. Hindi na lang ako pumunta. Si Sir Nelson Andes. Ngayon yata today nandyan.
Yeah.
Oo. Kasama sila ni Press.
Okay. I hope he can drop by our...
malamang, sir.
That's nice.
Oo, malamang, sir.
Okay, malamang pupunta siya doon sa conference.
Oo.
Hold on for a while, sir, ha? Hold on.
Okay, sir.
Okay. Sir Lowell.
For a while, sir. Maybe we can entertain some questions, sir. If there are questions in the chat box.
There are none.
Sir Bob?
There's none, sir.
Or there's none? Okay. Okay, so
there's no inquiry.
So IIE Cebu chapter awards this plaque of appreciation to Alan S. Biton, technical resource speaker on the topic promoting research and development culture among EE practitioners in the 21st Eastern and Central Visayas Regional Conference held on 27th to 30th day of July 2022 via hybrid at the Sky Hall A&B SMC side South Road Properties, Cebu City. Given this 27th day of July 2022. Signed, Magdaleno M. Baclay, President, IIE Cebu Chapter, Ronmar Gonzalez, VP Technical Affairs, Brian Pasilan, Regional Governor, Eastern and Central Visayas, Erwin J. Salvador, Technical Consultant and Advisor. Congratulations.
Thank you po, sir. Saka Sir Brian Gob, thank you po sa host. Thank you very much po sa opportunity. Maraming salamat po, sir.
Maraming salamat po, sir.
Thank you. Thank you, sir. Thank you, sir.
Sir Bob, request din kami ng slides ni Sir Biton, sir. Special request ko, sir. Sir Alan.
Ako lang ikuan sa Biton. Ako natawag. Wala ko pangayo, sir.
Nandito kasi Sir Alan. Sir Alan, nandito pa.
Sir Alan. Sir Alan. Sir Alan. Are you still here, Sir Alan? Sir Alan.
Sir, ako ba po? Ako po ba, sir?
Yes, Sir Alan
Ah, yes.
Dixon. So here's a request from my colleague, sir. Go ahead, sir.
Sir.
Sir Alan, special request ko sir, pwede makahingi ng mga notes or slides mo sir?
Ng ano, sir?
Yung slides or notes.
Slides.
Yes sir.
Sige. Ikuan lang sir, i-send ko yung email ko diyan para ma-email, ma-email niyo ako and then reply ko po kayo ho. I-send ko.
Sige sir, thank you sir. Thank you so much.
Thank you sir.
Thank you, sir. See you, sir.
Thank you, sir. Thank you.
Thank you, guys. See you tomorrow. See you tomorrow at 8 o'clock in the morning. Please be calm early. Thank you.
Hindi ka ba napapansin?
Okay, good afternoon everyone. Stay for a while for sponsor for a picture taking.
I-promote sa panelists ng paminaw sa kwan. So, while mag-promote pa, mag-kuwata sa videos.
Okay. So we will play our sponsor videos.
I-promote sa panelists para mag-picture. Wait sa i-promote panelists natin.
Wait for a while kaya itong i-promote ang mga attendees for panelists for picture taking. Okay, stay tuned. Hello, good evening. Yeah, sorry for the inconvenience. I think we have difficulty on transferring the attendees to panelists. So we will be doing the picture taking in tomorrow, day 2. Okay, once again, thank you everyone.
Mindanao ay kamakaret nagkakawaw. Yeah.
Nalawag pa'y itiranyag kiti aldaw. Sumikat ka ito'y lubong na